Hello everyone, and welcome to the lecture on while loops in Python. In this lecture we'll see how to use while loops. So while loops are used to execute statements, and as long as the given condition is true, it will execute the statements. Let's see a simple example of while loop. When we use while loops, there must be an initial condition, or a condition has to be initialized. So let's say we have a variable x and we'll set it to be equal to 0. So we can say while x is less than 6, let's print x. So in this simple example of while loop, we first initialized our condition, which we set x to be equal to 0, and then we said while x is less than 6, print x, and then we'll say x is equal to x plus 1, x plus equal 1, which is the same as x is equal to x plus 1. So let's print the statement. Let's run it. So we have 0, 1, 2, 3, 4, 5. So we initialized our condition. Then while x is less than 6, print x. So first x is 0. So 0 is less than 6. So this statement, that condition is true. So it will print the value of x, which is 0. And then next it says add 1 to the value of x. So 0 plus 1 is 1. So it goes back to the while loop. While x is less than 6, 1 is still less than 6. So it will print 1. Then add 1 to our current value of x, which is 2. Then it keeps on adding 1 every time it goes in the loop. And finally, when we reach 5, 5 is less than 6. So if we print x, that will be 5 is printed, and then add 1 to 5, which is 6. Then when it goes to the while loop, it says while x is less than 6. 6 is not less than 6. So it will stop executing the while statement. So it's important to initialize our condition, and also it's very important to have this checkpoint after the while statement. What do you think will happen if we didn't have this last statement? X is equal to x plus 1. So what will happen in that case is that 0 will be printed out indefinitely, because the initial condition x is equal to 0, right? And 0 is less than 6. So that will give us print 0. So it will be 0, and then again we'll go back to the while loop. 0 is less than 6. 0 will be printed. So we will run into what is known as an indefinite loop, infinite loop. So we have to be very careful not to run into an infinite loop. So that's how we avoid. So this statement avoids a condition known as an infinite loop. Let's look at another example. X is equal to 0. Then we can say while x is less than 8, we can say print x is, then we can format this, that format, and then we'll pass the value of x. Then finally we'll close out our statement. X is equal to x plus 1, x plus equal 1. Now let's run it. So we have x is 0, x is 1, x is 2, x is 3, 4, 5, 6, and 7. We can format it this way also. We can also use if else statements with our while loops. We could have said this also. Let's see. X is equal to 0. We could have said while x is less than 8, print x is, we'll format it again, that format, then we'll pass x, then we have our x plus equal 1. So this is the while part. Else we can say print, we can say x is no longer less than 8, less than 8. Let's run it. So we have x is 0. When x is 0, since x is less than 8, so x is printed. This statement is printed. X is 0. And then 1 is added, goes back to the loop. 1 is less than 8. X is 1 is printed. Plus 1 goes back to the loop until it reaches to 7. And 7 is less than 8. So x is 7 is printed. And then 7 plus 1 is 8. Goes back to the loop. It says, is 8 less than 8? No. So it will get out of that loop and then execute the else statement, which is x is no longer less than 8. That's what we have here. X is no longer less than 8. Okay, let's look at another example. Let's say x is equal to 8. We can say while x is greater than 1, we can say print x is, then we'll format it again, that format value of x, then what we'll do this time is x is equal to x minus 1. X is equal to x minus 1. Okay, let's see what we did. While x is greater than 1, print x's, then value of x. So our initial value is 8. 8 is greater than 1. So x is 8 will be printed. Let me run it and show you. X is 8, and then x is equal to x minus 1. So subtract 1 from the current value of x, which will be 7. Goes back to the loop. 7 is greater than 1. So print x is 7. Then take 1 or subtract 1 from the current value of 7. And then 6, 5 until it gets to 2. When we reach 2, 2 minus 1 here is 1. 1 is no longer greater than 1. So our while loop is terminated here. We could have added an else statement. So let me copy that, paste it here. And then we could have added an else statement. Could have said else print x is no longer greater than 1. So finally we have the else statement executed. X is no longer greater than 1. These are some examples of how we can use the while loop, and in the next lecture we'll continue with while loops. Thank you everyone. Hello everyone and welcome back. In this lecture we'll continue our discussion on while loops. In the previous lecture we saw how we could use while loops, and we mentioned that initializing our condition is important, and we also mentioned that it's very important to check the last condition so that we don't run into an infinite loop. In this examples we saw that we added or subtracted a value from our initial value of x so that we don't run into an infinite loop after each value of x. while conditions or while statements are commonly used with break and continue statements. So we'll see how we can use this break and continue statements with our while loops. Let's look at an example. Let's say we have a list of menu. Let's say, and then save it in a variable called menu. Let's say we have a list containing yogurt, say salad, chicken, fruits, and meat or beef. What we'll do next is we'll use a while loop to choose any one of these values. Let's see, we can say, so first let's initialize our condition, and let's call it chosen menu or food. You can name it whatever you want. So we'll make an empty list, an empty string. Then we can use our while loop. So we can say while our chosen menu not in our menu, we can say chosen menu is equal to raw input choose a menu. So we'll prompt the user to choose any of these strings in our list, in our menu. And let's add an if condition. We can say if chosen menu is equal to none, we can say print I am not hungry. Then we can break. Let's add an else condition. Else print I can't wait till, let's see, that format, and then we can use our chosen menu. Okay, so I can't wait till our chosen menu is served. Okay, let's run it. So I'll run it first and then show you what this code will do. Run it, says choose a menu. Let's say yogurt, enter. It says I can't wait till yogurt is served. I just wanted to show you one statement here while I explain. So we started by defining a variable menu. It's a list containing this strings, this values, and then we initialized our condition chosen menu is equal to an empty string, and then we said while chosen menu is not in menu. So we defined chosen menu earlier. Now we are checking if chosen menu is not in menu. So here it says while chosen menu is not in menu, it says chosen menu is equal to raw input choose a menu. So we are prompting the user to enter or to choose from a menu. And then if the user chooses none, it says print I'm not hungry. So if the user types none, this will be printed out, and then we'll break out of this loop. If the user doesn't choose none, this else condition will be printed. And it says, I cannot wait till whatever we choose is served. In this case, the break continue serves as breaking the while loop. So whenever the chosen menu is equal to none, we will be breaking out of our while loop. Okay, let me run it again. So choose a menu, let's say salad, enter, I cannot wait till salad is served. Now let's choose none. Run it, choose a menu, none. In this case, we'll break out of the while loop. Run it, says I'm not hungry. Okay? Only when the chosen menu is equal to none that this statement is printed. I'm not hungry, and then we break out of that loop. Let's look at another example. Let's say we have a variable x, and let's set it to be equal to 5. We can say while x is less than 12, we can say print x is, let's format it, that format, then let's pass x, then let's say x plus or equal 1, so we'll add the value of 1. Then let me show you how we can use the if statement, if the continue statement. If we can say x is equal double equal to 10, we can say print x is still less than 12. Then we can have a continue statement. Else we can say print x is no longer less than 12. Okay, let me run it and show you. So here it says initially the value of x is 5, while 5 is less than 12, print x is 5, so 5 is printed, and then add 1 to the value. This will prevent an infinite loop. So 5 plus 1 is 6, and then it will go back to this if condition. If x double equal to 10, which is not true, so we go back to our while loop here. 6 is less than 12, it goes here, and so on until we reach to 9. So x is 9 is printed, and then 9 plus 1 is 10. So here we have an if condition saying if 10 and 10 are equal, it says print x is still less than 12, and then continue. So x is still less than 12, and then continue with your while loop. So we go back here, and then 10 is less than 12, so the statement is printed, x is 10, and then 1 will be added, which will be 11. So x is 11 will be printed, and then 1 will be added, which is 12. Is 12 less than 12? No. So this else statement will be printed, and it says x is no longer less than 12. This is how we can use continue statement. We can check a certain condition, and then if that condition is true, we can go back to our while loop and then execute the statement. Okay, whereas the break statement will stop the execution. It will break out of that loop. Let me take the same example and then show you with break statement. So instead of continue here, let's say break. X is still less than 12, but exiting the loop either ways, let's say. So here, while x is less than 12, so when x is equal to 10, it says break out of the loop. Let me run it and show you. So here, when we reach to 9 plus 1, 10, and then if x is equal to 10, print x is still less than 12, but exiting the loop either ways. And then we have the break statement. The break statement means we are breaking out of that while loop. So we won't even have a chance to execute the statement, right? Because we haven't gotten to a point where x is less than 12. That's because while x is equal to 9 here, 9 plus 1 is added, so x is 10 here, and then we are breaking out of this while loop while x is equal to 10. So the break statement stops the execution. So the break statement will stop processing after that condition. Whereas with the continue statement, it forces the execution to move on, to continue. So that's the difference between continue and break state. Continue and break. Great. To summarize, we saw some more examples of while loops and how we can use the break and continue statements with while loops. We mentioned that the break statement will stop the execution of the statement when the condition is met, whereas the continue statement will force the execution to continue. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on while loops. In this lecture, we'll talk about infinite loops. So it's very important. We mentioned that it's important not to run into infinite loops while using while loops. So infinite loops occur when the condition is always true. So in this case, the condition will never be false. So that will lead to an infinite loop. So while using while statements or the while loop, it's very important to check your code and statement and see if there is any possibility of running into an infinite loop. Usually at the end of the statement, check conditions to increase your initial value by 1 or decrease it by 1 depending on your initial value. It's very important it's very important to avoid this infinite loops while using the while statement or while loops. And if you run into an infinite loop, just close your program and then open it again. Okay, so I'll show you some examples where we might run into an infinite loop and to avoid them. We have seen this briefly in the previous lectures. Let's look at a simple example. Let's say x is equal to 5. We can say while x equal to 5, let's say print my lucky number is, let's format it, that format x. So here in our initial condition, x is equal to 5, and in our while statement we are we are checking if x is similar to 5. In this case, they are similar, so it will print my lucky number is 5, and then again it will go back to the while condition and then print x, which is again 5. So my lucky number is 5 will be printed indefinitely, because in this case our condition will never be false. So that will lead into an infinite loop, and this my lucky number is 5 will be printed indefinitely. So another thing to do, one thing to do to avoid this indefinite loop is after our while statement, so we have here print my lucky number is this. After that we need to add or subtract or do something with our initial value, so that we check another condition. So in this case we can say x, for instance, plus equal 1. So here first my lucky number is 5 will be printed, and then it will execute this statement, x is equal to x plus 1, so 6, and then it will go back and check if x is similar to 5, which is not. So this statement will not be printed. So if we run this, we only get my lucky number is 5. Great. Let's look at another example. Let's say x is equal to 7. You can say while x is greater than 2, print x is, let's format it, that format, and then the value of x. So here x is equal to 7. So while x is greater than 2, so in our initial case 7 is greater than 2, so it will print out x is 7, and then it goes back to the loop. So x is still 7 and 7 is still greater than 2, so it will again print out x is 7. So that statement will be printed indefinitely, since the condition, this condition, will never be false. In this case we need to add another statement, right? Increase or decrease the value of x accordingly, and make sure to evaluate what you add. For example, in this case I am saying x is equal to x plus 1. So I'm adding 1 to the current value of x. Initially x is 7, and then it will print out x is 7, and it will add 1 to the current value of x, which is 7. So it will be 7 plus 1, 8. And then it will go back to the while loop. 8 is greater than 2. It will print out x is 8, and then it will add 1 to the current value of x, which is 9, which is 8. 8 plus 1, 9. Goes back to the loop and then print out 9, and so on. So in this case, this will also run into an infinite loop, right? Because the condition will never become false, will never be false. So make sure to what you add here, make sure to evaluate what you add here before running the statement. So in this case, subtracting 1 will make sense. So we start with a value of 7, and then x is 7 will be printed, and then we subtract 1 from the current value of x, which is 7 minus 1, 6. 6 is greater than 2, and then we subtract 1 from 6. 5 is greater than 2, and then 4, and then 3. When we reach to 2, 2 is no longer greater than 2. And at that point, the statements, the while loop will no longer be true. Okay, so if we run this, we get x is 7 all the way up to x is 3, and then this while condition is no longer true, so we exit out of the loop. And that works the same with if and else conditions. Okay, in this example we can add else print x is no longer less than, or x is no longer greater than 2. Run it. So finally we have x is no longer greater than 2. So it's important to check and evaluate those conditions. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome back. In this lecture we'll see an example of the continue and break statements in while loops, and later on we'll see how we can use the break and continue statements with for loops. Let's start by creating a dictionary. Then we'll save it in a variable called menu. Let's say our menu has, so we'll pass key and value combination. Let's say salad as key, and for value we'll pass, let's say vitamin. Let's pass another key and value combo, say potato, and then for value we'll pass carbohydrate, let's say chicken. For value let's pass protein, and then one more thing, let's say yogurt, and for its value we'll pass mineral. What we will do is we'll prompt the user to choose from this menu list, and then if they choose none, we'll use a break statement to break out of our while loop. If they choose any of these values, we'll print out those values. Okay, so let's start. We'll say while true. We can say while true, let's say menu choice is equal to raw input, and then let's say what would you like to have. So we prompt the user while true, menu choice, raw input, what would you like to have. If you are using Python 3, you can use the input function, and then what we'll do is while the condition is true, we'll see if menu choice is equal to none. So if they choose none, we'll break out of the while loop, and if menu choice, or if menu chosen is in our menu, we'll get our menu choice. So what we will do is menu, we'll use the get function, menu.get, and then we'll get the menu choice. We'll pass menu choice. So we'll be getting the keys from our menu dictionary. So menu.get, menu.get, menu choice, and then we'll print out what they chose. And let's save this in a variable called, let's say, food. Then we can simply print food. Now let's have our else statement, else print we don't have, let's say, plus menu choice. If they choose something else, we'll print out we don't have that chosen food. Okay, let's run it and see. It says, what would you like to have? I would like to have, let's say, salad. Enter. So salad has vitamin. What would you like to have? Let's see, potato. We do not have potato, so I misspelled it. Let's type it again, potato. Run it. So it has carb. See the keys, the value is printed out. Then what would you like to have? If we choose something else, let's say beef, it says we do not have beef. What would you like to have? Then if we choose none, that will break out of the while loop. Okay, so let me explain what this code does. So we have our menu, key and value combo. While true, we have our menu choice statement. Here we are prompting the user to enter a selection. And once we enter that, if whatever the user enters is equal to none, so we are comparing what the user inputs to this value none. And if the user inputs none, we are breaking out of the while loop. If not, we are going to this if condition. If menu chosen is in menu, so whatever the user inputs, if it's in our menu list, what we do here is menu.get the menu choice. So we'll be getting their choice, and then it will print out what we have gotten. So it will print out the values from our dictionary. So we ask the user to input a value. So basically the user will input the keys from our dictionary list, and then we use the keys entered to get the value here. So the value is printed. And if the user enters anything that's not in our menu list, this else condition will be printed out. You can say else print that, or in a new line we can print it out here. Else print we don't have plus menu choice. So whatever the user enters will be printed out. We don't have this. Okay, so this is an example of how we can use the break statement. Let me run it again. What would you like to have? Yogurt. Run it. So mineral. What would you like to have? Do we have water? No, we don't have water. What would you like to have? I would like to have a salad. Enter. So vitamin is printed, which is the value for that. And finally, if we enter none, that will break out of the while loop. So none. Now we are out of the while loop. So this is how we can use the break statement. And I also mentioned in the beginning that we can use the break and continue statements with for loops. Let's see an example of that. Let's say we have a list containing foods, and then we'll save it in a variable called menu. And let's say our menu has potato, beef, chicken, salad, yogurt, and let's say cheese. So we use a for loop. We can say for food in our menu, we can say if food is equal to salad, we can say break. Otherwise, let's print please bring me plus food. Okay, let's run it and show you what this will do. So run it. Says please bring me, let's have some space here. Run it again. Okay, please bring me potato, please bring me beef, please bring me chicken. Okay, what happened here? Let's see. Here we have our break statement. We have our menu here. So for food in menu, so this is for items in our menu. For food in menu, if our food, we are comparing food here to salad. So if food is equal to salad here, we are breaking out of the loop. If not, this statement is printed. Please bring me and whatever the food is. So this for loop will take each of these items in our list and then run it through this if condition. So for food in menu, first it will take potato. It will compare potato and salad. They are not similar, they are not the same, so it will print out the statement. Please bring me potato, and then the second item in our list is beef. Since beef is not similar to salad, it will print please bring me beef, and then chicken. When we get to salad, it says if salad is equal to salad, so salad and salad are similar, so it will break out of, since this condition is true, it will break out of this for loop. So for loop at this point will stop processing since this condition is true. So it will stop processing and then break out of this for loop. That's why we only have potato, beef, and chicken printed out. Now let's see the same example and use the continue statement. So instead of break here, we'll use continue. Now let me run it and show you. So here it says when we get to salad, so the first three conditions, the first three choices are the same, but when we reach to salad, it says if food is equal to salad, continue. So it's saying to continue into the for loop. So in that case, it will continue with the next element, which is yogurt, and then please bring me yogurt will be printed, and finally we'll have please bring me cheese. So here the continue statement, it forces this for loop to continue to the next item in our list. Okay, so when we have salad is similar to salad, then we have the continue statement. So it's telling the for loop, it's forcing the for loop to continue to the next item. That's why salad is not printed here. That's why please bring me salad is not printed. It's forcing the for loop to move on to the next item, which in our case is yogurt. Then please bring me yogurt is printed, and finally cheese. So that's the difference between break and continue statements. The break statement stops the execution, and then it terminates whatever loop we are in, for loop or while loop, whereas the continue statement will force the execution to continue. Great. Thank you, everyone, and I'll see you at the next lecture. Hello, everyone, and welcome to the exercise on while and if statements. In this exercise, we'll build a calculator. We'll use while loops and if loops, while statements and if statements to build a calculator. And we'll present some options to the user. Then we'll perform a basic calculator function. So here are the instructions for the exercise. We'll start out by writing a basic calculator instruction for a user and present a menu with options to add, subtract, calculate modulus, multiply or divide two numbers. Prompt and ask the user what operation they want to perform, and selection must be one of the presented options in our menu. And if the user does not select from the menu, we'll prompt the user to make a valid selection. And then finally, we'll display the result of the operation they selected. And don't forget to display a message if the user tries to, let's say, divide a number by 0. Okay, so take a moment and try the exercise. Great. Now let's see the exercise together. So we'll start out by creating our menu, and then we'll save our menu instruction in a variable called menu. So let's use triple double quotes for presenting the menu. Okay, let's say our simple calculator menu, and let's present some options for our users. Let's say 0, they will press 0 to quit, press, or you can say choose 0 to quit. Let's say choose 1 to add. We can say choose 2 to subtract. Choose 3 to multiply. Choose 4 to divide. And finally, we can say choose 5 to calculate modulus. Okay, so those will be our options for the user. What we'll do next is we'll use while statements to present these options. So if they select 0, our calculator program will quit, and if they don't select 0, we'll ask the user to enter their selection, and then we'll store their selection or choice in some variable. Let's start by doing that. So I'll just save their selection in a variable called choice, and then we'll start by setting it to none. Then we'll use while loops to check their selection. So we can say while choice is not equal to 0, then we'll print out our menu option, and then after printing this out, we'll prompt the users to make a choice from our menu list. So we can say, let's prompt the user by using our raw input function. Please make a selection or choice. Please make a choice from the menu. Okay. If you are using Python 3, you can use the input function instead of raw input. And since this is a string, we'll convert it into an integer by casting it to an integer. So this will convert the input, which is a string, to an integer. Okay, and we'll save this in the choice variable that we created earlier. We started by setting choice to none. Then based on their selection, while choice is not 0, we'll save their choice in our choice variable. Now that we have their choice, let's check if their choice is any of this, right? That's a validation that we need to ensure. Otherwise, we'll tell the user that they have made an invalid choice. So let's do that. We can say if choice is not in range 6, I'll explain that in a moment. You can say print you have made an invalid choice. Then we can make some string formatting, that format, then we'll pass the choice they selected. Then we can continue. Okay, let's see what we did here. So they make a choice, and if their choice is not in range 6, this basically means 0 through 5, right? Range 6 means 0, 1, 2, 3, 4, 5. So those are their options. 0, 1, 2, 3, 4, 5. That's why we used range 6. So if their choice is not in range 6, we'll print out this message. You have made an invalid choice, and we'll present the choice they made. For instance, if they select 7, it will say you have made an invalid choice and then 7. And we'll continue. So it will go back to the while loop, print the statement. So it will keep looping until they might finally make a valid choice. Okay. What if they also choose 0? 0 is also valid. So if choice is equal to 0, make sure it's double equal, because we are checking their input to this. So we are comparing those two sides. We'll also continue. Okay. Next, what we'll do is, so we'll be performing these operations on two numbers, right? So let's create a prompt. Let's prompt those options for the users. So we'll save our first number in a variable called x. They will say raw input let's say enter your first number now. You can say something like that, and then we'll save the second number in a variable called y. You can say raw input. Again, if you are using Python 3, you can use the function input. Okay, raw input, enter your second number now. So here, this is an integer, and we can cast this. This is a string. So the input is a string, and we can convert that to an integer by casting it into an integer. So we'll cast the whole thing into an integer, and then integer. So for this exercise, we are just casting it to an integer, but you can also cast it to a float number. So instead of integer, you can also say, you can also use float. So in place of integer, you can say float. So that will cast it into a float number, floating number. Okay, integer. Now let's use if-else statements to calculate these operations. So if choice double equal to 1, 1 is what? Addition. Choose 1 to add. Okay, so let's perform addition. If choice double equal to 1, if they choose 1, so the result will be x plus y. And let's save this in a variable called result. Result is equal to x plus y. What if they choose 2? So elif choice double equal to 2, result will be equal to x minus y. We have subtraction, and then next we have 3 for multiplication. So elif choice double equal to 3, result will be x times y. And then we have division. Elif choice is 4. If they select 4, we'll perform division. Result is equal to x divided by y, right? And one more thing to note here is that we cannot have 0 for the denominator, so we can use an if statement to display a message if they enter 0 for y or the second number, right? So let's use some if statements. So we can say if y double equal to 0, what will we display? We'll say print error can't divide a number by 0, right? That's if they choose 0 for their denominator. Else, we'll display the result, x divided by y. Okay? And finally, let's take care of the modulus option. So elif choice is equal to 5, which is modulus. We'll simply return the result, which is x modulus y. X modulus y. Again, modulus is similar to division in a sense. We cannot have 0 for our denominator, so we'll apply the same if else condition. So if y 0, we can print error can't calculate modulus when denominator is 0, or we can simply say 0 division error. So you can modify that error message. Okay, so that will take care of all the options. And finally, we need to print out the result. So we can say the result of your operation is, let's do some string formatting, that format, and then result. Okay, now that we have this, let's try out our program. Let's run it. So it says our simple calculator menu, and then we have our menu. Choose 0 to quit, choose 1 to add, choose 2 to subtract, choose 3 to multiply. Okay, please make a choice from the menu above. We can say above. Let's say we choose 1. Enter. It says enter your first number now. 4. Enter your second number now. 6. That should give me 10. 4 plus 6. So the result of your operation is 10. We can add a colon here. And let's add, please make a choice from the menu above. Okay, let's run it again. Let's run it again. Our simple calculator menu, please make a choice from the menu above. Let's choose 1. Enter your first number now. Let's say -3. Enter your second number now, and 5. So -3 plus 5 should give us 2. So the result of your operation is 2. And then our simple calculator menu is printed out. Please make a choice. So let's subtract now. 2. Enter your first number. Let's say 8. Enter your second number. 8 minus 5. That should give us 3. Okay, the result is 3. Great. Next, let's choose to multiply. So I'll choose 3. Enter your first number. Let's say -2 times -3. That should give us 6. Enter. So the result is 6. Now let's do division. Let's choose 4. Enter your first number now. Let's choose 6. Enter your second number now. Let's choose 5. Run it. So 6 divided by 5 is 1. So this is not doing true division, so we need to import division from the future menu. Okay, please make a choice. Let's quit. Choose 0 to quit. So 0, enter. So the program quit. What we'll do is let's import division from the future module. Okay, so import and say from __future __ import division. If you are using Python 3, this is not a problem, but if you are using Python 2 like me, we need to import division so that we can get the true division result. Okay, and as I said earlier, you can also cast your input into a float. Okay, let's run our program again. Okay, please make a choice. Let's do division. So we'll choose 4. Enter your first number now. Let's enter 7. Second number, let's say 5. So we get the true division result now, 1.4. Let's do a division again, 4. Enter your first number, let's say 5. Second number 0. That should give us the error. So it says error, we cannot divide a number by 0. So the menu is printed again, which is good. Now let's do modulus. Enter 5. Choose 5. Enter your first number now. Let's say 8. Enter your second number now. Let's enter 6. So this is 8 modulus 6. The result should be 2. Run it. So the result of your operation is 2. Again, with our modulus function, we should get an error if we enter 0 for the second number. So let's choose modulus again, 5. Enter your first number, let's say 5. Enter your second number now, 0. So that gave us a 0 division error, right? Integer division or modulus by 0, which is good. Okay, next, one more thing we haven't checked is if we enter anything, if our choice is different from any of these numbers, if it's not in the range 0 to 6. Let's check that. Okay, please make a choice from the menu above. Let's choose 8. Run it. It says you have made an invalid choice 8. Please make a choice from the above. If we enter something else, let's say 6, we still get you have made an invalid choice 6. So this is just a simple calculator function program that can, add, subtract, divide two given numbers. Okay, let's summarize our program. Okay, let me quit here. Okay, we started out by displaying a menu for our user, and then we started by setting the choice to none, and then we used the while statement to calculate their choice. We said here if choice is not equal to 0, print our calculator menu, and then we prompt the user to make a choice from the menu, and if their choice is not equal to 0, that means if they don't want to quit, what the first thing we did was to check if their choice is in the menu. So if choice is not in range 6, so if the choice is not in the given menu, we print this message saying they have made an invalid choice, and then we used the continue statement to loop back in the while loop and then present the menu again. So this will keep looping, asking them to make a valid choice again and again. Okay, and if they choose 0, it will quit the program, and once they make a valid choice from the menu displayed, we ask them to enter a first integer, a first number, and then we converted that into an integer. You can change this to float so that you can make calculations with floating numbers. And then we prompt the user again to enter a second number. And once we have that, we used if-elif statements to perform the operation they want. So if they choose two odd numbers, we'll display the result of the two numbers. Then we have here for subtraction, multiplication, and division. One thing we did with division was that if they enter 0 for the second number, which is the denominator, we displayed this error message saying cannot divide a number by 0. If not, we display the result, the first number divided by the second number. And same thing for our modulus function. If they choose 0, we print a message saying cannot calculate modulus when denominator is 0. Or here we forgot our else statement. So let's add our else statement. Else the result will be x modulus y. And then finally we present the result of their operation. Okay, let's run it one more time. Let's do modulus. So select 5 and then enter your first number now. Let's say 5. Enter your second number 0. So it will say error, cannot calculate modulus when denominator is 0. So if I enter 5 again, enter your first number now. Let's say 6. Enter your second number. Let's say 5. Modulus should be 1. And if they also try to divide by 0, they'll get an error. Enter your first number. Let's say 8 divided by 0. Error, it says error, cannot divide a number by 0. This is the exercise I have for this lecture. Thank you everyone, and I'll see you next time. Hello everyone, and welcome to the lecture on functions in Python. In this lecture, we look at what functions are and how we can create functions. Functions are a group of organized codes with a name, and they can be called using a parenthesis. And these codes in a function are reusable. Once we create a function, we can use the codes inside our function as much as we want. That way we don't have to recreate another code. So that's one of the features of functions. The codes are reusable. Let's see how we can create a function. We create a function by using the def keyword. So def space and then function name. Then we have parentheses followed by a colon. Then new line, indentation, indent, and then body of our function code goes here. So this is the general format of a function. We start our function definition with the def keyword, def space name of our function. Then we have parentheses, colon, new line, indent, and then body of our function goes here. So in this parenthesis, we can pass one or more arguments for our function. Go inside this parenthesis and we can have 0 or more arguments. We'll look at arguments later on. So these are optional arguments. We can have 0 or more arguments. So function name here is name of the function, and we use that for identifying a specific function. And usually we give it a name that portrays what the function does. For instance, if our function multiplies two numbers, we'll give it a name. Let's say multiplier or multiply or something like that. We give it a descriptive name, or a name that describes the functionality of the specific function. And then these arguments, they are also called parameters. So the names are used interchangeably, arguments or parameters. These are things that are accepted from the caller. So whoever is calling these function names, these functions, pass those parameters or arguments. And they appear in this parenthesis. And then we have the body of the function that contains the organized codes for our function. Great. Next, let's create a simple function. Okay, let's say we have our def statement, and then we have our function name, then our parentheses. As I mentioned earlier, we can have 0 or more parameters. So we'll just have no parameters for this example. Then let's say our function prints body of our function. Okay. So this is a simple function that simply prints body of our function. And in order to call our function, we simply write our function name. So in this case, this is our function name, and then we put parentheses. Notice that our function name, when we call our function, the function name has to be at the same level as the def statement, as the def keyword. They have to be at the same level. So we have function name, empty parentheses, and then run it. We get body of our function. Okay, so this is a simple function that accepts no parameters. Now let's take the same function. Let's say function name, and then we have that, and let's simply print body goes here. Now let's pass one parameter into our function name. So we can pass any parameter, let's say x. So in this example, our function accepts one argument or parameter. So that means when we call our function, we have our function name, and then we pass, since it accepts one parameter, we can pass it. So we can pass any parameter we like. I can pass 4, for instance, and then that will print body goes here. I can even call my function and then pass any other parameter, let's say 8, and then run it. Body goes here. I can say function name and then pass, let's say a. Body goes here. So it accepts one parameter. What do you think will happen if I simply call my function without passing any parameter? So this will give me an error. Let me run it and show you. So here it says function name takes exactly one argument, right? Argument means parameter, and we only gave it 0 arguments. So that's the error. Okay, and then we can give it one argument here, run it, and the error goes away. Next, let's create a function that subtracts one number from another. Okay, we have our def statement, and then let's give it a name. Let's say subtract. Then we'll pass two arguments. Let's say x and y, colon, then new line. Let's say print x minus y. Okay, so this function accepts two arguments or parameters, and then it prints the first parameter minus the second parameter. Okay, now let's call our function. To call our function, we just simply call the function name, which is subtract in this case. And then since it accepts two parameters, let's pass, let's say 12 and 5. Then run it. We get 7 back. So in this case, the first parameter is 12 minus the second parameter is 5. 12 minus 5 is 7. What if I put 5 minus 5 and 12? 5 and then 12. So in this case, the first parameter x is 5. So 5 minus y is 12. So we'll get negative 7. Let's see one more function definition. Define function, and let's call it greet. Then we'll pass a parameter, let's say x colon, and then new line, let's print hello plus x. Now let's call our function greet. Then let's pass, since it accepts one argument or parameter, let's pass that hello, let's say Python, and run it. So we get hello Python. Let me put some space there, run it again. We get hello Python. Great. To summarize, we saw what functions are and how we can create functions, and we looked at arguments and how to call a function. In the next lecture, we'll continue our discussion on functions. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we'll look at the difference between print and return statements, and we'll continue our discussion on functions. When we create and use functions, we use this print and return statements very often, and we'll see the difference between those two. So before I tell you about the differences, let's create a function. Let's look at the function that we created in the previous lecture. Subtract, the function that subtracts two numbers. And it accepts two arguments or parameters, let's say x and y. The last time we said to print x minus y. And let's create another function. Define subtract, takes two parameters, let's say, or arguments x and y, and this function returns x minus y. Okay. And as we said earlier, we can call a function by simply calling the name. So in this case, subtract, it accepts two arguments, let's say 4 and 3. Then run it, we get 1. Now let's call our function, our second function, which returns x minus y. So subtract, and let's pass 4 and 3. We get 1. So both functions, we get the same result, right? This one gave us 1. The function with the return statement also gave us 1. One thing we can do with functions is we can save our functions in some variable. Let's say we save this in a variable called a. We can say a is equal to subtract 4 and 3. And if we run it, we get 1. And let's say we call our variable a, which in turn calls our function subtract. So if I call A and run it, we don't get anything, right? However, if I say print A, I get none. Now let's look at our second function, which returns x minus y. Similarly, let's save this in a variable called b. B is equal to subtract 4 and 3. Okay, now I'm going to call b. If I call b, I get 1. However, when I called a earlier, the output was nothing. I didn't get anything. Whereas if I call b, I get 1. I get the output. So that's one difference between print and return statements. In case of print, it takes a Python object and outputs a printed representation of the object in the output window. That's what we saw here, right? It takes the output and then prints it. That's the print statement. Whereas a function that returns a value, which is this, a return statement. So a function that returns a value is producing a value for use by our program. In particular, we can use that return statement in our code where the function was invoked. And we can save that, so the result of the return statement can be saved in a variable. We can save it in a variable for later use, or we can use it to print the result, right? Or even use it for other expressions. Okay, if we have print statement, all it does is print the output in the output window. But if we have a return statement, we can save the result in some variable and then later call that variable, or we can even print the result as we saw here by simply calling the variable, or we can even use it for further expressions. Let's see an example. So we have the same subtract function and it returns x minus y. So we have subtract 4, 3, 1, and we can save that in a variable. Let's say b is equal to subtract, and we can pass, let's say, 4 and 3. If we call b, that will print out the result. We can use b in some other expressions. Let's say, for instance, we can say b plus 8, and that will give me 9. So the value of b is 1 plus 8 is 9. Similarly, I can say b plus b, I get 2, right? 1 plus 1. So that's the return statement. Let's look at another example to further clarify the difference. So let's say define a function called greet, and it accepts one parameter or argument x. Let's say print hello plus x, and let's define another function called greet, and let's say x accepts one argument, and let's return x. So in case of our second function with a return statement x, we can say greet. So we are calling our function greet, let's say hi there, right? So we'll get hi there. We can save this in some variable called x, and if we call x, we get hi there, right? Since it returns whatever parameter we pass. And we can say x plus, let's say, Python. So that will do string concatenation. So we get hi there Python. So this is how we can use the return statement. It will save the result in certain variable and then later call that variable to get the output, to print the output, right? And we can even use it for some other purpose. We can use it in other purpose. Okay, that's the return statement. It stores the result so that we can use it later on. However, with the print statement, we cannot do much of those things, right? Now, if I call the create function, let's say Python, in this case, it will print hello Python. So if I run this, I get hello Python. However, if I store my result in some other variable, let's say y is equal to great, then if I pass Python, run it, I get hello Python. However, if I call y, I'm not going to get anything, right? Because the function that does not return any value there, it simply prints the statement. So we cannot store its value in a variable when we use the print statement. Great. So the difference between print and return statements will be further cleared when we look at more and more examples of functions. We have a few upcoming lectures. We'll talk about functions and we'll be using both print and return statements in our examples, and that will further clarify the difference between these two statements. Great, thank you everyone, and see you at the next lecture. Hello everyone, and welcome back. In this lecture, we'll continue our discussion on functions. Let's start by writing a function that prints out odd numbers from a given list. Okay. So we start with our def statement and then name of our function. Let's say print odd, and then it will accept one argument. Let's say x. So we can say for I in range x, you can say print I. Okay, so we have our function name print odd. It accepts one argument or parameter x, and then for I in range x, print I. So what do you think this will do? If you remember from the range definition, if I say range 1 to 10, this will print out numbers 1 all the way to 9, right? I get a list of numbers from 1 to 9. But I only want, from this range, I only want the odd numbers. So how can we do that? We know that by default, range x means from 1 to x. So we can say 1 and then x, and we can say in step sizes of 2, right? So if I go back to this range function and say range 1 to 10 and in step sizes of 2, that will give me a list of the odd numbers only. So I'm doing the same thing here. So for I in range 1 to x in step sizes of 2, print I. So that will print out all the odd numbers. So we can call our function print odd, and let's pass 15 and run it. We get 1, 3, 5, 7, 9, 11, and 13. We could also say, outside of the function definition, we can say print, and then here are the odd numbers. We can say that. So remember, this print statement is outside of this function definition, so it's independent of that. In this case, this print statement will be printed first. Here are the odd numbers, and then followed by the function call print odd, which will print out the odd numbers between 1 and 15. Let's run it again. So we have, here are the odd numbers 1, 3, 5, 7, 9, 11, and 13. Notice that in this function definition, it only accepts one parameter, right? Or one argument. What do you think will happen if I simply say print, if I call our function print odd and then pass nothing? So if I run that, I'll get an error. It says print odd takes exactly one argument, and we only gave it 0. What if I pass 2 arguments? Here it says the function accepts one argument, x. What if we pass 2 arguments, let's say 12 and 20? Run it. So here it says print odd takes exactly one argument, and we gave it 2. So some errors that can be fixed by looking at the error description and then figuring it out from the description. So in this particular example, our print odd function takes one argument only, but we gave it 2. So we can go back and then correct it by giving only one argument or parameter. Now if we run it again, the error is no longer there. Next, let's look at another example. Let's write a function that prompts a user to enter integers two integers and add those integers and display the result. So what we'll do in this function is we'll prompt for the user to enter a first integer, and then we'll prompt the user to enter another integer, and then we'll add those 2 integers together and display the result. Okay, let's start by the def statement and then name for our function. Let's say add. Okay, and let's prompt the user to enter an integer. So we'll use the raw input function since I'm using Python 2. Raw input enter an integer. If I'm using Python 3, use the input function or method. Instead of raw input, use input. So in Python, for Python 3 users, you can simply say input and then enter an integer. That's the equivalent in Python 3. So this will result in a string, and we need to convert that into an integer, and we can do that by simply casting it into an integer. So this method will convert our raw input, which is a string, into an integer, and we'll save this in a variable. Let's call it number. Okay, and this function will simply return the number. Okay, right now if we call our function, let's say add, what we get is, it says enter an integer. Let's say 4, enter, it returns 4. Okay, so what we have to do is prompt the user to enter 2 integers, right? An integer first, and then we'll prompt the user again, and then we'll take those 2 integers and present the sum. Okay, let's do that. So we can say, let's say print, this function will add 2 integers. Okay, and then let's say, so let's prompt the user. So we'll call our add function, and then let's save this in a variable called, let's say, first integer, right? So that will prompt the user to enter an integer, and let's prompt the user again, and we'll save that result in a variable called second integer is equal to add. We are calling our add function, and then we can save the result in a variable called result, and then we'll add the first integer plus the second integer, which are the 2 prompts. Then we can print the values. Print first integer plus, or we can simply say the sum of the 2 integers is, then plus result. Okay, let's run this. So enter an integer, let's say 5, enter an integer, let's say 6, enter. It says cannot concatenate string and integer objects. Okay, let's cast this into a string since the result is an integer. Okay, let's run our function again. Enter an integer 5, enter an integer 6, enter. So the sum of the 2 integers is 11. Let's run it one more time. Enter an integer 2, enter another integer, let's say 5. The sum of the 2 integers is 7. Okay, just to summarize what we did. So we called our function first, which is our add function, which will prompt the user to enter an integer, and then we saved the result in a variable called first integer, and then we prompt the user again. We save the result in a variable called second integer, and then we added those 2 integers and then store the result in a variable called result, and then we displayed the sum of those 2 integers, right? And since our result variable here is an integer, we converted it into a string by casting it to a string. And then we got the result of our function, which is 7. Great. And in the next lecture, we look at arguments or parameters. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we look at arguments in functions. There are 4 kinds of arguments: required arguments, keyword arguments, default arguments, and flexible arguments or variable length arguments. Arguments are very important in Python. So far we have looked at arguments in function definitions. So we have function and then name of our function, and then we have 0 or more arguments inside the parentheses. So the arguments we've seen so far are called required arguments. That means if we pass an argument in this parenthesis, and then later when we call our function, if we don't pass any argument in that function name, we're gonna get an error. Those are required arguments. Next, we look at keyword arguments. So as the name implies, keyword arguments, we call those when we call our function, and the caller of the function has to identify the argument by passing the parameter name. Let's look at an example. Let's create a function called person, and let's say we have 2 or 3 arguments for that function. Let's pass name, age, and then state. Okay, and that function will simply print name of the person, will print age of the person, and then it will finally print the state of the person. Okay, once we define our function, we can call our function, which is person, and then in keyword arguments, the caller has to identify the parameters. So we can say name is equal to, let's say, John, and then age is equal to, let's say, 45, and then state is equal to New York, and then run it. So we have John, 45, and New York. So this is an example of a keyword argument. The caller has to specify the argument or parameter by calling the parameter or argument name. Similarly, if we look at another example, let's say define, and let's have a function that will subtract 2 numbers. Subtract, let's pass 2 arguments or parameters, let's say num1 and num2, and that function will simply print num1 minus num2. So if we call our function subtract, then num1 is equal to 9, and then num2 is equal to 7. Run it, we get 2. So these are examples of keyword arguments. The caller has to specifically pass or identify the parameter name. Okay, next let's look at default arguments. So in case of default arguments, the function will assume some default value if no value is passed. Okay, let's look at an example. Let's see the same function, define person, and let's pass 3 arguments: name, age, and state. We can make one of these arguments default by setting it to be equal to some value. Let's say state is equal to New York. Okay, and this function will print the name of the person, age, and then state. So in this example, state is a default argument, and we set it to be equal to New York. So if we call our person function person and then pass, let's say, name is equal to John, age is equal to 43, and then state, let's say, DC. In this case, if we run the statement, DC will be printed for state. However, we don't necessarily have to pass state in our function call. So if we only pass name and age, that's absolutely fine in this example. So let me run it and show you. So we get John, 43, and New York. So here in this example, if a parameter or argument is not passed in the function call, the default value of that parameter will be used. That's why we get New York for the state. Okay, so person. However, if we only pass, let's say, name, and then let's say just John, if we run this, we'll get an error. It will say 3 arguments expected, but we only passed 2. Let me run it and show you the error. So we get a type error. It says person takes at least 2 arguments, 1 is given, right? It takes at least 2 arguments, name and age. And this is the default argument. So we have to pass age also. Age is equal to, let's say, 34. Run it now. We're not going to get an error. And as I mentioned earlier, if we don't have a default, if we don't want to use this default value, we can pass state as the third argument or parameter, right? We can say, let's say, New Jersey, and then New Jersey will be printed. So those are default arguments, and we can make more than one of our arguments default. For instance, I can set name to be equal to, let's say, Jane, and in this case, all I need to pass is age. Let's say 33, and the default values for the parameters name and state will be used. So in this example, we got an error. It says non-default argument follows default argument. Another thing while using this default arguments is that all of our default arguments have to come after the non-default arguments. Okay, that's what this error is about. So in this case, age is a non-default argument, so I have to pass the age attribute before all the default arguments. Okay, that's important. Let's run it again. Now we have Jane, 33, and then state is New York. Let's look at one more example. Let's look at our subtract function. Then we'll pass, let's say, num1, num2, and then num3. then we can simply say print num1 minus num2 minus num3. Okay, and let's set num3 to have a default value of 2. Now if we call our subtract function, and let's pass 3 values for our num1, num2, and num3. We can say 7, 3, and 1. Let's run this. We get 3. So 7 minus 3 is 4. 4 minus 1 is 3. So this is an example of using a required argument, right? Because those 3 arguments are required. Or we could have also said num1 is equal to 7, num2 is equal to 3, and then num3 is equal to 1. Example of keyword arguments, we get the same result. And the order doesn't matter. For instance, I can say here num2 is equal to 3. So changing the order doesn't matter. Here num2 is equal to 3, num1 is equal to 7, num3 is equal to 1. It will specifically assign the value for the specified attribute in the specified place. Okay? And this will give us the same result, 3. And if we don't pass our num3 argument, the default value for that attribute will be used. In this case, the result will be num1 is 7, 7 minus 3 is 4, and 4 minus 2 is 2. So if we run this, we get 2. Okay? Those are examples of keyword arguments and default arguments. And in the previous lectures, we have looked at required arguments. And in the next lecture, we'll look at variable length arguments. Thank you, everyone. Hello, everyone, and welcome to the lecture on variable length arguments. So we use this variable length arguments when we are not sure of how many arguments or parameters we want to pass to our function. So in this case, when we create our function, we don't necessarily have to pass all of the parameters. We can use this variable length arguments, and later when we call our function, we can pass as many arguments as we want. So there are 2 kinds of variable length arguments. One is defined by a single asterisk, which is used to pass a non-keyword variable length argument, and the other one is called keyword variable length argument, and it's shown by double asterisk signs. We'll look at examples of this variable length arguments. First, let's look at non-keyword variable length argument. So let's define a function, and I'll just call it ratio, and let's pass argument 1, and then we'll pass another argument, non-keyword variable length argument. It's notified by the star sign, single asterisk, and this function will simply return, let's say, argument 1 plus sum of all the non-keyword variable length arguments divided by let's see here, length of all the non-keyword variable length arguments. Okay, so this is a simple function named ratio, and it takes one argument. Here argument 1 in this case is the formal argument. That means the function definitely takes this argument, and this section is the variable length argument. So the important thing here is not the name, but the single star or asterisk sign. It means that it's a variable length argument. So let's see an example. Now let's call our function. So ratio, and let's simply pass the number 2. So what will happen in this case? Let me run it and show you. We get 0 division error. This is the reason why. So ratio, and then we pass 2 as our parameter. So 2 will be this argument 1. And then since we don't have any variable length argument here, we are dividing the numerator by the denominator, which is length of the variable length arguments. In this case, we don't have any variable length argument, so we are trying to divide by 0. That's why we get this 0 division error. Okay, next let's pass 2 parameters or arguments. Let's say 2 and 4. So what do you think will happen in this case? Let me run it and show you. We get 6. So in this case, it will be the same as saying, so argument 1 is 2, which is 2 plus sum of all the variable length arguments. In this case, we only have one variable length argument, which is 4. So it will be 2 plus 4 divided by length of the variable length arguments. We only have 1. So divided by 1, that's 6 over 1. Okay. What if we say ratio of, let's say, 2, 4, 6, and 8? In this case, argument 1 will be 2, and this variable length argument, the non-keyword variable length arguments, will be 4, 6, and 8. So it will be 2 plus 4 plus 6 plus 8 divided by length of the variable length arguments. So the length of this is what? 3, right? Since it has 3 elements, divided by 3. So that will be what? 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8, 20, 20 over 3. So if we run this, we get 6.66667, which is 20 divided by 3. If you are using Python 2, don't forget to import math. That way you'll get the true division result. Or you can import from __ future import division. You can also do that. You can also do that from __ future import division. That way you get the actual division result. Okay, let's look at one more example. We could also say, let's say ratio. We can pass 2, 4, 5, 6, 7, 8, 9. And then run it. We get 6.833. So in this case, this is our argument 1, and this is our variable length argument, non-keyword variable length argument. So in this case, we have how many elements? 1, 2, 3, 4, 5, 6. We have 6 arguments for this arg. In the example above we had 3. Here we only have 1. So that's why the name variable length. And also the name non-keyword, right? So this is the important thing again, is the single asterisk sign. Non-keyword variable length argument. And this non-keyword variable length argument comes after your formal arguments. Okay? So if we switch the places, you'll get an error saying, this should come after the regular one. Okay, one last example. What do you think we'll get if we simply say ratio and don't pass any parameter? This will also throw an error, and it says ratio takes at least one argument and 0 is given, which is this formal argument, right? That's the required argument. And this variable length argument can take 0 or more parameters. Great. Next, let's look at another example. Let's define a function, and I'll just call it various arguments, and let's pass argument 1 and then non-keyword variable length arguments, and let's say print first argument is, then we can say arg1, and then let's say for arg in arguments, let's print here are the non-keyword variable length arguments. Then we'll have arg. Okay, next let's call our function various args, and let's pass only 2 and run it and show you what we'll get. Run it. It says first argument is 2, since we only have one argument or parameter provided here. Let me show another example. Various args, and let's pass 2, 4, and 6. Run it. So we get first argument is 2. Here are the non-keyword variable length argument 4. Here are the non-keyword, let me add a D here, the non-keyword variable length argument 6. So here we used a for loop to print out each of the non-keyword variable length arguments. For arg in args, print this. So in this case, for arg in 4 and 6, right? Again, it's the asterisk sign that's important. You can name this anything that you like, but in most textbooks and most people use this name args for non-keyword variable length arguments, but you can use any name that you like. Okay, the name doesn't matter, but this asterisk is important. Okay, let's look at one more example. Let's say various args, and let's pass 2, 3, A, C, Python, X, 4, and 5. Okay, let's run it. Here you see that our first argument again is 2, and then the rest of the arguments are our non-keyword variable length arguments. So we can have one variable length argument or many variable length arguments. To summarize, we looked at non-keyword variable length arguments in this lecture, and we saw that we can have 0 or more variable length arguments, and the asterisk sign is important to distinguish that. And in the next lecture, we'll look at keyword variable length argument lists. Thank you, everyone. Hello, everyone, and welcome back. In this lecture, we'll continue with our variable length arguments discussion. In the last lecture, we looked at non-keyword variable length arguments, and in this lecture, we look at keyword variable length arguments. So keyword variable length arguments are defined by double asterisks. It means that it's a keyword variable length argument. And in this case, we have to specify the keyword. Okay, let's look at an example. Let's define a function. Let's say kwargs for keyword arguments. And let's say our function takes two attributes, argument 1 and then keyword arguments, keyword args. Then the name here doesn't matter, but the double asterisk. You'll see this name on textbooks, and people usually use this name, keyword args, but you can use any name that you want. Okay, let's print first argument is, and then our arg1, and we can say for our key in keyword args, print keyword variable length argument. So in this case, we'll have it will be more like a dictionary, since we assign values. For keyword arguments, we say the argument name and then the value, right? So it will be like more like a key and value combination. So we can format this. We'll use some string formatting. That format, first one will pass key, and for our second one we'll pass the keywords arguments. Keyword args at index key. Okay. Now let's call our function keyword arguments, and first let's pass just one argument. Run it. So we get first argument. Let me make it argument. First argument is 1, which is good. Similar to the non-keyword variable length arguments, keyword arguments can have 0 or more arguments. So in this case, we only have one argument. What if we pass, let's say, 1 and another keyword argument? Let's say x is equal to 3, and run it. In this case, we have keyword variable length keyword variable length argument x. So this is our formatting. X is equal to 3 for key in keyword arguments. which is x is equal to, and then the value of x, which is 3. Okay. Next, let's pass a few more arguments, few more keyword arguments. Let's say y is equal to 5, a is equal to, say, Python, and b is equal to programming. So if we run this, we get our first argument, which is 1, the first argument we passed, and then we have this 4 keyword arguments, right? That's the key, and then value, key value, key value. So in our formatting, we have our key, then the value, right? For key in keyword arguments. So that's, which is this, print the key and the value. So again, here the name doesn't matter. You can name it, you can use any name. For instance, I could have said, let me copy this. Let's say argument 1. Here I could have said, let's say KW, and then we can change this to, let's say, for I in KW, keyword variable length argument, print. So we're gonna format it, I the key, and then the value, KW at index I. So we could have said that also. And let's call our function kvar, and then let's pass, let's say, Python x is equal to programming, let's say y is equal to 5, and z is equal to 8. Let's run this. So we get the same result. First argument is Python. In this case, Python is the first argument we passed is our formal argument 1. And then the rest of the arguments are our keyword variable length arguments. First one, y is equal to 5, x is equal to programming, and then we have z is equal to 8. So keyword variable length arguments. The most important thing is the double asterisk, right? That's what is important, not the name here. This example is just to show you that we can name it whatever we want, but we have to be consistent, right? Good. Okay, next thing I want to show you is, what if we have both keyword argument and non-keyword arguments in our function definition? Okay, let's look at that example. Let's create a function. Let's call it keyword. Let me simply call it all arguments. That means keyword, non-keyword, any kind of argument. Okay, and let's pass 3 parameters, argument 1, and then non-keyword variable length arguments. Then we have our keyword variable length arguments, and let's say the function simply prints first argument is, then argument 1, then we can say for arg in args, this is for the non-keyword variable length arguments, we can say print, here are the non-keyword variable length arguments. Then we can have our arguments, and let's have a for loop for the keyword variable length arguments also. Let's say for key in keyword variable length arguments, let's print here are the keyword variable length arguments. Okay, and again we'll format it using string formatting, the dot format method. Then we'll pass key, then keyword variable length arguments at index key. Okay, that looks good. Now let's call our function all args. Then we can pass values like, let's say 1, 3, 5, 7, 4, 6. Let's say x is equal to Python, y is equal to programming, z is equal to keyword argument. Okay, let's have those and run it. So the first one, as always, is our formal keyword, our formal argument, the required argument. Then we have, so the next 1, 2, 3, 4, 5, the next 5 arguments are our non-keyword variable length arguments, right? And then the last 3 we have our keyword variable length arguments. Here are the keyword variable length arguments, the key and value, right? Key and value. Okay, this is to show you that we can have all these arguments in the same function. And as always, we can have 0 or more arguments for this variable length arguments. For instance, if I have only one argument, let's say Python, that's absolutely fine. And we only get first argument is Python. That's why these arguments are important. If you are not sure how many arguments you want to pass when you define your function, you can use this variable length arguments to define your function. One last thing I want to mention is that when you have all these arguments, it's important to state your keyword variable length arguments at the end when you call out your function. Otherwise, you'll get an error. Let me show you what I mean. So if I copy this, and let's say args, run this, and then if I call the function args, and if I pass, let's say 2, 4, 5, and then let's say a is equal to Python, then if I have 8 and 10, run it, this will give us an error. It says non-keyword argument after keyword arguments. So when you have keyword arguments, they should come at the end. It should be the last parameter in your function call. That's important to remember, okay? Now we can fix this, then change this to here, 8, 10, and then run it. Now you should be fine. Great. This is all I have for you. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on the main function. The main function is used mostly to place statements that we don't include in our function definition. I wanted to quickly show you how we can use the main function. When you read various programming books, you will see the main function, and that's why I wanted to quickly cover this main function. Basically, when we define our function, we put our code, and everything else that we don't want to place in our function definition is placed in the main function. We define another function called main, and we place all of our statements which are not included in the function definition in this main function. And later on, we'll call this main function, and it will execute and in turn call all the other functions. Let's look at an example. Let's say we have a function that adds 2 to a given parameter. Okay, this function accepts, let's say, 1 parameter, and it will simply add 2 to that parameter. Okay, so x is equal to x plus 2. That's our function. Let's add a couple of print statements. Let's say print before the add to function is called, then the value of x. Then we have our function x plus 2, and then after the add to function is called, value of x is then x. So before the add to function is called, value of x is then x. So far we know how to do this, and we can call our add to function and then pass any attribute, let's say 3, and we get, before the add to function is called, value of x is 3. After the add to function is called, value of x is 5. And similarly, we can say add 2 and then pass, let's say, 7. Run it, we get that. We know how to do this, right? Next, let's see how we can use the main function. So we can define another function called the main function. Let's define it here. Define main. Then we can say x, let's say x is equal to 3. Then we can say, we can call the add to function and pass x. And next, let's say print will print a line, and let's say x is equal to 7, and then we'll call our add to function and then pass x. Let's print a line here also, and then let's define our x, let's say 22, and then let's call our add to function one more time and then pass x. So in this case, we have our main function here, right? The add to function, which is the function that we care about. And then anything else, we added it in the main function. So without this main function, what we have done was add 2, call our add to function, and then pass 3, right? Run it, and then we see the result, and then we call our add to function, and then pass 7 here, and then we get our result, and then finally we call our add to function and then pass 22, and we get our result. But instead of doing all of that, what if we did this? What if we defined another function called main, and then we passed all our attributes, and then we call our function at the same time, pass our attribute and call our function, and finally we can call this main function once. We can call this main function and it will execute all of the statements. So when we call our main function, it will go here and execute this. It will set x to be equal to 3, and then it will call the add to function, which will in turn add 2 to the value of x, and that will give us 5. So it will, when we call this add to function, it will execute, it will call, we are calling this function, so it will execute whatever statement we have within our add to function, right? And then we have x is equal to 7, then it will add, it will call the add to function again and execute the statements within the add to function, and so on for each of our x values. So let me run it and show you. So here we have, right, before the add to function is called, let's say this times 15. So now we have, before the add to function is called, the value of x is 3, and then after the add to function is called, the value of x is 5. Then we have our line, and then we called x is equal to 7, and it called the add to function. So we have these two statements because we are calling this add to function, and that executes the code within the add to function. Then finally we have when x is 22, after the function is called, we get 22 plus 2, which is 24. So this is the main use of the main function. So whatever is not included in the add to function, we place it within the main function, and we can call the main function once and it will execute all of that. So that's the main use of the main function. One thing I want to mention is that the value of x in the main function is not affected by our add to function. That's because we are only referencing x, which is an integer, right? So when we say x is equal to 3 here in the main function, x references only an integer. And we know that integers are not mutable, so we cannot change the value of x in the main function. Okay, so calling this add to function does not affect the value of x that we define in our main function. So just to show you that, what I'm going to do is, let me just copy this part. Okay, Command C, Command V. So we define our main function, add 2 to it, and then we'll call our main function here. And let's add a couple of print statements before and after this add2 function is called. So before our add2 function is called, let's print before our add2 function. Then let's say x. Then we have our add2 function, and after that let's print after our add2 function, and then x. So when we run this, so the value of x is 3 before our add2 function, and we call our function our add2 function, and the value after calling this add2 function will still be x, will still be 3. Let me run it and show you. Here you see before our add2 function x is 3, after our add2 function x is still 3, right? However, when we call our add2 function, these two statements are printed and run. So before the add2 function is called, value of x was 3, and then after the add2 function is called, the value of x is 5. That's the add2 function. Okay? And the value of x in this main function is not affected by the add2 x method, because integers are immutable objects and we cannot change the value once we define it. Okay, that's important thing to mention. Similarly, if we add that to all of our x values, we'll get the same result. So before we call our function, we can print before our add2 function, then value of x, then print after our add2 function, value of x. The same is true for all the other x values. So I included the same print statements for each of the x values before and after we call the add2 function. Okay, when x is equal to 7, print before and after the function is called. Okay, let's run it. So we get the same result. Before our add2 function is called, the value of x is 3, and then we have our add2 function call, which is these two statements here, and then after our add2 function is called, the value of x still remains the same, 3. In the second example, the value of x is 7, it still remains 7, and then 22 in the third example. Okay, it's important to note that the value of x is not affected in the main function. Great. So this is how we can use the main function. Just to recap, we use the main function to place statements that are not included in our function definition, and by simply calling the main function, we will be able to execute our initial function. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on Lambda functions. So far we have seen how to define functions and how we can use them. We've seen that we define functions by using the def keyword. In Python we have what is known as anonymous functions or nameless functions, which are defined by using the lambda keyword. And these lambda functions cannot have multiple statements. They can only accept single statement. And we use these lambda functions to create a simple function. Okay, they look like this. Lambda, that's the keyword, and then we have our argument, and then colon, we have expressions. This is the general form for lambda functions, and they are anonymous or nameless because we don't give those lambda functions any name. And this is the format. Mostly these lambda functions are used in conjunction with functions known as map, filter, and reduce. We'll see more of those later on, but you will mostly see lambda functions used in conjunction with these three functions: reduce, filter, and map. Now let's see some examples of how to create and use lambda functions. I'll start by creating a function by using the def statement, the def keyword, and our function, let's name it subtract, or I'll call it difference. So what it will do is it will take two arguments, x and y, and it will return x minus y. X minus y. So this is the normal function definition. Then we can call our function difference, and then pass two arguments, let's say 5 and 3. We get 2 back. Now let's convert this normal function into a lambda function. So lambda takes this form: lambda, argument, colon, and then expression. So that would be the same as we have lambda, then our arguments x and y, colon, and then expression x minus y, right? Our arguments x and y, and our expression x minus y. So this will be the lambda function. Okay, it says the function of main type lambda, and we can save this lambda function in some variable, let's say a, and then we can pass a, and it accepts two arguments, right, x and y. So we can pass 5 and 3 and run it, we get 2. Similarly, we can pass, let's see, 3 and 7, and we should get -4. Okay, so that's how we can create a lambda function. Next, let's define one more function called summation, and our function will take 3 arguments and it will return the sum of those 3 arguments or parameters. So it will return a plus b plus c. We can call our summation function and pass 3 parameters or arguments, and it will give us the sum of those arguments. So 3 plus 4, 7 plus 5, 12. Now let's convert this into a lambda function. So we have lambda, and then our arguments, which are a, b, and c, colon, and our expression a plus b plus c. That's our lambda function. And we can save this in a variable. Let's call it sum with double M. Now we can call our sum lambda function and then pass 3 variables, 3, 6, and 8, and it will give us the sum of those 3 numbers. What do you think will happen if I only pass, let's say, 2 parameters? I'll get an error. So the lambda function takes 3 arguments and we only gave it 2. So that's the same as what we would get with the normal def function. Great. Next, let's create a lambda function that will add some numbers and divide it by the sum of some other numbers. Okay, let's just say we have a lambda function that takes 3 arguments, a, b, and c, and it will return the sum of a plus b and c divided by, let's see, a plus b minus c. Okay, let's save this in a variable called ratio. So we can call our ratio lambda function our ratio function, and then we can pass 3 parameters. Let's say 3, 8, and 2. Run it. We get 1. So 3 plus 8, 11, that's 13 divided by 3 plus 8 is 11. 11 minus 2 is 9. Let's import the division module, the division function from the future module. So from __ future __ import division, since we are using Python 2, so that we get the actual true division result. Let's run our ratio function again, and then run this. So we get 1.444, and let's make this 8 so that this will give us an error, right? Or a plus b. Let's make this 5. Since the denominator will be 0 in this case, it will give us a 0 division error. 0 division error. Okay. Then if we have some other number here, let's make C a larger number. Let's say 11. Run it. So our result is negative 6.33. Next, let's see how we can use a lambda function with if-else statements. Okay, so we'll define a lambda function, and it will take 2 arguments, x and y, and our lambda function will return the greater of the 2 arguments. Okay, it will return the greater number. So we can say lambda xy return x if x is greater than y, or else return y. So we can save this in a variable called max. Now we can call our max function and then pass 2 attributes, let's say 2 and 4. So in this case it will return 4. Right, takes 2 arguments and then return x if x is greater than y, or else return y. See, x is 2 in this case, y is 4, and the result we got is what? 4, since it's the higher. We can also say max, and we can say x is equal to 8, and then y is equal to 12. Run it. We get 12 back since it's the greater of the two numbers. We can also say max, return the max of, let's say, 14 times 16. That will be one number, and then the second argument will be, let's say, 13 times 17. Run it. So 224 is the higher of these two numbers, which is 14 times 16. We can also use lambda functions with some of the functions in the math module. We can import math module, and let me show you how we can call the square root of some number by using lambda function. So we can say lambda x, then simply math that square root of x. This is just an example. Okay, and we can save this in a variable called square root, sqrt. So lambda x, so x is our parameter, take x and then return the square root of x. Then we can simply say square root and then pass whatever number that we want, let's say 16, and that will return 4. Then square root of, let's say, 111, that will be 10.535. Okay. This is just to show you that we can use lambda function with that. Of course, there's a simpler way. We can simply say math that square root and then pass our number. That's a much easier way. But this example is just to show you we can use a lambda function with a simple expression. Okay, we can also use lambda functions with list slicing. For instance, let's say we have a lambda function, takes an argument or one parameter and then returns the arguments at a specified index, let's say 0 to 4. Okay, and we can save this in a variable called, let's say, slice, and then I can call our slice lambda function and then pass our argument. It takes one argument, right? We can say Python is cool, and when we run this, it will return our argument from indexes 0 up to 4. So that means index 0, 1, 2, 3. So we'll get the first 4 characters, P, Y, T, and H. P, Y, T, and H. Similarly, we can change this to, let's say, 0 to 7. Run it again, we get Python back, Python in one space. So that's how we can use slicing. We could have also said lambda x, return x in the reverse order. Run it, we get the reverse of our slice. Okay. We could have also said return every other element. Run it again, we get pt, so every other element. That's how we can use lambda expressions or functions with list slicing. And lambda functions can also return true or false Boolean results. Okay, for instance, let's define a lambda function that will return true if a number is divisible by 4. If not, it will return false. Let's write that. So we have our lambda. Then we can say number, it takes, so number is the argument, lambda number, and then number modulus 4 is equal to 0. So it takes an argument, and then it will calculate the number modulus 4, and it will check if that's equal to 0. And if that's the case, our lambda function will return true. If not, it will return false. Let's save this in a variable called divisible div4. I'll just call it div4. Now we can call our div4 function and then pass. Let's start with a number that we know. We know that 12 is divisible by 4. So this will return true, right? Let's pass 16. We also know that's divisible by 4. Now let's pass some numbers that are not divisible by 4. Let's say 27. That will return false, right? Similarly, if we say 13, that will return false. And we can pass some random numbers. Let's say 1124. Well, that's divisible by 4. Say 7652. Let's see if that's divisible by 4. Okay. Say 763. We know that's not divisible by 4. So it returns false. So just to summarize what we have seen in this lecture, we saw that we can create lambda functions by using the lambda keyword, and lambda functions are nameless or anonymous, and we use them mainly with the map, reduce, and filter functions. And mostly we use lambda functions to create simple functions, and they don't replace the def main function definition, and we cannot have multiple statements in a lambda function. Okay, so the way we write lambda functions is lambda, and then we have our arguments or parameters, colon, and the expression. Great. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the exercise on functions. Here are the instructions for this exercise. First, define a function that accepts two parameters, lower and upper. The parameters lower and upper are integers, and they must be lower first and then upper. So if the parameters are entered in the reverse order, we must have some condition to make sure that the lower parameter is first and the upper parameter is last. And then we'll prompt the user to enter integers between the two parameters, lower and upper. And if the user does not enter integers or integer between the lower and upper parameters, we have to prompt the user to enter integer again and display some kind of message. And finally, once the user enters an appropriate integer, we'll display that integer. So basically we'll have a function that accepts two parameters, okay, lower and upper, and those parameters are integers. So let's say 3 and 10, and if those are passed in the reverse order, let's say 10 and 3, we must have some kind of condition to reverse this. and basically the user has to enter an integer between those two parameters. And in this case, if the user enters, let's say 22, 22 is not in this range, so we have to display a message saying please enter an integer between 3 and 10 or something like that. And finally, when the user enters the appropriate integer, let's say 5, we'll display the integer that the user enters. Okay, take a few moments to try this exercise. Great. Now let's see the exercise together. Okay, let's define our function. Let's start by defining our function. So we'll define, and then I'll name it, you can name it whatever you want. I'll just name it display integer, and then it accepts two parameters, lower and upper. And finally, what my function will do is display the result. So our function will return the integer input. Let's name it integer input from the user. That's the main purpose of the function. When the user finally enters an appropriate integer, which we will name integer input, we'll display that integer input variable. We'll return it. Okay, so let's start our function. So the first direction here is the parameters lower and upper are integer and must be lower first and then upper. Okay, in this case, let's have an if statement that will make sure that the smaller integer that we enter is the first parameter and the higher integer will be the second parameter, which is upper. So we can add an if statement, and simply we can say if let's say lower is greater than upper, we can say lower and then upper is equal to upper and lower. So what this basically means is if lower is greater than upper, make the lower upper and make the upper lower. That's what this if condition does. This does. Okay, and then let's prompt the user to enter an integer. We can say, and then whatever we prompt the user to enter, we'll save it in this variable, integer input. Let's do that. So integer underscore input, and that will be equal to raw input. If you are using Python 3, use the function input instead of raw underscore input. So we have raw input, and then let's see, enter an integer within the range. So we want the user to enter an integer between these two ranges, between lower and upper. So we'll say enter an integer within the range plus within the range lower plus and plus upper. Here this integer input is a string, so we'll have to make all of them string, otherwise we'll get an error because we cannot concatenate different data types. here we have a string, so let's make everything string. So we'll convert our lower integer into a string, and similarly we'll do the same here. Upper will convert it into a string. Let's continue this in a new line. Okay, enter an integer. Okay, now that we have this, we'll cast everything into an integer. Okay, to do that, we'll put everything in parentheses and then cast it into an integer. That's because our raw input is a string. Our lower here is a string also, and our upper is a string, and we casted everything into an integer. That way the integer input will be converted into an integer. Next, what we will do is we'll take this integer input and then check if it's within this lower and then upper range. Let's do that. We can say while integer input is less than the lower limit, or while the integer input is greater than the upper limit, greater than the upper, we can print a statement and then prompt the user or tell the user that the integer they entered is not within this range. We can say print integer input is not between the upper, is not between the lower and upper, and then we'll prompt the user to enter an integer within the range lower and upper, and then we'll save that in our variable integer input. So integer input, and we'll set it to be equal to raw input. Again, if you are using Python 3, use the function input. So raw input, and then we'll say enter an appropriate integer. Okay, we'll display that message to the user, and since this is a string, we'll cast it into an integer. So put everything in parentheses and then cast it into an integer. And finally, once the user enters an appropriate integer, we'll return the integer so that that integer will be displayed. Integer input. The reason why we're using while loop here is that if the user doesn't enter an appropriate integer, we'll keep displaying this message saying the integer you input is not between the lower and upper limit, and we'll again prompt the user to input an appropriate integer. And make sure your indentation is correct when using this while loop. Make sure this integer input that you prompt the user for the second time is at the same level as the print statement in your while statement. Otherwise, you'll run into an indefinite loop. Okay. If we use an if condition here, we'll only prompt the user once. That's why we're using the while statement. It will keep going back to that loop until the user finally enters an appropriate integer, and in that case the appropriate integer will be returned. Okay, now that we have our function, let's try it out. Okay, run it and then call our function, display integer, and let's pass two parameters, let's say 5 and 16. Okay, run it. It says enter an integer within the range 5 and 16. Let's say 3. Run it. It says 3 is not between 5 and 16. Enter an appropriate integer. Let's say 4. 4 is not between 5 and 16. Enter an appropriate integer. Okay, the lower limit works. Let's put something outside of this upper limit. Let's say 18. Run it. It says 18 is not between 5 and 16. Enter an appropriate integer. Let's put 8. Run it. Okay, finally, once an appropriate integer is entered, it will be displayed. So finally we got 8. Here in our first statement here, enter an integer between 5 and 16, and then we input 3. So let me add a colon to this initial input statement. Okay, plus, let's add a colon or space. Okay, should be good now. Let's run it again. Let's call our function, enter an integer between 5 and 16, let's say 3. Run it. Okay, now it's good, right? And finally, when we enter an appropriate integer, it's displayed. Good. Again, as I mentioned, we're using while loop so that it goes to the loop back and then keeps asking the user to enter an appropriate integer. Let me show you what it would look like if we use if statement. So if we use if, so it will prompt the user to enter between 5 and 16, let's say 3, enter. So it prompts the user once. Now if I enter something out of range, it will not prompt me again. It will simply return that result. That's why we're using while loop. Okay, now that we saw our function, one thing we can do is we can add the main function. Okay, we can define our main function, and then we can call whatever we want to call in our main function. Let's call our function display integer, right? And then pass, let's say 5 and 16 as our lower and upper attributes. And let's call our function again, display integer, and in this case let's pass 30 and 7. Okay, once we pass that, we can call the main function and run it. It says enter an integer within the range 5 and 16. So first, once we call the main function is calling the display integer function 5 and 16. So it goes to our display integer function with lower and upper attributes of 5 and 16. That's what we have here. So enter an integer between 5 and 16. let's say 99. 99 is not between 5 and 16. Let's say 1. 1 is not between 5 and 16. This time let's enter an appropriate integer. Let's say 8. So finally 8 is displayed, and then it goes to the next statement here within our main function, display integer between 30 and 7. So in this case it says enter an integer within the range 7 and 30. So here we say that if the lower limit we entered is higher than or greater than the upper limit, so display by switching the position of those two attributes. So make the lower upper and make the upper lower. So we know that condition is working. We entered 30 as our lower limit and then 7 as our upper. But here we have the right range, 7 and 30. Okay, let's enter a number 4. 4 is not an appropriate one. Enter 5. 5 is not in the range. Let's say 34. It's not in the range. And finally let's enter 20. So 20 is displayed. Okay, so by defining the main function we can enter any statements that we want and simply call the main function. We could have also entered print before the execution of the display integer function between, let's say, 5 and 16, and then we can add another print statement here. The execution of the display integer function between 5 and 16 is completed. Then we can print some line breaks, let's say times 15. Let's add a couple of print statements before the execution of display function between 7 and 30. Okay, here in our main function I added a couple of print statements before the execution of the display integer function between 5 and 16, and then we have our display integer function between these two ranges, 5 and 16, and then the execution of the function is completed, and we'll print a line. Then we have a similar print statement before the execution of our function between the integers 30 and 7, and then after the execution of that function the statement will be printed. Then we have a line will be printed, and then we are ready for the third execution of our display integer function. So the importance of this main function is to put all the statements that are not included in our main function, in our function definition. And once we put all those statements in our main function, we can simply call the main function, and we don't have to enter all of this one by one. So once we call the main function, all we gotta do is run it. So before the execution of the display integer function between 5 and 16, it says enter an integer within the range 5 and 16. Let's say 3. 3 is not appropriate. Let's enter 8. Okay. And then, so the appropriate integer is displayed. And then we have the execution of the display integer function between 5 and 16 is completed. And then we are on the next display integer code here. So enter an integer within the range 7 and 30. Let's say 3. 3 is not appropriate. Let's enter 25. Okay. So 25 is displayed, and then we are on to the third range, which is before the execution of the display integer function between negative 15 and 25. Or let me change this to negative 15 and 25. And let's change this to times 18 times 18 times 18. Okay, let's run it again. Run it again. Our kernel is a little busy. Let's call our function again before the execution of the display integer. Okay, 3 enter. 3 is not between 5 and 16. Let's enter 12. Okay, the execution of the first statement is complete. Now between 7 and 30, let's say 4. 4 is not appropriate. Let's say 34. Enter an appropriate integer. Let's say 22. Okay, finally 22 is printed. And then execution of the next statement. Enter an integer within the range negative 15 and 25. Let's say negative 22. Enter. Negative 22 is not between the range negative 15 and 25. Let's enter negative 7. Enter. So the execution of the display statement, the display integer function between negative 15 and 25 is completed. It looks much neater, right? Great. So that's what I have for this exercise. Thank you everyone, and I'll see you at the next lecture. Hello everyone and welcome. In this lecture we'll look at a few questions on strings and lists. We'll write functions to answer each of the questions. And here are the questions. Let's start with the first one. So we have a list here containing these 4 elements. And the instruction says, write a function that will add all the elements in the list above. So we want to write a function which will add up all these numbers here. So it should give us 3 plus 4 plus 5 plus 6. That should be, let's say, sum 1 plus, then it should add up the numbers in this list, which we'll call, let's say, sum 2. The elements inside this list added together, that will be sum 3 plus, so the last sum 4. And finally, we'll add these 4 sums, and that will give us a sum total. So that's the function that we want. This is the final result that we want. So the function that we'll write will give us this sum total. Okay, take a moment and try the exercise. Great. Now that you have tried the exercise, let's look at my solution together. So we start with our def statement, def keyword, and then name for our function. Let's call it list sum, and then let's say it accepts one attribute, which is a list attribute, right? We'll just call it LST, or simply let's call it X to make it simple. Okay, we have our function, and what we'll do for this is I will create a variable, and then that will hold the sum, and initially I will set that variable to be equal to 0. So when we first start, the sum total will be 0, and then we'll use a for loop to go through our list object here, and then we'll calculate the sum of each of our elements, which is each of this list inside our list. So we'll add that to our total, to the sum total, which was initially 0. Okay, and we'll calculate the sum total of all the lists inside our list. So let's look at that together. So let's have a variable called sum total, and we'll set it to be 0 initially, and we can use a for loop. We can say for let's say elements in our list X, we can say sum total is equal to sum total plus the sum of all this list elements, right? So we can set it to be equal to plus or equal. We can say sum of our elements, right? So I'm saying some elements because our elements are lists, so it will calculate. So this method will calculate the sum of all elements in this list, in the second list, the third and the fourth list, and the sum total will be equal to, we started with 0 plus the sum of this plus the sum of this list, and so on. Okay, so this will be our function, and finally once we calculate that, we'll return our sum total. Then finally return sum total. Okay, let's try it out. Let's call our function and try out a simpler example first. So let's pass a list containing the elements 1, 2, and let's say 3 and 4. So this should give us what? And then let's include a list here, right? It's a list containing these two lists. So the sum should be 2 plus 1 is 3, and this is 7. So that should give us 10. Run it, we get 10. Okay, now we know this function works. Now we'll pass this whole list. Okay, I'll copy this list. Let's copy that, Command C, paste it here and save it in a variable called, let's say, list1. Okay, now we can call our function list sum and then pass our list1 object, and it says the sum is 37. So if we add that, we should get 37. 6 plus 5 is 11, plus 4 15, 15 plus 3 is 18. So 18 plus 4 plus 2 is 7, plus 3 10, plus 4 plus 1 is 5, plus 2 7, and finally we have 3. So 18 plus 10 is 28, 28 plus 7 is 35, plus 3 38. Oh, this is 9, not 10. 4 plus 2, 6 plus 3 is 9. So that's 7 plus 3, 10. 10 plus 18, 28. 28 plus 9 is 37. So we know this is correct. Just to look at it one more time, we started with a sum total variable and we set it to be equal to 0, and we said for elements in our list X, sum total is equal to sum total plus sum of the elements, since all the elements are lists. If it was just numbers, we can just say sum total plus or equal to sum total, so it will keep adding to that list. Great. Next, let's look at the second question. Here is the instruction. It says write a function that will remove the first element from a given list and returns the new list and prints out the length of the new list. Can you do the same with string objects? Okay, take a moment and try the exercise. Great. Now let's look at the solution together. So we'll write a function that will remove the first element from a given list and return the new list. Okay, let's start out by our def keyword and then name for our function. Let's call it new list, and then it will take an attribute, or it will take a list as an attribute. Let's say X. So we want to remove the first element from a given list, right? So we can simply do that by using the del keyword or del statement. So we can say del, so delete our list X at index 0, because we want to remove the first element, right? Okay, that should take care of it. And return the new list and print out the length of the list. So then we can say print the length of the new list is, then we can use the length function, right? The length of X. So at this moment, the first element is already removed. Okay, and finally we'll return X, return the new list. So that should return our new list. Okay, just to make sure, we can also add, before we can say print the length of the list, the length of the original list is, then we can add length of X. So before the first element is removed, it will give us some length, and the second print statement will give us the length after we remove the first element. So the length of, so this second length should be 1 less than the length of the first length here. And finally we'll return X. Okay, now let's call our function new list, and it accepts one attribute. Let's pass a list containing the elements, let's say 1, 2, 3, 4, and 5. Run it. So the length of the original list is 5, which is 5, right? And the length of the new list is 4, as we expected. And this is our new list. Return X, right? The first element is removed, and we have our new list containing the elements 2, 3, 4, and 5. Similarly, we could have passed, let's try it with one more example. Let's pass the elements B, A, C, and D, and run it. So the length of the original list is 4, the length of the new list is 3. Then we have our new list containing the elements A, C, and D. And the second part of the exercise says, can you do the same with string objects? The answer is no. Remember, strings are immutable. Once we create a string, we cannot remove the elements in our string, right? So if we try to, let's say new list, if we try to pass a string object and run it, you will get an error because string objects do not allow us item deletion. They don't allow item deletion. Okay, if we run this, we get an error where we have our deletion because string objects don't support item deletion. Great. We'll look at the remaining questions in the next lecture. Thank you, everyone. Hello, everyone, and welcome back. We'll continue our discussion on the exercises that we have on strings and lists. Let's move to question number 3. So here is the instruction for the question. We have a list here, and it says write a function that will remove the first 2 elements and the last 2 elements from the list above. Also write a function that will remove the first 2 elements and the last element. So from our list, we need to write a function that will remove these 2 elements and the last 2 elements and return the remaining elements. So we want our function to return this highlighted elements. Okay, let's see how we can do that. Okay, we'll start with our def statement. Then let's call our function remove, and it accepts a list X as an attribute. Okay. The simplest way to write this function is to include and make use of list slicing. So we can slice the list from index 2 up to -2. If you remember list slicing, if we have a list object, let's say list X, if it contains the elements, let's say 1, 2, 3, 4, 5, and 6, we can slice our list. We can say list X, and then let's say slice 0 up to 3. What will that give us? This means indexes 0 up to 3, but not including 3. So this is index 0, 1, and 2. So this will give us a list containing the elements 1, 2, and 3. 1, 2, and 3. Similarly, if we say, let's say, index 2 onwards, we get 3, 4, 5, and 6. So this is index 0, 1, 2. Right? Index 2 onwards. So using the same reasoning, we said here X, so return X from index 2 to index -2. If we consider this list, negative indexing starts from the int, so 6 will be -1, and the index of 5 will be -2. So up to -2 means not including the last element, right? Slicing doesn't include the last element. So if we take this list, this function will return elements starting from index 2. So this is the index 0, 1, and 2, and return the elements 3 and 4. So that takes care of removing the first two elements and the last two elements. So we can simply say return x slicing from 2 to negative 2. Now we can call our function. We can call our remove function, and then it accepts one element, one attribute. So we'll pass a list. So in this case, it should return a list containing the elements 3 and 4. 3 and 4, great. Now we can pass our longer list object here. Command C. Then we can call our remove function and pass the list. So this should return a list containing the elements, the highlighted elements. Let's run it. Yep, from 8 through 4. And we could have saved this in a variable also. Let's say y is equal to our list, and then call our function and then pass the object y. So that's the same thing. Great. Next, let's look at the next question. Question number 4. Okay. Here we have a list. It says write a function that will return the sum by calculating the elements before it. Example, it says the sum element at index 2 will be the cumulative sum of the first 3 elements, and so on. Okay, so this is the same as saying we're not only returning the sum, but the sum has to be equal to the sum of the elements before it. So the result should look like this: 1 and then 3, I'll explain later, and then 6, and it goes on like that. So the first element is 1, so we have 1 here, and the second sum here, 3, is equal to the sum of the first two numbers, which is 3, and the third element, 6, is equal to the sum of the first 3 elements, right? And then the fourth element here in our sum should be equal to the sum of the first 4 elements. In this case, 4 plus 3, 7 plus 2, 9 plus 1, 10. 10. And then the fifth sum here should be equal to the sum of the first 5 numbers. So 10 plus 5, that should be 16, and the last element for our sum should be equal to the sum of all these numbers, which is 22, I think, right? 6 plus 5 is 11, plus 4, 15, plus 3, 18, plus 2, 20, plus 1 should be 21, and this is 15, not 16. Cool. So the function should do this, right? So for the first element, cumulative sum is 1. For the second element here, for the second sum, it should be the sum of the first 2 elements, 3, and then the next element should be the sum of the first 3 elements, and then the sum of the first 4 elements. So basically you will be adding, let's say the first sum is 1, right? And then we will be adding the next element to your previous sum, and then you add the next element to your previous sum. So let's say up to here is what? 10, right? And you add 5 to the previous sum and you get 15. So that should give you an idea, right? You can start with a variable to hold your total sum and set it to 0, and you can create an empty list to hold the initial sum, and we can use a for loop to keep adding or appending to that empty list, and then we'll build that empty list by adding the sum amount. Okay, that should give you an idea. Take a moment and try the exercise. Great, let's look at the solution together. We'll start with our def statement and give a name to our function. Let's call it summation, and then it will accept an attribute x, which will be our list. And then let's say we have a variable called total, and we'll set it to 0, and we'll keep adding total to the previous total. Okay, and we'll create another list object to hold the total. Let's call it result. We'll start out with an empty list, and we'll append the total that we get to this empty list. Now we can use our for loop. We can say for numbers, right? In our list object x, we can say total is equal to total plus number, right? So we can say total plus equal number. So initially total will be equal to 0 plus the first number, which is 1. So in the first for loop, the total will be 1. And then we'll take 1 and then append it to our result list. So we can say result that append total. Simple, right? And then next, in the next for loop run, so in the first run we'll have 1. In the second run, so the total will be here for number in x. In the second run, the number is 3, right? So total, no, here the number is 2, sorry. The second number is 2. So the total will be equal to the previous total, which is 1 plus the number 2. That will be 3. And then it will append it to our result list here. So 2 plus 1 is what? Will be 3. And during the third run, the third number is what? 3, right? So for number in x, num in this case is 3. Total is equal to the previous total, which is 3, plus our third number, 3. So this will be 3 plus 3. 3 plus 3. And then it will append the result to our list here. So it will be 6 here. And then, so the for loop will continue. For num in x, the next number is 4, right? Total is equal to total plus the number. The previous total is 6 plus our number, which is 4. 6 plus 4 is 10. And then append 10 to our result list. So it will append 10, and it goes on like that to the remaining elements in our list. And finally, once we have our for loop, all we have to do is return the result. Return result, right? The final result where all the total is appended. Okay, now that we have this, we can call our function and pass the list we have here. Let's run the cell, then call our summation function and pass the list. Run it, and we get, as expected, 1, 3, 6, 10, 15, and 21. We can try out other lists also. Let's say summation. We can pass, let's say 3, 6, 8, and 12. So that should give us, the first sum should be what, 3, then the second one should be 3 plus 6, which is 9, and then 9 plus 8, 17, and finally 17 plus 12, 29. So this should be the result. Yep, 3, 9, 17, and 29. Great. Let's look at the last question. Question number 5. Okay, let me copy it and paste it here. It says, write a function that checks if a given list has the same duplicate elements. If so, the function should return true, or else it should return false. So let's say we have a list containing the elements 2, 3, 4, and 5. So if our list has the same duplicate elements, it will return, the function will return true. If not, it will return false. Since we don't have any duplicate elements in this list, this will return false. Whereas if we have another list that has duplicate elements, let's say 4, 4, and 3, this will return true because it has the same duplicate elements, which is 4 in this case. Okay, let's look at the solution together. We have our def statement, and let's name our function duplicate, and it will accept a list object, right? Let's call it list1. It will accept a list as an attribute. So the first thing we can do is we can sort out our list. That will make it much easier. So we'll take the list1 object that we pass as a parameter and then sort it. So we'll sort our list object, and then let's save that sorted object in a variable called x. Okay, the next thing we can do is we can use a for loop and try to check every element in our list, and then we'll compare. For instance, let's say we have this, right? We will compare the element at the first index to the element at the next index. So we'll compare two adjacent elements, and if the comparison is equal, that means duplicate elements exist and the function will return true. So if the comparison returns false, we'll compare the next adjacent elements. So first we'll compare these two, and then we'll compare the next two adjacent elements, and then we'll compare 4 and 5 and so on. Okay, let's do that. So we can say for element in, let's use a range function, in a range, and then length of our list x, which is sorted, minus 1. Don't forget we are using range. Range goes from 0 to the last element is not included. So we said length of x minus 1. In this example, the length is 4. So 4 minus 1 is 3. So range to 3, right? And then indexing will be 0, 1, 2, 3. That's why I said length of our sorted list minus 1. Okay, and then we'll compare two adjacent elements. We can say if our list x at index of the element, right? So it will be the first element. We'll use double equal because we are comparing right and left. We are comparing to see if those two are equal. So if x at the first index, if the element at the first index is equal to the element at the next index, which is element plus 1, right? This is the next index. If the comparison is equal, our function will return true. If not, we'll return false, right? Return false. So if this is true, we will return true, or else return false. So let's go through it one more time. Our duplicate function accepts one parameter. It accepts a list object. We start out by sorting our list, and once it's sorted, we use a for loop to go through each element in our list. So for element in range length of our list minus 1. So for elements in our list, basically, if our list at that element, so index, if the element at that index, so the first element, if the element at index 0, right, that will equal to the element at the next index. So it will compare 2 and 3. If it's true, our function will return, this for loop will return true, and it will do that for each of the elements. Otherwise, the function will return false. Okay, let's check our function. Let's call it, and then pass a list containing, let's pass this list containing the elements 2, 3, 4, and 5. 2, 3, 4, and 5. So this should return false because there are no duplicate same elements. Run it. Here it says object of type non-type has no length. Okay, let's solve this. I have one solution. Let's start out. Let's first convert the attribute that we pass here into a list. That should take care of the error. So we can say list and then the attribute that we pass. So list 1, we'll cast it to a list. So that will convert it into a list. And then we can save that in a variable called, let's say, x. And once it's converted into a list, we can sort our list. So we can say x dot sort. So that should take care of the error. Let's run it again and call our function. Good. So here we have false because there are no duplicates. And next, let's call our duplicate functions, our duplicate function, and pass the next list, which is 4, 4, and 3. 4, 4, and 3. This will return true because there are duplicates. True, right? Similarly, if we pass, let's say, a list containing the elements A, C, D, that should return false. Whereas if we add one more element C, this will return true, right? And one more thing, since we are casting our attribute, whatever we pass into a list, we can even pass strings in this case. So duplicate, we can pass a string object and it will be converted to a list. So this will return false because there are no duplicates. Whereas if we say string and then let's say R and run it, we get true because R is a duplicate, right? Great. So these are the exercises that I have for this lecture, and this is just one solution. You could have written different functions to solve these problems. This is just one solution, and there are multiple ways of solving all these problems. Okay, so the solutions that I showed you are just one solution. Okay, thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on classes in Python. So far we have learned about different data types like strings, lists, dictionaries, tuples, and functions, and so on. We have seen that things in Python, all this, for instance, strings, lists, and tuples, they are all objects. Everything that we deal with in Python is an object. And we have seen that we can find out what kind of object something is by using the type function, right? And classes are a way of grouping together related functions which act upon some data. That's the main use of classes. And when we say things in Python are objects, it means that there are some instances of a class. For instance, let's say we have a string name and then save it in a variable called string1, and let's say string example, and then if we call string1, we get string example, str example. And if we want to find out what kind of object this string1 is, we can simply say type and then pass string1. It tells us it's a string object. Similarly, we can say type of, let's say, some number 23. We see that it's an integer. And if we have a list and save it, let's say, in a variable called lst, and let's say our list has the following elements: A, C. Then if we want to find out the type of our list object, we see that it's a list. So that's how we can find out the type of any object. We simply type and then pass any object there. Great. And some data values which we store inside an object, we call them attributes. And functions which are associated with those objects are called methods. We have seen some built-in methods that we have in strings and lists, for example. Next, let's see how we can create a class. So to create a class, we start with the keyword or statement called class. So we type class and then space and then name of the class. So the class name goes next. and then we have colon, and then we go to a new line, indent, and we put our methods. The first method that we put is a special method known as the init method. I'll explain more about it. So underscore underscore init underscore underscore, and then in parentheses we pass self. This is an attribute, and then colon, new line, and then any code to initialize our object goes here. Any code to initialize our object goes here, and then any additional method goes here. Method name, and so on. So this is the general structure for creating a class. We have the class statement or keyword, then space, class name. So the class name starts with an uppercase, and usually we give a nice descriptive name for our class name. For instance, if our class consists of let's say doing multiplication, addition, subtraction, and so on, we would give it a class that clarifies that. For instance, we could name that class operation or math operations or something like that. And then the first method is the special method known as the init method, and then it takes self as its first argument, and then any other method follows that. Method means any function within a class. So method is nothing but a function which is defined within a class. Okay, it's just a function within a class, and we see that we use classes as templates for creating various objects. And then once we create a class, we initialize our object. So any object created by using the same class will have similar characteristics. We'll see that later on. So this init method is a special method. When we call our class object, a new instance of the class is created, and then the init method on this object is executed with all the parameters that we pass to the class object. And the purpose of this init method is to set up a new object using data that we have provided to it. This init method is also called the class constructor, or the method used for initializing methods, and Python calls this init method when we create a new instance of this class, and it takes self as its first parameter, and then it also takes any other parameter. So let's say parameter 2, parameter 3, and so on. But it takes self as its first parameter. So self is a parameter or reference to this instance of our class, and every method's first argument is self. So here we have another method, and the first argument it takes is self. So self is not only the first parameter in our init method, but also any other method that we have in our class. It takes self as its first argument or parameter. Hello everyone, and welcome to the lecture on class attributes. In this lecture, we look at class attributes in detail. If I go to the previous class that we created in this person class, we saw that this address is a class attribute. So this class attributes, they are shared by all instances of our class, right? So all our methods are able to use and refer this class attribute. These attributes that we defined in our init special method are called, those are instance attributes, and they are added to the instance when the init method is executed, right? Now let's look at class attributes in detail and how we can use them. Let's create a person class, then person. Let's define a class attribute known as, let's say, majors, and then we'll pass a tuple of majors, let's say engineering. Let's pass few more majors, law, let's say IT, and psychology. So that's our class attribute, and then let's define a few methods. So the first method is our special init method. Init, it takes self as its first attribute. Then let's pass some more attributes like major, name or first name, and let's pass last name. Okay, then let's initialize these attributes. Can say self that major, we'll set it to be equal to major. Then self that name, we'll set it to be equal to name. Self that last name, we'll set it to be equal to last name. So now that we have initialized our instance attributes, what we want to do is, once we initialize our person object instance, we'll pass a major and then see if that major is in our list. And if it's not in our list, we'll pass an error. So what I will do is, I'll include an if statement to accomplish that. We can say if major is not in our self that majors, we can raise an error. We can simply raise, let's say, a value error. So I'm saying value error because I know the specific type of error that this will raise. That's why I said value errors. This is one kind of error. Then we'll simply say, let's format our error. So we'll say we have our open parenthesis, and then we can say is not a valid major. Okay, that format, and then we'll pass major. So we'll pass a major, and then this will check if the past major is within this tuple, and if it's not in here, it will raise a value error. If not, it will continue with our method and then do whatever our method is doing. Okay, Next, let's define another method. Define, let's say, person major. Then we'll pass self as its attribute. And what this method will do is, let's simply print the major of that person. So what we'll do is print the major of plus self dot name plus space plus self dot last name plus is plus self dot major. Okay, what this person major method will do is it will print out the major of that person. Next, let's initialize an instance of our person class. Then we'll save it in a variable called, let's say, Jimmy. Then we'll set it to be equal to person, and then we'll pass, so it takes 3 attributes, it takes 4 attributes. Let's pass those. Major, let's pass low, and then for first name, let's simply pass Jimmy, and for last name, let's pass Newman. Okay, then next, if we say Jimmy dot and then hit tab, we'll see the list of available methods and instances that we have for our attributes. So we have majors, last name, major, name, and person major. Let's look at the first one, major. So that will print out a tuple of these majors. So we have engineering, law, IT, and psychology. Jimmy.tab. Then if we choose last name, we see that last name is Newman, so we'll get Newman. Then Jimmy dot. So this time, let's select major. That will be low. And then Jimmy dot tab, and we'll choose this method, person major, and then we'll include a parenthesis for that major. So that printed out the following statement: the major of Jimmy Newman is low. That's what we wanted. Okay, let's put some space here. Run it again. So the major of Jimmy Newman is low. Since low is in our tuple here, we did not get any value error, right? Similarly, if we pass some other major like psychology and run it, we'll still not get any error since that's a valid major. The major of Jimmy Newman is psychology. What if we put some other major that doesn't exist in our majors class attribute here? What do you think we'll get? Yes, we'll get a value error. Okay, for instance, if we put, let's say, math and run it, we get a value error, right? Let's see here, we got a key error. What went? Okay, oh, so here there shouldn't be any space. Okay, let's run it again. Okay, we have a value error, and it says value error, math is not a valid measure. Similarly, if we put some other measure, like let's say physics, and run it, we'll get the same value error. It says value error, physics is not a valid measure. Okay, whereas we saw that if we put one of the measures from our measures class attribute, let's say engineering, it's valid, and then the measure of Jimmy Newman is, let's run this again, is engineering. So that's a valid entry. Great. Now let's look at another example. So we'll create another class called person, and then let's have a class attribute named sports, and then we'll set it to be equal to an empty list. And what we'll do next is, what we will do to this is that we'll add some sports, we'll append some sports to this empty list. Let's define a couple of functions. Our first function, of course, is the special init function, and then we'll pass self as an attribute. Then we'll say self dot sports, we'll set it to be equal to an empty list, and let's define one more method, and let's call this method add sport. It will take self and then sport as attributes, and let's initialize those attributes. So we can say self dot sports dot append, and then we'll pass sport. So what this method will do is it will append a sport to our sports list. And let's also have it print some message. Let's say the following sport has been added to our, let's say, sports list, then plus sport. Okay, that looks good. So in this case, sports is our class attribute, and it's an empty list. Now let's initialize our person class. Then let's save it in a variable called x is equal to person. And then, so our person class takes only one attribute, which is self, right? So that's all we have to do, person. Now if we say x dot hit tab, we'll see we have the following methods and attributes available for us. Add sport is the method that we define here, and then sports is the empty list that we created, which is the class attribute. So right now if we say x dot sports, we'll only get an empty list, right? Okay. And if we say x dot add sport, and we know that the add sport method takes two attributes, one is self and the second one is sport. So let's add a sport. Let's say soccer, and then run it. So we got the message, the following sport has been added to our sports list. Okay, soccer. Now if we call this sports attribute, class attribute, x.sports, we'll see that it's no longer empty. It has soccer now. Similarly, if we add an additional sport. Let's say x dot add sport, and let's say basketball. Then run it. The following sport has been added to our sports list. Now if we call our sports attribute, we see that basketball is added. So now we have soccer and basketball. Okay, so this is how we can use class attributes. Great. What we'll do next is add one more method in our class and then show you more example of this class attribute. Let's add our function. Let's add our method. Define. Let's name it sport list. Sport list will accept self as its attribute. Then we'll simply print the following, or we can say here is a list of all the sports in our list, plus, and then we'll pass self that sports. Okay, we can do that, but there is one issue with this print statement. Here we have a string and this is a list. So self.sports is a list, and we're trying to concatenate a string and a list. That will give us an error because we cannot concatenate two different data types. So in that case, we'll convert our list into a string by casting it. So we'll say string self.sports. So that will convert it into a string. Now we can initialize our person class. So we can create an instance of our person class and save it in a variable called x equal to person, and then it takes only self as its attribute. So we can say x is equal to person, and then now if we say x dot hit tab, those are the available methods that we have, methods and attributes. So let's first add a couple of sports. So x dot add sport, let's add soccer. The following sport has been added to our sports list, soccer. Let's add basketball. Okay, the following sport has been added to our, and then let's add one more sport. Let's add baseball. Okay, baseball has been added. Now if we say x dot sports, we'll get a list containing the three sports, right? Soccer, basketball, and baseball. Now let's call this sport list method. When we call this method, we'll get, here is a list of all the sports in our list, and then we'll get a list containing these three sports. Let's do that. So x dot tab, our method name is sport list. Don't forget the parentheses. Then run it. So we have, here is a list of all the sports in our list: soccer, basketball, and baseball. Great. So this is what I have for this lecture. Just to summarize, we looked at class attributes and how we can use them in our class. And we mentioned that these class attributes are accessible to all our methods within our class. Great. Thank you, everyone. Hello, everyone, and welcome back. In the previous lecture, I briefly introduced classes, and in this lecture, we'll continue our discussion on classes. We saw that we could create classes by using the class keyword. So we simply type class space and then name of our class. let's say we want to create a class called person. Okay, and then we have colon, new line, indent, and then we pass the first method, which is called the init special method. So we start with our def statement, 2 underscores, and then init 2 underscores, and then we pass self as the first parameter or attribute, and then we pass any other parameter. For instance, let's pass a couple of parameters. Let's say name, last name, and then telephone. So in this special method, we put self as the first parameter. So any method within our class takes self as its first attribute. And then any other attribute follows. In this case, we have name, last name, and telephone as attributes. Then we go to a new line. The next step is we have to, we mentioned that this init method is called when we create a new instance of our class, in this case person. And then within our init method, we initialize our attributes. So let's initialize these 3 attributes. So we say self.name is equal to name, then self.last name is equal to last name, then self.telephone is equal to telephone. So here we are initializing our attributes and we are assigning these attributes to our class attributes: name, last name, and telephone. So self means that we are referring to this specific attribute. This is what self means. So this is a way of telling Python that we are referring to this specific attribute and not any other attribute. So this is how we initialize our attributes. So self.name is equal to name, self.last name is equal to last name, and self.telephone is equal to telephone. So initialize our attribute and assign it to our class attributes. So I mentioned that we use self as the first attribute for all our methods in our class, and we use self by convention. So it's a well-known convention that we use self. Okay, and then we mentioned that if we have any other method, it follows in our class after the init method. And then once we do that, the next step is that we can create an instance of our class. So how do we create an instance of a class? So in this case, we can create an instance of our person class, and then we pass. So our person class takes these 3 attributes: name, last name, and telephone number. So to create an instance, we go to a new line, and then you see here when we create an instance, it has to be at the same level as our class. We don't need to indent it. It has to be at the same level where we have our class keyword. So person, and then so our person class takes 3 attributes, right? So we pass these 3 attributes, So for instance, name, let's say John, and then for last name, let's say Smith, and then for telephone number, let's pass 345 656 8849. So here we have created an instance of our person class, and then we can save it. We can save this in a variable. Let's say x. So x is equal to person. Now if we call x, we see that it's a person instance. So if you call type of x, it's an instance of our person class. Okay? And then if we want to find out information about this x, this instance of the person class, we can simply say x dot, and then if you hit tab, let's hit tab on your keyboard, you'll see that it has 3 attributes: last name, name, and telephone. So if you select last name and run it, you'll get Smith, right? You'll get Smith. Similarly, if you hit tab and then select telephone, we get the telephone, right? 345 656, so on. So this is how we can call the attributes of our person class. So we create an instance of our class, in this case the person class, and then once we initialize it, we can use all these attributes in our person's special init method. And notice here that I only passed the 3 attributes: John, Smith, first name, name, last name, and then telephone number here. I did not pass self. So even if self is also an attribute by itself, but you don't need to pass, it's not required that you pass self here. Even if you don't, Python knows that self is an attribute and it will assign it automatically for you. So it doesn't matter whether you pass self or not. However, if I only pass, let me remove this. So let's say I only pass John and then telephone. What do you think will happen? So this will give me an error. Let me show you the error. So here it says the init method takes exactly 4 arguments and we only gave it 3. So the 4 arguments are self, name, last name, and telephone. However, it says that we only gave it 3 arguments, which are self. Self is 1 argument. Even if you don't pass it, Python assigns it for you automatically. So that's 1, this is 2, and this is 3. So 1 argument is missing. So it's important to pass all the arguments or attributes. Okay. So John, let's pass Smith again. Then telephone number. Hello everyone and welcome back. In the previous lecture we saw how to create a class and then how to initialize our attributes using the special init method, and then we saw that Python calls the special init method when we create a new instance of our class. In this example we created an instance of this person class, and we were able to obtain information like name, last name, and telephone number. Let me copy this class and then see another example. Okay, I will paste it here. So in this person's class, the init method, it takes 4 attributes: self, name, last name, and telephone. Another thing we can do is we can assign default value to any of these attributes. For instance, let's assign a default telephone number. So we'll set the telephone number to be equal to, let's say, 445 342 1245. Okay, now let's create an instance of the person's class, this person class. So we simply say person, and then we said that this person class takes 4 attributes. So the first one is self, we don't need to pass that. Then we need name, let's say Jane, last name, let's say Smith, and telephone number, let's pass 345 569 9803. Then let's save this in a variable called y. Now if we call y, we see that it's of the class person instance. And if we want to find out the available methods that we have for this object y, we simply say y and then that, hit tab on your keyboard, and you'll see the available methods that we have for y. And if we choose name, for instance, y.name, and run it, we get Jane. Then if we do y.last name, we get Smith. Okay. Next, let's create another instance of this person class. So we say person, and then we'll pass our attributes. Let's say Corey, and then for last name I'll pass Paul. Okay, and then save this in another variable called a. So here we know that it takes 4 attributes. Our person class takes 4 attributes, but we only provided 3 in here: self, Corey, and Paul. What do you think will happen if I run this? Will I get an error? So in this case, I will not get an error. Even if our special method takes, our person's class takes 4 attributes and we only provided 3, but there is a default value for our telephone attribute. That means if we don't pass an attribute for our telephone, Python will assign and use this default value for telephone. So if we run this, we'll not get an error. And then if I call, let's say a.name, we'll get Corey. And if we call the telephone attribute, we'll get this default telephone number. Okay, that's very important. If we have a default value for any of our attributes, we don't necessarily need to include them when we create an instance of the class. So that's not required, and if you don't pass that attribute, the default value will be assigned to your instance of the class object. So that's what happened here. And another thing we can do is, so here on our person class, we see that name is Corey, and if we want to assign a different name, we can do the following. So a.name, and then we can set it to be equal to, let's say, another name. Let's say John. Now we are setting the name to be John. A.name is equal to John. Now if we call the name, we'll get John. So Corey is no longer the name. Now it's John. We can do that also. Let me copy this and then show you another example. So in this case, I will assign name. I will assign a default value to my name attribute also. Let's say Harry. Okay, in this case, and then I'll pass person. Let's just pass Corey. So in this case, the default values for name and telephone will be used. So we only need to assign, to pass last name here, right? And so this is correct, but there is one problem with this. So if we run this, we'll get an error. Let me run it and then show you what the error is. So it says non-default argument follows default argument. So the problem is with this attribute. So whenever we assign attributes, default values to our attributes, that attribute has to be at the end of the init method. Okay, that's what this error is saying. So if you have default attributes, they should be defined at the end. Those default attributes should be toward the end, and no non-default argument should follow your default arguments. That's what this error is saying. So basically, we have to have last name here and then delete it here. I just wanted to show you that. So now we have self, last name, which is a non-default argument. Then we have our two default arguments, name and telephone number. Let's run it now. Okay, if we call A now, we see that it's of a person instance. And then A dot, if you hit tab, you'll see the different methods available for our object A. If you select telephone number, for instance, you'll get this default value. And we mentioned that if you don't want to use the default values, you can assign, you can pass different attributes when you create an instance of that person class. Let's create another instance and save it in a variable called B. So B is equal to person, and we can pass. So let's pass last name, we can pass Paul. For first name, we can pass, let's say, Tim. And then for telephone number, we can pass some different phone number. Okay. Now if we call B dot hit tab, and then if you choose last name, you get Paul. Then B dot first name is B dot name, we get Tim. So that's how you can play around and then assign attributes to your class. Next, let me show you one other example. I will create another attribute known as address. Then let's say that to be equal to, let's say, New York. Notice I am putting this attribute right after our class definition and outside of our first method. So this attribute is called a class attribute. This is also known as class variables. Class variables, or more like global variables, and this class variables can be used by any of your methods in our class. Okay, these are called class variables, and all the class variables are put right next to your class definition and outside of your first method, your first special method. Notice here it's at the same level as your methods, and if you have any additional method, it will be at the same level. So those are class variables, and they are accessible by all the methods in your class. Okay, let's see an example. So in this case, we'll create another instance of this person's class. And save it in a variable called C, and we'll set it to be equal to person, and then let's pass last name. Let's say Newman, and then use the default values for name and telephone. Now if you say C dot and then hit tab, notice that you have an additional method available for you now, the address method, right? C dot tab, now we have address. That's what I meant by this class variables being accessible or available to all your methods in your class. Okay, and then if you choose that, C dot address, and then run it, you'll get New York. Now we have New York. And then if you want, you can set it to a different address. Let's say New Jersey. Now if we call C dot address, we see that New Jersey is the new address. Just wanted to show you that this is a class variable, and this is an example of a class variable, and we can have more than one class variable. Okay, let's say city is equal to New York City. We can have that also, and then once we create a new instance, we see that those class variables will be available for us. Now we have address and city in addition to these three attributes. Okay, great. This is what I have for this lecture, and in the next lecture we'll continue our discussion on classes. Thank you everyone. Hello everyone, and welcome back. In this lecture we'll learn about methods. So in the previous lecture we have created classes, we have seen how to initialize our attributes, and then we have seen how to create an instance of our class. In this lecture we'll add some more methods to our special init method. So here we have a person class, and then it has one method, the init special method, and Python calls the special method when an object is created. Okay, let's add another method. So basically methods are functions within a class. So let's add another method. So we'll start with the def statement space name of our method. Let's say our method name is greet person. The greet person, that will be our method name, and then we'll pass self as its attribute. So we mentioned that all our methods within our class take self as their first attribute. And this method will simply print out the following. Let's say hello and welcome plus, let's say, self dot name plus self dot last name. So we have a new method here called greetPerson. What this method does is it will print hello and welcome plus self.name plus self.last name. Okay. And now let's create a new instance of this person class, and we'll save it in a variable called a is equal to person, and then we'll just pass last name, and we'll use the default values for the attributes name and telephone number. So let's pass Smith. Okay, then if we call type of a, we see that a is an instance of this person class. Now we saw that if we say a dot and then hit tab, we'll see all the available methods that we have. Now we have one additional method known as greetPerson. So if we choose that, and then when we are referring to a method, don't forget to include a parameter, include a parenthesis. That's very important. It means that we are referring to this method within our class. Okay, so now if we say a dot, if we call the greetPerson method in our person class, this will print out hello and welcome. So what's the name here? Name is Harry, and the last name is Smith. So it will print out hello and welcome Harry Smith. Run it. So it says hello and welcome Harry Smith. Let's put some space here, plus self.name plus, let's put some space, plus self.last name. Okay, let's run it again. Now we have hello and welcome Harry Smith. Similarly, if we say a dot hit tab, we can use any of the other methods available. So a dot last name, you will see Smith, and so on. And in the last lecture, we briefly looked at the class variables, which can be used by all the methods within your class. So for instance, we can have address and then set it to be, let's say, New York. And here it's a good practice to leave one line of space between your class definition and any global variables, any class variables, and a line between your global variables or class variables and your first init method. And then also here there's a one line of space between your methods. So that's a good practice. Okay, now we have added address, and then if we say a dot hit tab, we'll see address is also available for us to use. What I'll show you next is copy this, and let me show you one more example. Let's create another method in our class. Let's say define greet person. Let's say define ask person. Then we'll pass self as its first attribute, and this method will simply print are you from, say, plus. And in the previous lecture we mentioned that this class variables can be used by any of your methods within the class. So in order to use this class variable address, we have to first specify where it's coming from, which is a class called person, and then name of the class variable. So the way to access that is by first calling your class, which is person, and then that name of the class variable address. So address. So are you from New York? And let's add a space here plus, let's say, self dot name. So this method will return are you from New York and then the person's name. So by default it will return are you from New York, Harry? And let's add a question mark here. Okay, let's create a new instance. Let's save it in a variable called xx. Then we'll create a person instance and just pass last name. Okay, now if we call xx.tab, we see that we have a lot more methods and attributes available for us. So we have address, we have the ask person method, we have the greet person method, and of course our three attributes: last name, name, and telephone. So let's greet person, run it. So greet person by itself, as we mentioned, is of class instance, and in order to call that greet person method, we have to include parentheses, right? So xx dot greet person and then include parentheses. So this method will greet Harry Smith and it will say hello and welcome Harry Smith. Now let's access this ask person method. So xx dot select ask person, include a parenthesis and run it. It says are you from New York, Harry? Okay, so this is how you can access various methods within your class. And if you have any class variables, you can access those variables by first mentioning your class name and then the class variable name. And as I mentioned, we can use those class variables in any of our methods within our class. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on docstrings in Python. Docstring means documentation strings, and these docstrings, they give us more information about our class, function, methods, attributes, and so on. So anything that we have in our class, we can give more information by using docstrings, and we can provide information regarding our class, what the class does, the different methods in our class, what they do, and the various attributes that we have in our class. And usually we give like a one-line summary for our class, but if we want to provide more details, we can do that. Let's look at an example. So I just copied this from our earlier lecture. Here we have a class known as person, and then we have our init special method and the various attributes, and we have initialized our attributes here. Let's see how we can create a docstring for this person class. So we create docstrings by using triple double quotes or triple single quotes. So triple double quotes or triple single quotes, and then docstring goes inside. That's how we can create docstrings. So let's create a simple docstring for our person class. So we'll have our triple double quotes, and then so information about our class. We can say class to represent a person. So this is a simple docstring, and usually this is what you will see, just a simple a one-line information about the class. And docstrings are usually important for when other people read your code, they will have more information about what the functions and methods do in your code. However, if you are writing your code, you already know what the code does, right? That's why you see only just a single line that gives you a general information about your class. So this is a docstring. Okay, and if you want to find out more information about this docstring, this document, you can simply use the help function, help, and then pass name of your class, in this case person, and then run it. So here you see you have your class person and then your document string, your docstring, class to represent a person. Good. Now let's take this further and then add some more info, some more docstring to our person class. Let's add some more information here. Okay, so we'll put the information in multiple lines. So in addition to our class to represent a person, let's add some more attributes. Let's say attributes. So our person class takes 3 attributes: name, last name, and telephone. We can include those. You can say name, and we can give more information about the name. So that will be first name of the person, then we have last name of the person, and then we have telephone of the person. Similarly, we can add a docstring to our init method. Let's do that. So we can say we have our triple double quotes, and then we can say this is the person's, or we can say the person init method, So that will be a one line docstring for this init special method. And if you want to add additional docstring, you can do that. Let's say, so it has this parameters, right? You can say parameters or attributes or arguments, whatever you want to call them. Let's say we have name. So this name will initialize our name attribute. We have last name. Last name initializes our last name attribute. And then we have telephone. This will initializes our telephone, and then we can add some more info for that. Default value is, then specify the default value 445 342 342 1245. So you can add as much information as you want. Okay, then you enclose your triple double quote. Now if you call the help function on your person class, you will see the docstring. So we have class person, then class to represent a person. We have attributes, name, last name, and telephone. Methods defined here. Then we have the init special method. So docstring for that, the person init method. We have parameters, name, last name, and telephone. So to make it more readable, we can indent those, right? But depending on, this will be more readable. Let's run it again. Let's call the help function again. We have that class to represent a person. The attributes are name, last name, telephone, and the init method, the person init method. Parameters are name, last name, telephone. So this is how you can write detailed docstring. And as I mentioned earlier, usually it's a one line statement. Let's look at another example. I just copied this from one of our previous lectures. It has three methods. Our special init method, greet person, and then ask person method. We can simply add docstring to this class. We can simply say, so I'll make this a short docstring. You can say class to represent a person. I'll just keep it short, nice and simple. And then we can say, for our init method, we can say person init method. For our greet person method, we'll simply say method to greet a person. And then finally, for the ask person method, we can simply say method to ask persons, let's say whereabouts. You can just add a one line nice representation to your class. Okay, let's run it. Now if you call the help method or function and then pass the person class, so we have class person, class to represent a person, you have the methods, and then for the init method we have %init method, and for the ask person method, so it's method to ask person's whereabouts. And then for the greet person method, we have method to greet a person. Great. This is how we can use docstrings. And just to summarize, we use docstrings to provide more information about our class, what the different functions and methods do, and any further information that we want to provide. Thank you, everyone. Hello, everyone, and welcome to the lecture on inheritance and method overriding. In this lecture, we look at what inheritance is, its importance, and we'll briefly look at method overriding. Let's start with what inheritance is. Inheritance, as its name implies, it's a method where a class inherits properties and methods from another class. So in this case, we'll have a parent class. Let's say parent, and then this parent class has methods. It has methods. Let's say method 1, method 2, and let's say method 3. And let's say we have another class known as child, and just this child class inherits methods from the parent class. And then it will have, let's say, method 4, method 5, and let's add method 1. So this is the general outline for inheritance. We have our parent class, and then we have our child class. In this case, this child class inherits from the parent class. So we pass it in parentheses. And the parent class has 3 methods, methods 1, 2, and 3. And by inheriting this parent class, this child class is able to access the methods that the parent class has. So in this case, if I want to use, let's say, methods 2 and 3, I don't have to redefine those methods in my child class here. So by simply inheriting the parent class, the methods inside the parent class will be accessible and ready to use for the child class. So here the child class will be able to use these methods 4 and 5 and these 3 methods from our parent class. So that's inheritance. And let me give you a brief example of method overriding. Here I have, in the child class, I have method 1, and in the parent class, I have method 1. Let's say this method returns, let's say this method prints hi. So it simply prints that statement. And let's say this method prints hi there. So even if this child class inherits method 1 from the parent class, it's able to override this method. Since we also have method 1 in our child class, it's able to override this method and then apply its own method. Since we have a method here, print hi here, when we access method 1, this will be printed. Hi there will be printed instead of hi. That's what method overriding is. Even if we inherit a method, we can still override that method by accessing the same method that we have in the child class. Great. Next, let's see an example of inheritance. We'll create two classes. One, I'll call it a house class, and then we'll create a second class, and we'll call that class a kitchen class. Class kitchen, and that class will inherit from our house class. Okay, let's say this is kitchen class and inherits from house class. That's a simple docstring. Let me go back to the house class and create a few methods in it. Okay, we can say this is our house class. This is our house. We can say parent class. Let's create some methods in it. So as we know, the first is the init method. Then we'll simply pass self as its attribute. And then we can simply print this is a house. Let's add a few more methods. Another method we can add, let's say define, and then color. We'll pass self as its attribute. Then this method will simply print I am red. Okay, let's add a few more methods. Let's say size, and then pass self as its attribute, and let's print I am, let's say 3,500 square feet. Let's add some more methods. Define location, and then I'll pass self as its attribute. Print I am in New York. Then let's add one more method. Then we'll call it kind, and it takes self as its attribute. Then let's print I am a townhouse. Next, let's create our kitchen class. Let's initialize and add some more methods in our kitchen class. So the first one is the init method. In it, then it takes self as its attribute, and then within the init method we will have to initialize the house instance. Okay, that's how it knows that it will be inheriting from this house class. So we'll be initializing the house instance. So we have our house class name, that, then we call the init method, init, and then it takes self as an attribute. Okay, so this is initializing the house instance, and then we can, the kitchen init method can print out the following: I am a kitchen, kitchen. Let's add some more methods. So define color, self, print I am cream in color. Let's add another function, call it, let's say oven. Then we'll pass the self attribute, print, let's say I make food. And let's pass one more method and define size. We'll pass self as its attribute. Let's print a couple of statements. I am no longer 3,500 square feet. Let's also print I am now 800 square feet. Okay, now that we have our two classes, let's initialize or create an instance of this kitchen class. So we'll create an instance of the kitchen class, and then so our kitchen class, as you see here, it takes one attribute, one argument, the self argument, and we don't have to specify self, we can just leave it like that. And let's save this instance of the kitchen class in a variable called, let's say, x. Now if we run x, two statements are printed. This is a house and I am a kitchen. So if we go to the init method, so within the init method we have the houses init method. So it's referring to, it's accessing the houses init method. So if you go to the house class, its init method has this statement, this is a house. Okay, so we are accessing the init method of the parent class. That's why this statement, this first statement is printed, this is a house. And the init method of our kitchen class also has this print statement, I am a kitchen. Therefore, the second statement is printed, I am a kitchen, right? Now, if we say x dot and then hit tab, you'll see a list of available methods that we have. We have color, kind, location, oven, and size. Even if we only have size, oven, and then color methods in our kitchen class, so color, oven, and size, right? Color, oven, and size in our kitchen class, we see two more methods here, kind and location. And those two methods come from the parent class, right? The parent house class has kind and location. So because of inheritance, we are able to access even methods that we don't directly have in our kitchen class. Let's access some of these methods. So x dot tab, let's access oven. Don't forget the parentheses. So x dot oven, where is the oven method? So the oven method is in the kitchen class. So this statement will be printed, I make food. Let's run it. I make food. Okay. X dot hit tab. Let's access color. Let's access the color method. Let's see. So we have color in the kitchen class, and we also have color in the house class. Even if we are inheriting this color method from our house class, it will be overridden by the color class in our kitchen. So that's an example of method overriding. So if we run this, we'll get this, I am cream in color. Let's run it. I am cream in color. So that's overriding. However, if we comment out this color method and then create an instance of our object again, and if we run this color method, we'll get I am red in color. Let's run it. Now it's I am red. So that's method overriding. Next, let's see. So far we have seen color, we have seen oven, x dot the oven method. We have seen the color method. Let's see kind. So x dot kind. So where is the kind method? We don't have kind method in the kitchen class, so it will be inheriting it from the house class, and therefore print this statement: I am a townhouse. So if we run that, we get the statement: I am a townhouse. Okay, x.tab, let's access location. Where is location? Similarly, location is found in the house class, which is the parent class, and because of inheritance, we are able to access the location method, which is found in the house parent class, and therefore this statement, I am in New York, will be the result. So I am in New York. And finally, we have the size method. So if we look at the size method, it's found in both the kitchen and then house class, and due to method overriding, these two statements will be printed. I am no longer 3,500 square feet, and then I am now 800 square feet. Let's run it, and we have those two statements. So this is an example of class inheritance and overriding. Okay, we have our parent class, and then we have our child class. When we create our child class, in parentheses we pass our parent class. In this case, house is the parent class, and then we start with our special init method for our kitchen class, and we also have to initialize the house instance, which is the parent class. That's important. So in this example, we are inheriting from one parent class. Okay. In the coming lectures, we'll see an example of how we can do multiple inheritance, how we can inherit from more than one class. Okay, we have a lecture that will cover that. Great. Thank you, everyone, and see you at the next lecture. Hello, everyone, and welcome to the exercise on object-oriented programming. Here are the instructions for the exercise. Let's go through the instructions. It says, write a program called a fraction, which accepts attributes numerator and denominator, and returns a string representation of a fraction. You will need two methods that will get the numerator and denominator. You will also need two methods that will set the numerator and denominator. Don't forget to check the denominator, and it cannot be 0. So we can have an if-else statement to check for this condition. And finally, try to include a one-line docstring for your class and the methods involved. So this is just a program to see if a number is a fraction. Fraction means a rational number. So the numerator can be any integer, whereas the denominator cannot be 0. So try the exercise, take a moment, and then we'll see the solution together. Great. Let's see the solution together. Let's start by defining our class. So class, we'll call it a fraction, And let's add some docstring to our class. Our class represents a fraction, and then we have our first method, the init method. Let's define our init method. It accepts self as its first parameter, and as the instruction says, it accepts two parameters, numerator and denominator. So if I go back here, it accepts two attributes or parameters, numerator and denominator. Okay, and it says we'll need two methods that will get the numerator and denominator. So let's initialize our attributes numerator and denominator. We can say self that, let's say numerator, self that numerator is equal to num. So we'll have a separate function that will get the numerator, and once we get the numerator using that method, we'll set it to be equal to the numerator. So self that numerator is equal to numerator, and for our denominator we need to check that it's not equal to 0. We can say if our denominator is not equal to 0, or if it's different from 0, so not equal to 0, we can say self that denominator is equal to denom. Again, we'll also have a separate method that will set the denominator. Or else we can print a message like there was an error with your calculation, and we can exit the program. In such case, I will show you a trick. There is a module called sys. So from sys we'll import exit, and then we'll simply exit. So in case a user enters 0 for denominator, our program will be executed, will be exited. That's what this does. From system import exit, and we'll simply exit and close out the program, so we won't get an error. Great. Next we have, it says here, you will need two methods that will get the denominator and numerator. Let's define those two functions, those two methods. So the first one, define, we can say get numerator, and then it accepts self as its parameter or argument, and this will simply return the numerator. So we can say return self that numerator. We can initialize it also. We can say, let's say this will return the numerator. Okay, we can say that, and then it will return the numerator so that we can use it in our init method. And similarly, let's define another method that will return the denominator. So define get denominator, and then it accepts self as its attribute, and this method will simply return the denominator. Let's initialize it. This will return the denominator. and it will simply return self.denominator. Great. Next we will also need two methods that will set the numerator and denominator. Okay, let's define our first function, our first method. So let's define our method. Let's call it set numerator. Then it will accept self as an attribute and also a numerator. Let's call it nu for numerator. Basically, when a user enters a numerator, we'll use this method to set the numerator. And once we set that numerator, we can use it using the get denominator, which we will later use in our init method. Okay, so let's initialize our attribute numerator nu. Before that, let's include a docstring. We can say this will set the numerator or something like that. Okay, so self.numerator is equal to nu for numerator. Similarly, we'll have another method called set denominator, and it accepts self and a second attribute. Let's call it de for denominator. You can name it whatever you like. Let's include a docstring. This will set the denominator, and the denominator cannot be 0, right? So this will set the denominator. If denominator is equal to 0, it will terminate the program or exit the program. Terminate and exit the program. That should be good. Now let's initialize our attribute de. We can say if our denominator is different from 0, if it's not equal to 0, we can say self.denominator is equal to de, or else we need to terminate the program. So same thing that we did here. Or else we can print, let's say, denominator cannot be 0. And let's import sys module, and then we'll import the exit function, and we'll simply exit the program in case the denominator is 0. Okay, that should be good. And finally we have, don't forget to, okay, we did that. Try to include a nice and short one line. We did that also. And we are missing, okay, here it says return a string representation of our fraction. So what we'll do is we'll use the str method. Let's define that so that we get a nice string representation of our fraction. Okay, define underscore underscore str underscore underscore, and it will take self as its attribute or parameter. Okay, let's include a docstring. This will return a string representation of our fraction. That should be good. And this will simply return a string representation of our. So in this case, what's important is we'll have our numerator. So we'll use this function to get our numerator, and we'll divide it by our denominator, which we get by using the get denominator function. So that will be our fraction, right? Denominator divided by the numerator divided by denominator. So we'll have our self that get numerator. The reason I'm casting it as a string is because this is an integer, so we need to cast it to a string. So we have that. So this method will return our numerator. It will get our numerator and then convert it to a string. So we have that plus divided by, and we'll do the same thing for our denominator. Once we get it, we'll cast it into a string. So self that get denominator, right? And then we can, so to make it nice, we'll define the main function, define main, and we'll place all the things we want to do in the main function. And later we can call this main function and it will execute all the things that we want. Okay, so let's initialize an instance of our fraction class. Let's say fraction1, and we'll save the first instance in this variable fraction1, and we'll set it to be equal to fraction, and let's try 2 and 7. Okay, and then let's have another instance called fraction2. Let's say fraction, and then 3 and 8. Okay, and then we can print, let's print underneath each of them. Print fraction1, and here we can print fraction2, and before that let's print, now we will change the numerator and denominator to different numbers and then see the result. Okay, we can say fraction1 dot set the numerator. So initially it was 2. Now let's make it 9. So we'll set the numerator to 9, and let's do the same thing for our denominator. So fraction1 dot set denominator, and let's set it to 19. Then we can print fraction1 now. Then let's print some lines in between, say times 10. And next we'll call our main function and see the result. I'll go over our program one more time and explain what each of the methods do. Let me run it first. Okay, 2 over 7. Now we will change the numerator and denominator to different numbers. We have 9 over 19, 3 over 8. Good. It works good. Now let me go over our program. So we have our fraction class, and then our class represents a fraction. We have our init method. It accepts 2 attributes here, numerator num and denominator, and we initialize the denominator and numerator attributes. Self.numerator is equal to num, and then we have self.denominator is equal to denominator. Okay, and here we have an if-else condition to check if the denominator is not 0. If the denominator is 0, we use this to exit our program. Okay, from sys import exit. So this will exit the program in case our denominator is set to 0. And the self.numerator and self.numerator, denominator and numerator, we have separate methods to get those values. And once we get those values using the get numerator and get denominator, we use them in our init method. So we have our get numerator method, which will simply return the numerator of our class, and we have the get denominator method, which will simply return the denominator. And we have this set numerator and set denominator methods. So those methods will set the numerator and denominator respectively. So this is in case the user enters a numerator. So let's say the user enters some numerator, let's say 10. So it will set, this method will set the numerator to 10, and then so that our get method can get that, our get numerator method can get that numerator. So user inputs, we have this method set numerator, and the get numerator method will get that numerator from this method, and then later on it will be used by our init method. And that's what the set numerator does. It does the same thing for denominator, and it also checks that the denominator is not 0. In case the denominator is 0, it will exit the program. And finally, we have our special str method, which returns a nice string representation of our fraction. So it returns a string representation of our get numerator method divided by a string representation of our get denominator function. So numerator divided by denominator. That's why you see here a nice string representation. Okay, and we put everything we want to do in this main method. So later on, by simply calling the main method, we are able to execute all of this instead of typing one by one, initializing the class, typing one by one. We can simply call the main method. Okay, and in the next lecture we'll continue with what we have here. We'll briefly explain this main method and what each of these codes do. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome back. In the last lecture we defined several methods that will get and set the numerator and denominator for our class, and we defined this method main, which we can use to input what we want to do and later on call that main method to execute the program once. So here we created an instance of our fraction class and saved it in a variable called fraction1, and our fraction class, the init method accepts 2 attributes. So we passed numerator and denominator values, and we said to print fraction 1. So here we can also print, so our fraction 1 is an instance of our fraction class, so we can use any of the methods inside our class. So we can get the denominator and numerator for our fraction 1 object. So we can print, let's say, fraction 1 dot get denominator, and we'll also get the numerator. Say fraction 1 dot get denominator, numerator, I mean numerator, and we can add some statement here. For instance, we can say the numerator of our fraction 1 object is, and let's also do the same for our get denominator method. We can say the denominator of our fraction 1 object or class is, then we have our get denominator function here. Okay, and let's print a line in between. Let's say that times 10. Okay, next we have print. Now we will change the numerator and denominator to different numbers. So fraction 1 dot set numerator, we use the set numerator method to set a new numerator, and then we did the same for our denominator using the set denominator method. We'll be setting a new denominator. Okay, fraction 1 dot set denominator, then we have fraction 1 dot set denominator. Okay, and let's print these two statements again. Command C, here Command V. So the numerator of our fraction 1 and the denominator of our fraction 1 got get in. Okay, and we can print our fraction, print our new fraction is, then we can say fraction 1. So that will be our new fraction. So let's run it. So initially we have 2 over 7, right? And then the numerator of our fraction 1 object is 2, good. And the denominator of our fraction 1 object is 7, good. It says now we will change the numerator and denominator to different numbers. So after we change it, the numerator of our fraction 1 object is 9, and the denominator of our fraction 1 object is 19. Our new fraction is 9 over 19. So it looks good, right? Even if we set it to certain numbers initially, we can use the set numerator function or method to set it to different numbers, right? And we use the get numerator and get denominator methods to display what those values are. And that also helps us in representing a nice string format of our fraction. Okay, let me include that. And next we have 3 over 8. So we have another, okay, we initiated another class of our fraction and saved it in a variable called fraction2. Fraction2 is equal to fraction 3/8 print fraction2, and we can do the same thing as we did here, right? And what other things can we do? So let's say print fraction2, and then we can say print, let me copy paste what we have before. The numerator of our fraction2 object is, in this case it will be fraction2 dot get numerator and fraction2 dot get denominator of our fraction2 object is, now we are initializing another instance of our fraction class and save it in fraction2 variable. Okay, so print fraction2, and then we have our numerator and denominator. So while we are here, we can change it to different values using the set numerator and denominator functions. So that's what we'll do next. Let me copy the statement and paste it here. So what we'll do is we will now change, okay, we will now change the numerator and denominator of our fraction2 object to different numbers. Okay, let's do that. So we have fraction2 dot set numerator, and then let's set it to, let's say 24, and let's do the same for our denominator. Fraction2 dot set denominator to, let's say 55. Okay, let's print a new line here so that it's more visible and clear. Times 10. Next we can print our new fraction2 numerator and denominators. So we can print, just to save some time I will copy paste the statements here. Command C and paste it here. Command V. The numerator of our fraction2 object is, we can say the new numerator of our fraction2 object is fraction2 dot get denominator and fraction2 dot get numerator. So when we execute the statement, we'll get, first we are printing fraction2 3/8, and this get numerator function will get the numerator, which is 3, and then this get denominator method will get the denominator, which is 8, and then we'll change the numerator and denominator to new numbers using the set numerator and set denominator methods, and we'll set our new numerator to be 24, which we will get by using the fraction2 dot get numerator function or method, and the denominator will be 55. Let's run it. So we have seen up to here, this is for fraction 1. Now we're looking at fraction 2. So initially we have 3/8, then the numerator is 3, denominator is 8, makes sense, and then we'll change the numerator to two different numbers, which is 24 for our numerator and denominator is 55. We can also print our new fraction, right? Which is this line. Our new fraction is, then we'll print fraction 2. Let me copy this, print it here. So our new fraction is fraction 2. So we are calling fraction 2, which in turn calls the init method, and then it will give us a nice string representation of our fraction 2 object. Let's run it again. So finally we have our new fraction is 24 divided by 55. Okay, so far it's good. What if we have 0 for our denominator? What will we get? So in case we use 0, it will exit the program. Let me show you that. Let's add a new line first. Then we can paste it and set a new instance and save it in a variable called fraction3. And let's change this to 4 and denominator to 0, and let's simply print fraction 3. So in this case, so we have all our first two fraction objects, right? We have our first two instances of our fraction class. So that's our fraction 1 object. This is for our fraction 2 object. And then here we have, there was an error with your calculation, which is what we put here, right? In our init method, if denominator is 0, we are printing the statement, there was an error with your calculation, and then it's telling the program to exit, right? That's what this statement does. From system import exit, and then we are using the exit method or function. So that's what we have here. An exception has occurred, so system exit. Okay, that's what this does. So this is what our program does. Just to summarize, we created a fraction class, and then this is fraction. So we have a one line representation, a document string for our class object and each of our methods in our class. And you can use, for our init, you can add a one line document string. You can say this will initialize our attributes, initialize attributes numerator and denominator. So usually we don't need this to read our own code, because if I'm writing this code, I know exactly what I'm doing, so I don't need this document strings. Usually people put a nice and short descriptive document string in the class. So you'll see, if you are reading people's code, you'll only see this document string, our class that represents a fraction. That's what you'll mostly see, right? Because if I am reading my own code, I know exactly what each of these methods do. But for others, this is a very clear description. So one line description of each of the methods. I just wanted to quickly show you that, right? So we have our init method, get numerator and denominator methods, which will return the denominator and numerator, and the set numerator and set denominator methods set numerator and denominators. And we have our special str method that will return a nice string representation of our fraction object. Okay, and we put everything that we want to calculate in the main method. You see here, we put everything in the main method, and we just called the main method once to calculate all of this, right? So that's the importance of the main method. Otherwise, we will have to instantiate, we have to come to a new cell and then instantiate our fraction class every time. We'll have to say fraction1 is equal to, right, fraction, and then pass the attributes. We gotta do that, and then say, you know, print fraction1, and then print, you know, fraction1 that, for instance, we can say get denominator, and then, you know, execute this, go to a new cell, instantiate a new class. You know, instead of doing all of that, we can place it in our main method here, and then just simply call the main method. And whenever we want to add more things, we can place them in our main method. Great. That's what I have for this exercise. Thank you, everyone, and I'll see you at the next lecture. Hello, everyone, and welcome to the exercise on object-oriented programming. Here is the instruction for our exercise. It says write a program with a class name myAccount, and its special init method takes 3 attributes, which are number, name, and balance. Initialize the attributes, and also initialize and define a minimum balance attribute and set it to be equal to 500, and also set the account to be active initially by setting it to be true. You will also need 2 minimum methods, deposit and withdraw methods. The deposit method will add deposit to your amount if the account balance is greater than 0. And the withdraw method will take amount out of your account, and it will require a minimum balance of 500 to be in your account. You will also need 2 additional methods. One is a set active method that will activate or deactivate your account, and you'll also need another method called, let's say, is active, and that will return true if your balance is greater than 0. So once we write this program, we'll use it to add amount or withdraw if we will be able to withdraw or make a deposit. Okay, great. Now that you have tried the exercise, let's see the solution together. We'll start by creating a class name. We'll name our class myAccount, and we'll define our method, our special init method, and it takes self as its first attribute, and number, name, and balance. Then let's instantiate this attributes. So the first one is this number. That's basically our account number. So you can say self that account number. Self that account number is equal to number. Next, let's initialize the name. Self that name is equal to name. So that will be the account holder's name. And finally, we have our balance. Self.balance is equal to balance. And let's also instantiate a minimum amount balance. So self.minimum balance is equal to, let's set it to be 500. And finally, we'll have a self.active, and we'll set it to be true. So later on, we'll have a method called setActive, and that will set, by default, it will be active. That means if the balance is greater than 0. Otherwise, our account will be inactive. Okay. Now that we have defined our init method, let's define another method called deposit. So this method accepts self as its attribute and an amount. So we'll use this method to deposit money to our account. And our account has to be positive. Okay, the balance has to be greater than 0. Otherwise, we won't be able to deposit. So this method, this will deposit amount to our account if balance is greater than 0. This will deposit amount if account balance is greater than 0. Okay, so we can say if self that is active, we'll define this method later on, and this method is active if balance is greater than 0. So if self that is active, we can say self that balance plus equal to amount, right? So self that balance is equal to self plus balance plus the new amount we deposited. And this method will then return true if the condition is true. If the if condition is true, it will return true. Whereas if this if condition is false, what's going to happen? So let's have an else statement. Else, let's print something like you will need to go to the nearest branch or something like that. So if their account is less than or equal to 0, they will have to go to the nearest branch and make that deposit or something like that. So in that case, we'll return false. Okay, that's good. Next, let's define a method for withdrawing money, and let's call it withdraw, and it takes two attributes, self and amount. So what this method does is that it just withdraws money from our account, and we'll need a minimum balance of 500. So this will withdraw amount if balance is greater than 500. Okay, let's define a variable called result, and we'll set it to be false initially. So if this condition is not true, the result will be false. And for a person to withdraw money, first of all, the account has to be active and the balance has to be over 500. So let's have those conditions. If first it has to be active, right? So if self that is active, again we'll define this method later on. If self that is active, that's one condition, and the second one is our balance amount, right? And if self that balance minus the amount we want to withdraw, it has to be greater than or equal to 500, right? So greater than or equal to self that, and 500 is our minimum balance. So if it's greater than or equal to self that minimum balance, we can say, so they will be, in this case, they will be able to withdraw money. And then we'll need to calculate the new balance after they withdraw money. In that case, the new balance, self that balance, is equal to the old balance minus the amount. So we'll set it to be equal to minus equal amount. So self that balance is equal to self that balance minus amount, right? So, and then at this point we'll set the result to be true. That means successful withdrawal at this point. And then let's have our else condition. Else we can print, or else we'll print a message like you will need a minimum balance of greater than 500. That should work. Then we'll finally return the result. Then return result. So we'll start with a default result of false, and if the account is active and if the balance is over the minimum balance, or we can make this greater than the minimum balance, which means over 500. We'll return, they will be able to withdraw, and our method will return true, or else we'll display this message, you'll need a minimum balance of greater than 500, and then we'll return the result. Next, let's define two functions. I think we need two more methods, the set active method and the is active method we have seen so far. Let's do that. So define a method called set active, and it takes self as its attribute and another account, some other attribute, let's say account, okay, ACTT. That's just an attribute, and this is just to activate or to deactivate our account. Okay, this method will activate or deactivate our account. Okay, so we'll set it to be self that active is equal to our attribute act, and finally we'll have our function is active, our method is active, and then it takes self as its attribute. So this will return true if the balance is greater than 0. So if self that balance is greater than 0, our method will return self that active, or else it will return false. Else return false. So if the balance is greater than 0, it will return self.active. Self.active is true by default. Oh, this is also self. So this is self. And if the balance is less than or equal to 0, it will return false. Okay, let's see what we did here. Our init method takes 3 attributes in addition to self: name, number, and balance. So we initialized our attributes here. Self.account number is equal to number, self.name is equal to name, and balance. And we initialized a minimum balance of 500. And we set our account to be active initially. Right? Self.active is equal to true. Then we define a method called deposit. And we have a method to withdraw, set active, and is active. We'll continue our discussion in the next lecture. Thank you, everyone. Hello, everyone, and welcome back. Let's continue our discussion on our exercise. Okay. In the last lecture, we stopped after the init method. And the next method we have is the deposit method. It takes one attribute, amount. And this method will deposit amount if our account balance is greater than 0. So for that, first it has to be active, right? For our account to be active means its balance is greater than 0. So if self that is active, if that's true, which we have down here, right, that checks, the isActive method checks if our balance is greater than 0. So if balance is greater than 0, add or deposit whatever amount you want to deposit, and it will return the final balance after the amount is deposited. Or else it will return false, and we'll have a message saying you will need to go to the nearest branch. So if they have a negative balance, they will have to go to the closest branch office. Then we have a withdraw method, which takes the attribute amount, and this method will withdraw an amount if balance is over 500. So by default we start with a value of false, and to withdraw some money, first the account has to be active and the balance has to be over 500. That's why we use AND. AND means both of these conditions have to be true. So it has to be active, and also the minimum balance has to be greater than 500. That means self.balance minus the amount is greater than self.minimum balance. So I cannot have a balance of, let's say, $500 and try to take out $600. Okay, and that will later give us the balance after we withdraw the amount we want to withdraw. Or else we'll display a message saying you'll need a minimum balance of greater than 500. And finally, this message will return the result, either true or false, right? And here we have our set active method, and this method will activate or deactivate our account, and it takes one attribute. And finally, we have our isActive method, and this method we'll set the amount to be active if balance is greater than 0. Otherwise, it will return false. Great. Next, let's instantiate our myAccount class. Okay. And then let's save it in a variable called account. Okay. And we'll set the account to be equal to account. So we are initializing our class object, our class myAccount, and let's pass. So our account takes, our class myAccount takes, in addition to self, it takes 3 attributes, right? Account number, name, and balance. So account number, you can pass any number that you like. I'll just pass 54545. Account number, is it name next or balance? Next is name and then balance. Name, let's say Jane, and then balance, let's start with a balance of $1,000. Okay. Okay. Now that we have our account object, if we say account dot and then hit tab on your keyboard, you'll see the various methods and attributes that we have for our account object, right? We have account.name, account.deposit, account.balance, and so on. So let's deposit some amount. So account.deposit, let's deposit 300. So initially our balance is what? 1,000, and now we are depositing 300. Let's run it. So it's true. That's because our account is active and we are able to deposit if our balance is greater than 0. So now if we check our balance, it should be what? 1,000 plus 300, which is 1,300. So if we call the account.balance method, we have 1,300, right? So at this instance, if we check if our account is active or inactive, it should be true. It should be active, right? Since our balance is greater than 0. So if we check that, it's true. Next, let's see what other methods that we have. Let's try to withdraw some money. So we'll choose withdraw. So account.withdraw, let's withdraw $800. So if we run it, so here account.withdraw 800, it says you'll need a minimum balance of greater than 500, and then we're not able to withdraw. It returned false. So if we take 800 out of 1,300, that means we'll be left with exactly $500. And for us to make a withdrawal, we have set it to have a balance of greater than 500 to remain in our account. So in this case, if we change the amount to $799, we should be able to withdraw, right? Because $501 will be left. So we should be able to withdraw. Let's run it. So now it's true. If we call our balance attribute, now we should be left with what? $501? Yes, 501. Now we won't be able to withdraw. So if we try to withdraw an additional amount, even $10, that will be false. And it says you'll need a minimum balance of greater than 500, right? should we be able to deposit now? Yes. As long as our balance is greater than 0, we should be able to deposit. So account that deposit, let's deposit $100. True. Now if we check the balance, account that balance should be 601. Now we can withdraw some amount. We can withdraw, for instance, $41, and that will return true. True. Now our balance should be 601 minus 41, which is 560, right? Other things that we can check for our account. So account that hit tab. Currently is our account active? That's true. What other things can we check? Okay, if we check the is active method also, we'll get true for our account is active. What else? If we call for minimum balance attribute, it should be at least $500, right? So our minimum balance is 500. So we can change that minimum balance to 501. So let's change the minimum balance to 501. That way it goes along with the other parameters. To withdraw, the account has to be greater than 500. You'll need a minimum balance of greater than 500. Or we can say greater than or equal to 501. You can use that. You have the idea. I'll just leave it like this. Okay. Let's run it again. Count that deposit. Now, if we check the balance, 1300, we should be able to deposit. Run the balance, 1400. We should be able to withdraw 750. That's true. If we call the minimum balance now, it should be 501. Then what else? Account that name should be Jane. Okay. Now let's instantiate another object of our class. Let's say account2 is equal to my account, and then it takes 3 attributes: account number, name, let's say Smith, and then balance. Let's start with a 0 balance or negative amount. Okay, let's say negative 100. Now if we check if account 2 is active, that should be false, right? Because the balance is less than 0. So if we call our is active method, we'll get false. And if we try to deposit an amount, we won't be able to deposit, because in order for us to make a deposit, the balance has to be greater than 0. So account that, let's call the deposit method. If we try to deposit, let's say $2,000, it should display the message, where is it? Go and check your nearest branch. Yes. So you'll need to go to the nearest branch. So let's run it. It says you'll need to go to the nearest branch. Let me show you one more thing. Let's instantiate another object of our class method. Account3 is equal to my account. Let's say account number is that, and name is, let's say, Joe, and balances, let's say 3,000, right? So if we check if account is active now, account 3 that is active, it should be true. However, so once the account is active, we should be able to withdraw or deposit any amount that we want, right? I mean, as long as it's a valid amount. Let's say we can deposit 200, that should return true, and we can withdraw some amount. Let's say we can withdraw $400 in this case, it's true. And if we check the balance, we have 2,800. And one thing we can do is we have this active method that we can use, the set active method that we can use to activate or deactivate our account. So we can call the set active method. So we have our account 3 that set active, and it takes, in addition to self, it takes another attribute, right? It takes one more attribute, and by default we have set it to be equal to true. And if we pass this false parameter, it will set the account to be inactive. So now if I check account 3 that is active, that will be false, because now I have changed it to inactive, right? Initially by default it was true, but now I have set it to false, right? By calling the set active method. So this is like if you want to freeze the account of a person, no matter how much balance you have, banks can freeze your account for some reason or another. So this is a similar method. We can also do that, right? Just wanted to quickly show you this method, the set active method. Great. As an exercise for you, you can also change this minimum balance amount to, let's say, $50 or $300 or $1,000, and try to change some of the conditions and see if you can get or withdraw or deposit amount and so on. Great. Thank you, everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on errors and exceptions handling. In this lecture, we'll define what errors are, and we'll see most kinds of errors. Let's start by our discussion on errors. Errors are usually mistakes made by the programmer. So whoever is coding will be making those errors, and we call those bugs. So we refer to errors as bugs. And usually these errors are due to the programmer. Okay, whoever is writing the codes will most likely be creating these errors. And errors are divided into 3 categories. So most of the errors could be either syntax errors or runtime errors or logical errors. Usually errors fall under these 3 categories. Let's start by looking at syntax errors. So those are one common kind of errors, and those errors are like not defining a keyword, for instance. That would fall under a syntax error. And if you are using or putting an incorrect indentation, you'll get those syntax errors. And if you misspelled a word or use a parenthesis instead of a colon or something like that, that will give you a syntax error. Let's see some examples of syntax errors. Let's see an example. Print hi there, and then forget the closing quote and run it. I get a syntax error, right? So that's one example of syntax error. Another example could be, let's say, if x is equal to 0, and then let's say print hello, run it, you'll get a syntax error. That's because you missed a colon here, right? Or if you simply use, let's say, if we say else print not correct, if you run it, you'll get a syntax error, because in this case you need an if statement for your else statement. Let's say you define a function without the def keyword, and if we say, let's say, function name, then pass a parameter, let's say, let's pass 3 parameters, a, b, c, and return a plus b minus c. So if you run that, you'll get a syntax error because you are missing the def keyword when you defined your function. So these are some examples of syntax errors. Next, let's see some runtime errors. Runtime errors. Runtime errors will not have any kind of syntax errors. So your syntax could be correct in this case. However, you will run into this runtime errors. For instance, if you are trying to divide a number by 0, or if you try to use a variable that you haven't defined, or if you try to open a file which doesn't exist, you will run into this runtime errors. For instance, if you say 5 divided by 0, this is a runtime error. There is nothing wrong with this expression, right? You are trying to divide one number by another, but the problem is that division by 0 is not allowed. So you run into that error. And another example of runtime error is if you are trying to open a file that doesn't exist, you'll run into a runtime error. The last category of errors is logical errors. So logical error is a little bit different than the other two categories. That's because these logical errors are a bit harder to find a solution or fix them. That's because it deals with logic. For instance, if you are, let's say, if you are using an if statement, let's say x is equal to 0, and then let's use an if statement. You can say if x is equal to 5, you can, print some statement here, and then while x, and if x double equal to 5, you can check some other conditions. For instance, you can say if x's. You can have some conditions here, and then you can have another if with an if. So in case, let's say you have a nested if statement, and you could have one of the nested ifs in the wrong indentation. Okay, you could indent one of these if blocks to the wrong levels, and that will run into a logical error. Even if you have even if your program is correct in its syntax, you could run into some wrong indentations, and that will create problem with the logic of your program, and that will be a logical error, and it's a bit harder to fix compared to the other kinds of errors because you are dealing with logic. Another example of logical error is, let's say you try to add some numbers. Let's say 4 plus 5 minus 7 plus 2 divided by 4 times 6 times 5 minus 3. So if you have statements like this, and if you are not sure of the order of precedence for these operations, you will run into logical errors. For instance, if you expect this operation to be performed from the beginning to the end, let's say, if you are expecting this to be 4 plus 5, 9, 9 minus 7, 2, 2 plus 2 is 4, 4 divided by 4 is 1, 1 times 5, 1 times 5 is 5, 5 minus 3 is 2. So if you expect this operation to result 2, and when you run this, you get -1. So that's a logical error. It's different from your expectation, right? That's because you are not quite sure of the order of operation precedence. So that falls under logical errors. That's why it makes it hard to fix those logical errors. So the errors or exceptions that we encounter while programming fall under these 3 categories: syntax, runtime, or logical errors. This is the broad category, but you'll be seeing a lot of errors. For instance, so far we have seen syntax errors, we have run across key errors, indentation errors, you might run into that, but you'll see so many other kinds of errors or exceptions. For instance, IO error, syntax error, system exit error, index errors, zero division errors, end of file error, import error, and so on. But whatever error you see, they fall into one of these 3 categories in general. Okay, this is also a general introduction into errors and exceptions in Python. And in the next lecture, we'll see how to handle these errors or exceptions. We'll see how we can handle them by including statements like try and except. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on errors and exception handling. In this lecture, we'll see how to handle errors or exceptions by using the try and except statements. We saw that errors or mistakes could happen while we run our program, and exceptions are errors in Python. So we call them errors or exceptions. We'll see how to handle errors or exceptions by using the try and except statements. So the format for using try and except looks like the following. We have our try keyword and then colon, new line. So our statements go here. Our statements go here. So we can have one or multiple statement. And then we'll have our except keyword. And then there will be some code here. So execute this part if exception occurs. So this is the general format for try and except. So try your code here, and if there is any exception, execute this part. So in our except statement, we can leave it like that, or if you know the kind of exception, you can name it here. For instance, you can say value error. So these are optional. You don't necessarily have to give your exception a name. And another thing with try and except is you can have one or more except statements. For instance, if you are anticipating, or if you know, let's say two different kinds of exceptions could happen, you can say except and then name of the exception. For instance, I can say 0 division error or something like that, and then in that case it will execute this part of the exception. And in the first exception, in the first except statement, you could expect, let's say, value error. So if your statement here has a value error, it will execute the value error exception here. And if your statement has a 0 division error, it will execute this part. So this is the general format. Now let's look at some examples. Let's say we prompt a user to enter a number. Okay, so let's use the raw input function. If you are using Python 3, use the input function. I'm using Python 2, so I'll use raw input. And let's say, please enter a number. And then we'll convert this input into an integer. So we'll cast this whole string into an integer. And then once we have that, let's save this in some variable called number, num, and then we'll print out the number you entered is, okay, let's do some formatting, that format, then we'll pass the num. Okay, let's run our code. Please enter a number, let's say 8, run it. We get the number you entered is 8. Okay, so what if I enter something else? Please enter a number. Let's enter A. Run it. We get a value error. It says value error, invalid literal for integer with base 10 A. So our input is invalid. Now let's handle this exception using try and except. So we can say, so this is our statement, right? Prompt a user to enter a number and then display the number the user entered. So we can include that in our try statement. So try, and then inside our try statement, we'll include our statement. So try this, and then if there is an exception, we'll include the except keyword. Except, in case of exception, we can print the number you entered is not an integer or something like that. Okay, now let's run this. Please enter a number, 9. The number you entered is 9. Okay, let's run it again. Please enter a number. Let's say A. Now if we run it, it says the number you entered is not an integer. We no longer get an error, right? Earlier we got a value error, but here we don't get any kind of error. We have handled the exception or error by using the try and except keyword. So try the statements, and if anything fails or if there is an exception, print this statement. So a nice statement is printed. The number you entered is not an integer. As I mentioned earlier, when we use our except statement, we can simply say except colon and then whatever you want to show. Or if you know the kind of error you will get, you can name it. For instance, we know we're gonna get a value error, so you can give your exception a name, except value error. Then run it again. Please enter a number. Let's say JU. Run it. The number you entered is not an integer. So this part is optional. So giving the error name in your except statement is optional. We also mentioned earlier that we can have one or more except statement. Let's look at an example. Let's prompt the user to enter two numbers, and we'll try to divide the first number by the second number. Okay, so we have our raw input function, and then let's say enter the first number. Then we'll cast it to an integer by including everything in parentheses, and then using the integer function we'll cast it into an integer. And let's save their first input in a variable called first, and we'll do the same thing and prompt the user to enter a second number, and we'll save it in a variable called second. Raw input, enter your second number. Then we can print out first number divided by second number. Say print first number. Let's use some formatting. First number divided by second number is equal to, let's say, the result there. Then we can say that format, and then we'll pass our first number, second number, and then the result, which is first number divided by second number. Okay, let's run it. Enter the first number, let's say 9. Enter your second number, 3. So we get first number 9 divided by second number 3 is equal to 3. That's good. Let's run it again. enter first number, let's say 8, enter your second number, let's say 5, run it. First number 8 divided by 5 is 1. Okay, let's import the division module from future. From the future module, import the division function, division. This will allow you to perform true actual division. If you are using Python 3, you don't need to do this, but for Python 2 users, you can import division from the future module. That way we can get the actual result of our division. Okay, let's run our cell again. Enter your first number 9, enter your second number 7. Okay, now we have the true division result. Okay, next what we'll do is let's put a 0 for our denominator. Enter first number 3 divided by second number 0, we'll get an error, right? So we get a 0 division error. We'll include an except statement to handle this 0 division error. And another error that could happen is, what if we enter some other numbers, some other input that's not a number? For instance, enter your first number. What if I say P? Run it. I get another kind of error, right? A value error. So what we'll do next is include 2 except statements to handle those errors, the value error and 0 division error. Let's do that. So we'll try our statement, first number, then second number, and let me copy the print statement also, then paste it here. So try first, second, and then print this. Now let's add our except statements. Except, we can say print you can only enter integers for first and second. So this will take care of the value error. Let me name it value error. And the second kind of exception or error is a 0 division error. So we can say except 0 division error, then print the second number cannot be 0. Okay, now let's run our code. Enter the first number, let's say 8, enter your second number. If we enter 0, we'll get our 0 division error exception. The second number cannot be 0. Okay, let's run it again. Enter your first number 7, enter your second number, let's enter some character, let's say T, enter. You can only enter integers for first and second, right? We got our value error exception. Similarly, if we enter a character for our first number and run it, we get our error. You can only enter integers for first and second. So this is how we can handle exceptions by using try and except keywords or statements. We mentioned that we can have one or more except statements, and the name part is optional. So if you are not sure the kind of exception, you can simply leave out the name and just say except colon and then your statement. We'll continue our discussion on errors and exceptions handling in the next lecture. Thank you, everyone. Hello, everyone, and welcome to the lecture on errors and exception handling. In this lecture, we'll look at try, except, and else statements. The general format for try, except, and else is as follows. We have our try, and then statements go here. And then we have our except statement. And then if there is any kind of exception, in case of exceptions, this will be executed. And then finally we have our else statement. And then in case there is no exception, this will be executed. So if our try statement doesn't raise any kind of exception, the statement in the else block will be executed. Let's look at an example. Let's prompt a user to enter a number. So we can say try, and then we have our raw input. We'll use the raw input function. For Python 3, you can use the input function. Enter a number, and we'll convert this into an integer. And let's save this in a variable called number, num. And then there is an exception for key value error, except value error. We can say print you can only enter a number or integer or something like that. And if there is no exception, we'll run the else statement. So else colon, and then in the new line we'll say print the number you entered is, let's use some formatting, that format, then we'll pass num. So let's run our statement, enter a number, let's say 8. Since there is no exception, the number you entered 8 is printed, which is in the else block. Let's run it again, enter a number, let's say you can only enter a number. So this is how we can use the else statement. It comes at the end after all the except statements. Next, let's look at another example. What we'll do is we'll try to open a file in the read mode, and we'll try to write some data or some text into our file. Let me show you what I mean. There is a function known as open, which will allow us to open a file. Then we'll pass some file. Let's say file name. So this doesn't exist. File name, and then we can pass a mode. So read mode in this case. So this means open a file, and then the mode is read. There are various kinds of modes. One is a read mode, and let's save this in a variable called, let's say, file x. Now what we'll do is, while the file is open and it's in read mode, next we'll try to write into this file. by using a function known as write. So we have our file x object, and then we'll call the write method on it, and this line will be added to the file name file. Okay, we'll learn more about opening and reading and writing to files in a later section. There will be a file section entirely dedicated to files, but I just wanted to show you a try and accept example with files. So if we run this, what do you think will happen? If we run this, we'll get an error. That's because we are trying to write a file while it's in read mode. So once we open this file, we are opening it in a read mode. So we are only allowed to read that file. And basically this will throw out an error. So if we run this, we get no such file or directory called file name, because this file doesn't exist. Now I'll show you how we can handle this by using try, except, and else. So we can say, I'll copy this, Command C, let's include that in a try block. So we'll paste it. So try to open a file in a read mode and try to write to it, and then we'll include an except statement. Except, you see this kind of error, IO error. Except IO error. This part is optional. I know it's a IO kind of error, so I'll just say IO error, and then we can print file cannot be found. We can say that, and let's include our else statement. Else, that means if the try statement doesn't raise any exception, the else statement will be executed. The else block will be executed. Else, we can say print text is now added to the file. We can say that. So this will throw an error, and in this case, since there will be an exception, this statement will be printed. File cannot be found. Let's run it. So file cannot be found. That's because this file name doesn't exist, and we have a read mode here. Now let me copy this and show you in a write mode. Let's paste this, and then I'll change this to write mode. So one thing about a write mode is that even if this file name doesn't exist, it will create this file name for us. And once it creates this file name, we'll be able to write this statement in our file. So when we run the statement, there won't be any exception, in which case the else block will be executed. And when we run our program, this statement will be printed. Text is now added to the file. Let's run it. See here, text is now added to the file. So this is how we can use the else statement in conjunction with try and except. And the else block of statement is executed only if the try statement doesn't raise any kind of error or exception. And if there is any error, our except statement will be executed. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone and welcome back. In this lecture we'll look at errors and exceptions handling, and we'll look at the finally statement or keyword. So the general format of finally is as follows. We have our try statement, and then statement goes inside here, and then we'll have our finally statement, and then we'll have our finally block here. Execute this either ways. So the finally statement is written at the end, and regardless of whether there is an error or exception, the block of statement in the finally statement will be executed. So whether there is an error or not, the statement will be executed. That's how we can use finally. And we can have exception blocks also. So you can have except, let's say, execute this in case of an error or exception. So this is the general format. Let's see an example. Let's say try. We'll prompt a user to enter a number, and we'll save it in a variable called number, and then we'll have raw input. For Python 3 users, use the function input, raw input, then let's say enter a number please, and we'll convert their input into an integer by casting their response into an integer. And then so we can say try that, and finally let's print all done now. So this finally statement will be printed regardless of an exception. Let's run it. So enter a number please, let's say 3, enter all done now. There was no exception, the finally statement is printed. Now let's enter a number that's not an integer, that's not a number. Let's say you, run it. So we have our error, we have our value error, and our finally statement all done now is also printed. So regardless of whether we raise an exception or not, the finally block of statement will always be executed. Now let's include an except statement. Okay, I'll paste it here. So enter a number, and then let's add an exception. So except value error, and then we can say you can only enter a number. Okay. Now let's run it. Enter a number please, 23. All done now, there was no exception. Now let's enter you, so that both the except and finally statements will be executed. You enter. So we have our value error exception statement here, you can only enter a number, and our finally statement all done now. Let's look at another example and further clarify the use of the finally statement. What we'll do is we'll define a function, and that function will calculate the average of numbers Let's do that. Let's define our function. I'll just name it average AVER, and then it will take one argument. Let's just say list numbers, and then let's have a try statement. Let's say print the average of the numbers in the list is, then we'll calculate the average. So let's import the math module. Import math. So the math module has a function called a sum. So we'll get the sum of the list of numbers, and then we'll divide it by the length. So print the average of the numbers is that, and then we'll use the function called fsum. So this will calculate the sum of our numbers, then the sum of the numbers in our parameter, which is list num, divided by length of our list here, parameter list num. And let's save that in a variable called AV for average, and we'll print out the average. Okay, and then we can have our finally statement and print exiting the function now. Okay, let's run our function and call our function average, and then let's pass a list of numbers. Let's say 2, 3, and 4. Run it. So it says the average of the numbers in the list is 3. Well, that's because 4 plus 3 is 7, plus 2 is 9. 9 divided by length of our list, which is length of our list is 3, right? It has 3 elements. 9 divided by 3 is 3. If you are using Python 2, don't forget to import math from the future module. So from future, import, don't forget to import the division module, the division function from the future module. That way you'll get the true division result. Don't forget that. From future, import division. And finally, exiting the function now statement is printed. Now let's enter some other numbers. Let's say 1, 1, 1, and 2. Let's run it. So the average now is 1.25, and exiting the function now. It looks good. What if I just pass an empty list? So in this case, the denominator will be, the length of the list will be 0 since it doesn't have any elements. And we're trying to divide a certain number by 0, which will yield an error. So when we run the statement, we'll get an error, and the finally statement will also be printed regardless. Let me run it and show you. So if we run this, so the average of the numbers in the list is, then we have a 0 division error, and then the finally statement is printed, right? Exiting the function now. So regardless of an error, our finally statement is printed. Another kind of error that can happen is if we try to pass elements that are not numbers. Let's say 2, 3, and A. So if we also run this, we'll run into a type error. So run it. So here we got a type error, right? And still the finally statement is printed. What we'll do next is we'll take our function and include an except statement to take care of those two exceptions. So try this, and if there is any exception, except, first let's take care of the type error. We can say print one or more elements in your list is not a number. That will take care of the type error. And next, let's take care of the zero division error. Let's say except zero division error. Then print error cannot divide by 0. So this will take care of our errors. Let's run this cell and then call our function now. Average, and first let's pass a list with appropriate elements, which is numbers. So the average of 3, 5, 6, 8, and 8. Let's run it. So the average of the numbers in the list is 6. So 8 plus 8, 16, 22, 27. 27 plus 3 is 30. Divided by 5 is 6. And then our final statement exiting the function now is printed. Next, let's enter some elements which are not numbers. Let's say X and Y, and run it. So the average of the numbers in the list is, there we have we have our first exception, which is one or more elements in your list is not a number, which is a type error. And our final statement is printed, exiting the function now. Finally, let's try our zero division error. So we'll pass an empty list, run it. Now we have our zero division exception or error. Error cannot divide by 0, which is what we have here for our zero division error exception. So we've seen that regardless of whether there is an error or not, the finally block of statement will be executed. So that's the main use of the finally statement. So to recap, we saw how we could handle errors by using try, except, and finally keywords. And we mentioned that the finally statement will be printed regardless of an exception. And in the next lecture, we'll see how we can handle errors and exceptions by using try, except, else, and finally keywords in our code. Thank you, everyone. Hello, everyone, and welcome. In this lecture, we look at errors and exceptions handling using try, except, else, and finally. In the previous lectures, we have seen how to use try and except statements. We have seen how to use try, except, and else statements. And we have also seen how to use the finally statement. In this lecture, we'll see an example on how we can use all of the statements together. So we look at a situation where we will prompt the user to enter a number, and then we'll try to divide that number with the second number that will prompt the user. And if there are any errors, we'll handle them by raising, let's say, value errors or zero division errors. Let's do that. So we'll start with the try statement, and then the first thing we'll do is we'll prompt the user to enter a number. So we'll use the raw input method. For Python 3, use the input method instead of raw input. Raw input, and then you can say enter your first number, and we'll cast this into an integer and save this in a variable called, let's say, first for first number, and then we'll save the second number that they enter in a variable called second. We'll do the same thing. We'll prompt the user to input a number, and then we'll cast it to an integer. Enter your second number, and then we'll handle the exceptions by using the except keyword. So try that, and then except. We know that we'll have two kinds of exceptions, a value error or a zero division error. So let's handle those. Except value error, and that will be print you can only enter numbers. And next, let's handle our zero division error using the except keyword. Except we have zero division error, then print the second number can only be or cannot be zero. Then if there is no exception, the else statement will be executed. So else will display the result, which in this case is else print first number. Let's use some string formatting, divided by second number, and then we'll display the result is equal to that format. We have first, second, and then first divided by second. So if there is no exception, this else statement will be executed, and finally we'll put our finally block of statement. Finally, let's print all done now. Exiting the program or something, you can add that. Okay, so this is the structure. You have your try statement, you have your except statements, and then you have your else block, and our finally statement comes at the end. Let's execute this. Enter your first number, say 4. Enter your second number, let's say 3. So first number 4 divided by second number 3 is equal to 1.33, and then all done now is printed. So your final statement will be printed whether there is an error or not. Okay, and you might need to import the division function from the future module if you are using Python 2 to get the actual division result. Otherwise, you will see 4 divided by 3, you will see the result as 1. Okay, now let's see. This else statement is printed only if and only if there is no exception. However, the finally statement will be printed no matter what. Let's also check those two. Enter your first number. Let's enter that, run it. So in this case, you can only enter numbers is printed, which is the value error. Okay. Let's see if the same is printed if I enter some other character for the second number. Okay. So enter your second number. You can only enter numbers, which is good. And the final statement is still printed. And now let's see our 0 division error. Enter your first number, 9. Enter your second number, 0. Okay, all done now. We have our 0 division error, division by 0. So again here, all done now is printed, right? Regardless of the error or not. Let's run our program one more time. Enter your first number, let's say -7. Enter your second number, 3. Run it. The result is -2.333. So this is how we can use the try, except, else, and finally keywords in handling errors and exceptions. And in the next lecture, we'll look at how we can raise our own exceptions. Thank you, everyone. Hello, everyone, and welcome to the lecture on errors and exceptions handling. In this lecture, I will show you how we can raise our own exception. It's going to be a quick lecture, but I wanted to show you that we can raise our own exceptions. And we do this mainly for type errors and value errors. For type errors and then value errors. We have seen what value errors are. But if you run into type errors also, you can raise your own exceptions. So you might come across this in literature. That's why I wanted to quickly have this lecture and show you how we can do that. And to raise our own exception, we use the raise keyword. Okay, that's how we can raise our own exception, by using our raise keyword. We'll see some examples. So what we'll do is we'll prompt a user to enter a number, and if they don't enter a number, we'll raise an exception. Okay, let's do that. So we'll start with the try keyword, try, and then raw input, since I'm using Python 2. Let's say enter a number, and then we'll convert this into an integer by casting it, and let's save this in a variable called num. So this is a simple statement. And then, so what you have seen so far is we have that, and if there's an exception, we can use the except keyword. So except, then we can say print, you can only enter numbers or a number. We can say that, and then let's include a finally keyword. Finally print all done now. Okay, so we prompt a user to enter a number, and then if they don't enter a number, we'll raise an exception. You can only enter numbers. Let's do that, and finally all done now will be printed. Okay, enter a number 9. So we don't have an else statement. Enter a number 9, all done now. Okay, what if the user doesn't enter a number? Let's say R. You can only enter numbers. The except statement is executed. So we can include, we know this is a value error if they don't enter a number. So we can say except value error, right? And this will give us the same result. You can only enter numbers. Now let's take this to the next level. So instead of this, we can say except, so if there is an exception, except value error as, let's say, error, we can say that, and then print, you can only enter numbers. And let's add some formatting. So I'll add that so that it will show us what the user entered. So that format, and then we can include the error message here. So now if we run this, please enter a number. If we enter a number, that should be fine. All done now. And if there's an exception, let's enter a character S. Run it. It says here you can only enter numbers, which is this. And then we have invalid literal for integer with base 10, and that's the character that we entered. So what we did to get this is that we raised our value error as error, and then we displayed it. We displayed that error by formatting it in our print statement. Okay, and this is just a name. You can use whatever you want. That's the same as in for loop. We can say for I in range, let's say 5, print I. That will give you 0, 1, 2, 3, 4. You could have said for numbers in range 5, print numbers. That will give you the same result. So similarly, we said except value error as error, and then print it by including it in the formatting. So instead of error, you can say anything that you want. Except value error as, let's say, wrong number, print. You can only enter numbers, and then you can format it into wrong number. We can do that also. Run it, let's say W. So you can only enter numbers, invalid literal for integer with base 10. Then the character we enter W. So we can do that. I'll just make this simple and say error. So raise our value error as error. And one thing I mentioned is that we can raise our own exception using this raise keyword. So now let's take this to the next level. So we have that, and we can also include another line of statement saying, let's say, raise, and then space our error. So we'll be raising that value error as error. So we can say raise error. Now let's run it. So if we enter a number, that should be fine. But if you enter something different than a number, different from a number, and run it. So now you can only enter numbers. You can only enter numbers, invalid literal for integer with base 10, and then the character we entered. That's for this print statement. And then we have our we have raised an error, which is this. We have raised our own value error, right? Invalid literal for integer with base 10p. So what's that? This is for our this value error that we have raised using the raise keyword. Raise error. So this is what I wanted to cover for this lecture. I wanted to quickly show you that we can also raise our own error by using the raise keyword, and it works mainly for value errors and type errors. And you might come across this raise statement in literature. That's why I wanted to quickly show you. Let's run our program one more time. Enter a number, say 4. All done now. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the errors and exceptions handling exercise. We look at the following question. Let's see the instruction. So we have a list containing a list of numbers. So it says prompt a user to enter an index, and if the index is in the range of our list, display the number in list 1 at the specified index. We have a list here, and then we'll ask a user to enter any index in this range. So if the user enters 0, we'll display this number 23. If the user enters index 7, we'll display the appropriate number in the list. So here it says use a combination of while and if statements to make it challenging. Okay, and in the prompt message, display the option to enter quit if they want to quit and break out of the while loop. So when we prompt the message, we'll also ask the users to enter quit if they want to exit out of the program. And then use try and except statements to handle errors or exceptions. For instance, if the user enters an out of range index, which is also known as index error, or if they enter characters different from numbers. So here we have, I think, 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have index 0 to 9. And if the user enters, let's say, index 10 or 11, that's out of range. So we'll handle that index error using an except statement. And if they enter some other characters different from numbers, for instance, if they type the character X or U, we'll handle that by using an except statement. Okay, take a moment and try this exercise. Great. Now that you have tried the exercise, let's see my solution together. I'll copy the list. Command C. Let me copy it here and paste it. Okay, we have our list. Let's start with our while statement. So we can say while true. Then let's prompt the user to enter an index. I'm using Python 2, so I'm using the function raw input. If you are using Python 3, use the function input. So raw input, and then we can say choose your index now. Then we also need to display that they can type quit to quit the program. So we can add type quit to quit or some message. choose your index now, raw input, and let's save this input in a variable called choice. And what we'll do next is we'll check to see if they type quit, so that we can exit out of the program. So we can say if choice double equal to quit. We are using double equal because we are comparing to see if choice is quit. So in this case, we'll break out of the while loop. Okay, the next thing we will do is they will enter a choice here. Right now, the choice is in string format, right? It's a string. And what we'll do next is convert that string into an integer. So we'll convert their choice into an integer. And then we'll find out the element at the chosen index. Then we'll print that element. If they give us some other index outside of our range, we'll handle those using exceptions. Let's do that. So once we have that, we can say, so let's include all of what I said in our try statement. We can say try, and then we'll cast our choice into an integer, and I'll save this in a variable called index. I'm just converting their choice into an integer. And now that we have that, we can simply print the element. So list 1, which is my list, at the index chosen. List 1 at their choice of index. Okay. Now let's handle some exceptions. So if you don't know any exception name, you can simply say exception and then put your exceptions. I know one kind of exception, which is index error. So I'll include that name, and then in case of an index error, we can print, let's say, wrong index. We can also display the index the user chooses, and then for any other exceptions, we can simply print, let's say, something else is wrong with your choice or something, and then display their choice. We can display that. So if they choose something else, let's say some other characters like U or X or V, we'll display this print statement, something else is wrong, and then their choice. In case of out of range index, we'll display the wrong index message. Okay, looks good. Let's run our program now. It says choose U index. Okay, choose your index now. Type quit to quit. Let's choose an index. Let's choose, let's say, 2. Enter. So 56 is displayed, which is correct. Index 0, 1, and 2. Let's choose another index. Let's say 7. 99 is displayed. Yep. Now let's choose an index out of range index. Let's choose 11, for instance. So wrong index, which is good. It's out of range index. And let's choose something else. Let's say U. Something else is wrong, which is the correct exception. And the last thing we haven't tried is quit. So let's try to quit. Great. Now we are out of our program. Okay. To make this look nicer, what we can do is we can introduce some line breaks between each of our response. So what we can do is, so if their choice is quit, I can print out some blank line like that. Let's say times 15, and I can do the same thing here. After the element is printed, we can print out some blank lines, some lines, so we see that a line, so that there will be some line breaks in between. Okay, we have our index error here. Let's add a line times 15 and one more line here. Print times 15. Okay, let's see how it looks now. Okay. Run it again. It says choose your index 3. Okay, a nice line break. Choose your index now. Let's choose 8. Okay, 222. 222, great. We can also do negative indexing. So if we do -1, the last element will be printed. So the last element is 123. Let's choose another index. Let's say -5, 89. Choose your index. If we choose an out of range index, let's say -11, we get a wrong index exception, index error exception, which is good. Similarly, if we choose some other characters, we'll get an exception message, something else is wrong, which is this. So for any other exception, we get that message, something else is wrong, and the character we entered. Now we can quit by typing quit, and we are out of our while loop. So the line break is just to make it look nicer and neater. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to this exercise. We look at errors and exception handling using the try, except, and finally keyword. We have two questions. Let's start with the first question. It says prompt a user to enter a number, and prompt a user to enter a second number to divide the first number by, and then check to see if the first number divides by the second number evenly without any remainder. That means check to see if the first number modulus second number is equal to 0, and use the try, except, and finally statements to handle any kind of exception like value error or zero division error. Take a moment and try this question. Great. Let's look at the solution together. So we'll prompt the user to enter the first number by using the raw input function. Raw input to enter your first number, and we'll cast this to an integer and then save it in a variable called first for first number. Let's convert it into an integer by casting it. That will be the first number, and let's prompt the user to enter the second number. We'll do the same thing. We'll use the raw input function. Since we are using Python 2, enter your second number. Now that we have those, we can use if statements to see if the first number modulus second number is equal to 0. So we can say try if first modulus second double equal to 0, since we are comparing that to 0. So if first modulus second, if that's equal to 0, we can print out your first number first. It's your first number first let's say divides evenly by your second number, then our second number, else we can say print your first number let me copy this print statement, then paste it here. Your first number doesn't divide evenly by your second number. So this will take care of the try statement. Next, let's handle some exceptions by using the except keyword. Except, let's handle 0 division error first, and in case of 0 division error we can say print your second number cannot be 0. Then for value error we can say except value error. We can say print enter numbers only. So if they enter any other character, we'll handle that by this value error statement, enter numbers only. And let's add a finally statement. Finally, you can say print all done now. So this finally statement will be executed regardless of any error. Okay, let's run it now. Enter your first number, let's say 7. Enter your second number, 3. It says your first number 7 doesn't divide evenly by your second number 3. And then we have our finally statement all done now. Good. And next we can say enter your first number, let's say 18, enter your second number, let's try 6. Your first number 18 divides evenly by your second number 6. Okay, so we have tried out these two statements. Now let's try our zero division error exception. Let's run it. Enter your first number 2, enter your second number 0. Your second number cannot be 0. Great. Our final statement is still printed, which is good. And finally, let's try our value error. Run it. Enter your first number, let's say 5. Enter your second number, let's say x. We have our value error, invalid literal for integer with base 10. In this case, our value error statement is not printed. I know why. Let me go. It's because we have the first and second prompt message outside of the try and except statements. So we'll include it inside our try block. Now let's run it. Enter your first number 3, enter your second number, let's say v, enter numbers only, which is good, and our final statement is still printed. Okay, now let's try. Enter your first number, let's say s, enter numbers only, great, and we still have our final statement printed. Run it, let's say 9, second number 0, so this will give us our zero division error message. Your second number cannot be 0, and our final statement. Let's try some valid numbers. Say 3, enter your second number 7. Your first number 3 doesn't divide evenly by our second number 7, and we have our finally keyword, final statement. Okay, and if I say 60, enter your second number 5. Your first number 60 divides evenly by 5. Great. Now let's look at our second question. So here is the question. Prompt a user to enter a number and check if the number is divisible by 5. And use try, except, and finally to handle any exception. So we can use the modulus function to find out if a number is divisible by 5. So if the number modulus 5 is 0, that means that number is divisible by 5. So let's try that out. We have our try statement. Then we'll prompt the user to enter a number. Raw input, enter your number. Okay, and then we'll cast that number to an integer, and we can save that in a variable called, let's say, choice. And we can use an if statement to check if it's divisible by 5. So we can say if our choice of number modulus 5 that will equal to 0. You can say print the number you chose. The number you chose is divisible by 5. We can say that, or we can display the number also. So the number you chose, and then our choice, and we can add space there, a colon there, a quotation there is divisible by 5. That should work. Now let's take care of the else statement. Else print your number is not divisible by 5. So that takes care of the try statements. And then for our exception, the only exception we can have is a value error, right? We cannot have a zero division error because we are dividing our number by 5. So except value error, you can say print please choose a number only. Then we have our final statement, print all done now. Okay, let's run our program. Enter your number, let's say 9. Your number is not divisible by 5, which is the else part. And we still got our final statement printed, all done now. Now let's take care of the if statement to see if it works. Enter your number, let's say 555. The number you chose, 555, is divisible by 5, which is great. Okay, let's run it again. Enter your number, let's say 25. The number you chose, 25, is divisible by 5, and all done now is printed. Now let's see if the value error is working. Enter your number, let's say I. Please choose a number only. Great. Then we have our final statement, all done now, printed. So you can also include an else statement for your exception handling, and this else statement will only be executed if we don't raise any kind of exception. So here we could have said else print, let's say good choice Okay, now if we run this, enter a number, let's say 10. So in this case, first this statement will be printed, and then our else statement will be printed, and our final statement will be printed. To the number we chose, 10, good choice, and all done now. If we enter something else, let's say 12, the else statement will be printed, and then the good choice will also be printed, and all done now. So your number is not divisible by 5, good choice, all done now. And finally, if we enter something else that's not a number, in this case, the else statement will not be printed, as we will run into an exception, which is a value error exception. So please choose a number only, and our final statement will be printed. So please choose a number only, and then all done now. Great. So these are some exercises on error and exception handling. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the Project 2 section of this course. Here we'll create a game. I have given it the title, Which Road Will You Choose? And these are the these are some of the characteristics of the game. So we'll create a game where a player has to choose between two roads. One road leads to a treasure, whereas if the player chooses another road, that road leads to a scary place. So which road to choose? So these are some of the methods that will help us build this game. So first we'll have a method or function that will display some introduction about the game, and then we'll have another function that will ask the player to choose a road. Then we'll have another method or function to display result of the chosen road and whether the player has chosen the path to treasure or misery. And finally, we'll have a function that will ask if the player wants to play again. So take a moment, pause this video and try to derive a game that will do following this. Okay, let's start the game. Okay, first I'll have a function that will display introduction to the player. So I'll call that function display game intro. Okay. So I will print some info about the game. I will print out something like this. You are in a faraway land full of monsters. Ahead of you you see, then let's print another line, print ahead of you, you see two roads. If you take the first road, the monster guarding the path is Skull. Let me print another line, print. So if you take the first road, the monster guarding the path is calm and friendly. Okay, and will share his treasures with you. The other monster, however, so you can type anything that you want. This is just an intro for the player. Let's say the other monster, however, is always hungry and will not hesitate to eat you on sight. Okay. Great. I'll pass an empty parenthesis here. So this is my display game intro function. Good. Now let me define another function, and I'm gonna call it choose road. Okay, and then let me create a variable and it holds an empty string. So this choose_road method, it will let the player choose road 1 or road 2. Okay, I can use while statement for that, while loop. I can say while road is not equal to, I'll explain later on, while road is not equal to 1 and road not equal to 2, I can say print which road will you go into, and then I can display choices for the user or player, 1 or 2. Okay, then I can have road is equal to row input. So this will let the player input his options. Okay, let me go in detail and explain the choose_road function. So the reason why I have a while loop in the choose_road function is because the player may type 3 or 4 or even anything like hello, hi, whatever, right? So in that situation, our program will not make sense of that. So if the player did not enter 1 or 2, the program will loop back, right, and ask the player for the road number. So if the player keeps entering the wrong numbers, our program will patiently ask the person to enter 1 or 2, right? So it will loop back and ask the player for the road number over and over again until the player finally enters 1 or 2. And when the player does that, the while loops block will be false, right? So in that condition, it will jump out of the while loop and will continue with the rest of the program. So this is what it will do. Okay, in the last video we saw the choose_road method or function. So we started with an empty string for road, and then this will prompt the user to enter a valid road number, either 1 or 2. And once the user enters a valid road number, this function will return the road. Great. Now let's define another function, and then let me call it check road, and then I'll pass in an attribute. Let's call it chosen road. We'll come to that later on. Okay, so now we're going to have the program randomly choose road for us, whether 1 or 2. Great. All right, let's say print you approach the road and then let's pause for a few seconds, so I can use time.sleep, and then let's pause for 2 seconds, and then let me print another statement. Let's say it's dark and spooky. let's pause for another 2 seconds, and then let's print another statement. A scary monster jumps out in front of you. He opens his jaws. And okay, let me print an empty string here, and then let's pause for another 2 seconds. Great. So far here we have used the time.sleep method. So there is a time module. So when I use time.sleep method, I have to import the time module. So import time. So time.sleep means from the time module, import the sleep function. So basically, this will pause the program for 2 seconds. Great. Let's continue. Okay. Let's have a friendly road. Friendly road is equal to random integer. So we'll have the system choose 1 or 2 as the friendly road, and it does that randomly. So random is another module, so we'll have to import it. Import random. So this basically means from random module, use the random integer function to randomly choose a number, in this case between 1 and 2. Okay, and then let's have an if statement here. So here we have passed a parameter or attribute called chosen road. So now I'm going to use that in my if statement. If chosen road is equal to friendly road, right? So whatever we choose, if that's equal to the road randomly chosen by the system, I'll say print gives you his treasure, or else we can print something like Google's and it's you in 1 byte, or something like that. Okay, here friendly road is an integer, so I have to convert that to string using the string method. So this will convert the result to string. Okay, great. Let me explain what I did in the check road function. So here we're going to have the program randomly choose which one has the friendly dragon or monster, and then which one has the scary monster, right? And we did that by calling the random integer function, and that will return either 1 or 2. and store that value in a variable called friendly road. So we're going to use this variable friendly road to store the number randomly generated by our program. Great. And then here we have, here we're going to check if the integer we chose is 1 or 2. And if the number we chose match the randomly chosen number by the program for the friendly road, we will display the monster will give you his treasure. Or if the number randomly chosen by the program is not equal to what you chose here, the monster will eat you in one bite. Great. Okay. Now let me define a variable called play again, and let me give it a value of yes. So this will check if the player wants to play again or not. So I can use the while statement, while play again is equal to yes, or play again is equal to yes, or even play again is equal to, let's say, upper yes, or even play again is equal to yay. So if the player enters any of these responses, we'll be able to play again. Okay. So in those conditions, I'll call my functions here, starting from the beginning. So the first one will be display game intro. That's my first function. So I'm calling my function. And then I'll have my second function is choose road. So let me call that function choose road. And then lastly, I have the check road method function, right? So here I have choose road. And then, so the player will choose a road, right? 1 or 2. And then I'm gonna store the result in a variable, let's say, called road number. So that variable will store the result for choose road. And then I have the check road. So I'll use the check road method, function check road, and then I'll pass the road chosen by the player, which is stored in road number, right? So I'll pass road number, and then finally I'll have print do you want to play again. I can have options yes or no, right? And then I can have play again is equal to raw input. Great. So let me explain what I did after this. So I've started calling my function. The first one I'm calling is display game intro. Here we call the display game intro function. We defined that earlier in our program. So when display game intro is called, the program execution goes to the first line here, right? So it will start printing these statements since we called that function. Great. Then now we call the choose road function, right? Right here. So this line, we let the player to choose between road 1 and road 2, right? And then it will return a value and store it in this variable road. Then we have check road number, which is this method, this function. So in this function, the program will randomly choose 1 or 2 as the friendly road. Let's say if the program chooses 1 to be friendly, and then if the player's choice is 1, so 1 is the friendly road, and then he will get a treasure. But if it's the other way around, the monster will eat the player. Great. So once we have that, once the result is displayed, this line of statement will be printed. Would you want to play again? And then row input, yes or no. And depending on that, the player can play or not. Okay, let's play our game. Good. So if I run it, so here I get, you are in a faraway land full of monsters. Ahead of you, you see 2 roads. If you take the first road, the monster guarding the path is calm and friendly and will share all his treasures with you. The other monster, however, is always hungry and will not hesitate to eat you on sight. Which road will you go into? 1 or 2? So if I enter something else, 3, enter, so it will prompt the user to enter a valid choice, either 1 or 2. If I say, let's say, hello, enter, so this will keep displaying. That's the while loop here. So it will prompt the user until the user enters a valid input. Let's say I choose road 1. You approach the road. It's dark and spooky. A scary monster jumps in front of you. He opens his jaws and gives you his treasure. So this time, I am a winner. Do you want to play again? Let's say yes. You are in a faraway land, so the display game intro function is displayed here, and then which one would you choose? Let's say I choose 2. Enter, you approach the road. You see the time that sleep function? That's the gap in between, 2 seconds. Okay, here you see I chose 2. It's dark and spooky. A scary monster jumps in front of you and eats you in 1 bite. So the program is working. Do you want to play again? Yes. Okay, let me choose 2 again. Enter, you approach the road. Dark and spooky. He opens his jaws and gives you his treasure. Great. You see it's randomly choosing 1 or 2. Earlier I chose 2 and the monster ate me. And here again I chose 2 and I got a treasure. So it's randomly picking numbers. So I know the program is working. Great. So as a summary, we created a game using few functions. So we have a function here that will display introduction about the game, and then we have another function that will prompt the user to enter choice A or B, which is 1 or 2, and then the system will randomly generate a number, will randomly choose between 1 or 2 to be the friendly road, and then whatever the program decides to be the friendly road, it will compare that to the road the user chose. And then if it matches, the statement is printed. If not, the statement is printed. And finally, we are asking if the player wants to play again, yes or no. And here we are calling our different functions. Great. And one thing I want to show you is here, do you want to play again, yes or no? If I say yeah, it plays again. So let's say I choose 1, you approach the road, it's dark and spooky, scary monster jumps in front of you and then eats you with 1 bite. So I have one assignment for you. Here we are only checking if the player enters yes or Y or upper yes or yeah. What if the player enters some other input? What do you think will happen? Let's say I say no. What do I get? Nothing, right? Great. Let me play. Let me run it again. Choose 2. You approach the road. It's dark and spooky, and it's you in 1 bite. So here I have responses yes or no. What if I enter something else besides yes or no? Let's say I don't know. So nothing happens. So same as in here, right? If the player does not choose yes or no, you can always prompt the user to enter either yes or no. So that's my assignment for you. Okay, I hope you have a good understanding of how we can use functions, how we can use while loops, if loops to build our functions. Great. Thank you, everyone, and I'll see you at the next lecture. Hello, everyone, and welcome to the lecture on files in Python. Let's start by looking at some general properties of files. As you all know, files have file names and file paths. So for instance, I have these files saved on my desktop. If I want to find the file path, since I'm using Mac, this will be my file path. Let me copy it and paste it here. So this is the file path for my Excel file that I showed you. So, workbook1.xlsx. So this is the path. If I follow this path, I will find workbook1.xlsx. And this is the file name. And the last part, the .xlsx, is the file extension. It just tells my computer what kind of program to use in order to open this file. It could be PNG and so on. So those are different file extensions. For Linux and Mac users, the forward slash separates one folder from another. So the equivalent of this is a backward slash if you are using Windows. So in Windows, it would look like this, something like this. You have the C root folder, colon, backward slash, and then something. I'm just making this up. Let's say workbook 1.xlsx. So it will look something like this in Windows. So the C colon slash, this is the root directory, the root folder. Folder means directory. It used to be called directory. Now we refer to it mainly as folder. So the root folder or directory in Windows is C colon slash. Whereas in Mac, the root directory is just a forward slash. Okay. And one more thing I want to show you is files are represented by strings. And if you are using Windows, make sure to include double slashes. Since one backslash is the escape character, it will ignore it. So make sure to use double slashes. Let me give you an example. So if I were to print, let's say this part here, this is for Windows users. So if I were to print the paths, I have to put double slash. That's because one slash is an escape character. So if I print this, you see what I get? Single slash. So make sure to use double slash if you are using Windows. Or the alternative way is to use a row string. So I can also say print R, that's row string, and then your file path. So let me copy this whole thing. So if I print this, I get the same result. So you can use, again, double slash or row string. Good. Now let's look at some more characteristics. So if I want to join different folders, how can I do it? Let's say I have folder 1, folder 2, and folder 3. These are different folders or paths. And then let's say I have a file called file.png. Okay. If you are using Windows, you can use the simple join method that we learned in strings. So I can say that's join, and then this whole folder. Command C, Command V. So I can use // that join to join this folder saying file name. So it will create a directory like this. If you are using Windows, this will work. Okay. However, Python has a module called OS, and this module has a lot of functions that will let us work with files. So in order to join different folders and files in any operating system, we'll have to use the OS module. So let's see that. So I have to import the module, import OS, and inside OS there is a function called join, so I can use that. So os.path.join. So join is a function inside the path module, which is inside the operating system, the OS module. And then I can provide this part, folder 1, let me type it in, that's join, folder 1, folder 2, folder 3, and finally I have my file.png. Okay, so if I run this, I get a path, folder 1, folder 2, / folder 3, and then finally file.png. That's because I'm using Mac. If you are using Windows, you'll get something like this, folder 1, folder 1, you have the / folder 2, / folder 3, / file.png. This is what you'd get in Windows. Okay, and let me show you another function, os.get current working directory. This will give you the current working directory. So if I run it, this is my current working directory. So I'm in users folder and the users, and then a folder named Sami Shumiye. So inside this, I have this Jupyter notebook. So it's saved in here. So your current working directory will look different than mine. For Windows, your current working directory will look something like this, under C drive, right? And then it goes on like that. So that will be your current working directory in Windows. Good. Hello and welcome back. So in the last lecture, we saw how we can get our current working directory by using the function in our OS module called get current working directory. Okay, and there's another function that we can use to change our current working directory. It's called change directory function, os.change directory, chdir, and then we pass the directory that we want to be in. So for instance, let me pass a new directory, users, Sami Shumiye, and then let's say desktop. Okay, now if I call my current working directory function, you see it's users, Sami Shumiye, and then desktop. Earlier it was just users and Sami Shumiye, right? Okay, let me change it back to my earlier current working directory. So chdir, and then users, Sami Shumiye. Good. Let's talk about file paths. We have two kinds of file paths. One is absolute file path and the other one is relative file paths. Absolute file paths start with the root folder. So for me here, this is an absolute file path because it starts with my root folder, right? Whereas a relative file path don't start with the root folder. Okay. For Windows, again, this is your root folder, C:/. So anything that starts with that is an absolute file path. And we have two extensions. One is called the .dat folder, and we have another one, .dat folder. So if you see one .dat, it just means it refers to that specific folder, this folder. Whereas .dat folder refers to the root folder. Okay, let me show you an example here. So I have a picture here. This is in Windows. Let's say my current working directory is the bacon folder. So this bacon folder is inside the C folder. So C folder is the root folder. Inside that, I have the bacon folder. So let's assume the bacon folder is my current working directory. So the relative path will be .dat/. This means I'm referring to this folder, which is, since I am in the bacon folder, ./ means this bacon folder. And the absolute path for it will be C:/bacon. Since absolute folders start with our root folder, right? Good. If I am referring to this fizz folder, which is inside the bacon folder, I can say .dat. That means this folder, the folder that I am in right now, this folder. So since I am in bacon folder, so that means bacon folder, and then /fizz. So inside bacon folder, I'm referring to this fizz folder. The absolute path will be C, my root directory. Under C, I have bacon folder, and then fizz. Good. What if I'm referring to this spam.txt file? How can I refer to it? Since I'm in bacon folder, that means this folder, which is bacon folder. And then inside bacon folder, go to fizz folder, right? And then finally in fizz folder, I have my file spam.txt. For absolute path, starts from here, my root directory, and then go to the bacon folder. Inside the bacon folder, there is another folder called fizz folder, and inside that fizz folder, I have my spam.txt file. Okay? Now let's see this eggs folder. You see this eggs folder? It's no longer in bacon folder. It's in the root directory folder. So I used, for the relative path, I used .dat, right? .dat means root folder, right? .dat means root folder. So inside the root folder, which is the C folder, go to eggs folder, eggs. You see the difference between here? In the previous examples, I was using just that one .dat. That's because I am currently in the bacon folder, in the bacon directory. But now, since X is in a different directory, I have to refer to that different directory, which is the root folder. So under the root folder, you'll find X folder. This is the relative path again, because we're using, we are referring to it by that. Whereas the absolute paths always start with the root directory, C:// This in Windows, or I mean in Mac or Linux, it will be a / and then whatever the path is. So if I am referring to the spam text here, which is inside the X folder, so that root directory and then X folder and then my spam text file. So that's the difference between absolute file paths, relative file paths, and 1. And then 2. folder. Okay. Now let's look at some more examples. Okay. I have different functions inside the operating system OS module. Inside the path module, one is ABS path. This is one function. And this function returns an absolute path form of the path passed to it. So if I pass, let's say, picture.png and then run it, this will return the absolute path for this file that I passed to. Since the machine assumes I'm in users, then Sami Shumiye folder, so it's giving me the path there. That's why I see users Sami Shumiye. If I change the path to a different folder, for instance, let's say os.path.change directory, chdir, and then if I change this to a different directory, let's say users Sami Shumiye desktop, right? Desktop. What did I miss here? Module has no attribute. Change directory. Oh, this is just os.change directory. I don't need path for that. Okay. Now if I say get current working directory, I get users Sami Shumiye and then desktop, right? So if I get the absolute path of the same file that I passed earlier here, pic.png, since it assumes that I am in the desktop folder, it will give me this absolute path. You see how different it is from what we got earlier? So it assumes our current working directory. Good. And there's another function called isAbsolutePath, and this will return true if the path passed to it is an absolute path. Let me show you an example. So os.path.isAbsolutePath, and then let me pass in this string here, Command C, Command V, run it, I get true. Similarly, if I pass Command C, Command V, and if I remove this desktop part and run it, I get true. That's because this is an absolute path, right? Starts with the root directory. What if I pass, let's say, os.path.isAbs, just picture.png? What do you think I will get in this case? So I got false. That's because this is not an absolute path. It's just a relative path. Okay? Hello and welcome back. In our last lecture, we saw how we can know if a path is absolute or not. And we saw how we can get the absolute path of a file name. Okay, let's look at some more functions in the OS module. Okay, let me change my working directory to users slash Sami Shumiye. Okay, now let's look at another function called relative paths. So os.paths relative paths, rel path. So this function is found in the paths module in the OS module. Okay, so this takes in two strings and gives you the relative paths. Let me show you an example. So if I pass users slash Sami Shumiye desktop, let's say picture2.png, and I have another string users Sami Shumiye. So this is my current working directory, right? Users Sami Shumiye, and I have this file in this directory. So using this function, it will tell me the relative path of this file relative to my current working directory, which is this. So I get desktop picture2.png. You see the relative path? Since I'm in this my current working directory is this, relative to where my picture is saved, right? This is where it's saved. So relative to my current working directory, this file is found in desktop/pic2. Okay, let's move on. There's another method called directory name, dir name, and this is used to get the directory part of my file path. So if I pass, let's say, let me pass this whole thing. Copy and paste it. So this function will give me just the directory part. So if I run it, I get users, Sami Shumiye, and then desktop. Only the folders, right? That's what this will give me. dir name. Okay, and there's, in order to get the file part name, right, I use a function known as base name. This will pull off the part after the final slash. So let me show you an example. os.paths.base name, and then I pass the whole thing. So this will give me the part only after the last backward or forward slash, depending on whether you are using Mac or Linux or Windows. So I get only pic2.png. So that's the difference between base name and dir name. dir name gives you the folders or directories, whereas the base name gives you the file name or the part after the last slash. Remember, this base name does not always give you the file name part. It gives you the part after the last slash. So if I were to change this to, let's say that, it will give me the desktop folder. I will just get desktop. Good. Okay, let's look at some more functions. There's a function called os.paths.exists. This will return true if the file exists. Otherwise, it will give me false. Okay, for instance, if I copy paste that and then run it, I get false. That's because I made up this .png file. It doesn't exist. If I go to users, Sami Shumie desktop folder, this doesn't exist. I just made it up. So it only returns true if this exists. Let's look at another example. That pass that exists. I think I have a file called workbook1.xlsx file. Let's see if that's true. So I get true. Since this exists, I get true. Okay. There's another method called isDirectory, and this returns true only if we pass a file path instead of a file name. Okay. So instead of is file, that it accepts is dir and pass it the same string. So this is a directory. This returns false. Whereas if I just pass this desktop part, I get true. That's because this is a directory, right? This is a directory. Good. There's another function called getSize, and this returns the file size in bytes. So getSize, that's the function name. getSize, and run it. I get an error. That's because this file doesn't exist in this directory. Let me show you an example with a valid file. Okay, os.parse.getSize, and then passing our workbook1.xlsx. So the size of this file is about 27,500 bytes. Good. And another function I want to show you is the list directory, os.list directory. This returns a list of strings of file names. So if I pass Command V and just desktop, run it. So I got the following. The list directory function returns a list of strings of file names. So if I go to users, then Sami Shumie, then desktop, I have the following files and folders, right? So I have note, localized, example1.png, example2.png, the recordings folder, summary.png file, and so on. So this lists all the file names as strings. Okay? Good. So in summary, we saw what file names and file paths are. In Windows, the root folder is C:, whereas in Mac, the root folder is just a /, right? Just a / versus C:/. And then we have file extensions. We saw that we can use the join method to join different folders and file paths, and we use that by importing the OS module, which contains a lot of functions related to files. We saw how we could get our current working directory using the get cwd function found inside the OS module, and we also saw how we could change our current working directory to a different directory. Then we saw absolute paths and relative paths. We also saw different methods, different functions to see if a path is absolute or relative, if it exists or not, if it's a file or directory name, and so on. So this is a general introduction about files and file paths. I hope you have a good understanding of files in general. Thank you everyone, and I'll see you at the next lecture. And there's another function called isFile, and this returns true if we pass into it file names. So os.path that is file, that's the name of the function found inside the path module, inside the OS module. isFile, and then we pass to it users slash Sami Shumiye slash desktop slash, let's pass to it some file name that doesn't exist, .png. Run it. So this returns false. We pass to it a file name, right? But since this doesn't exist, it returns false. However, if I pass to it a valid file path, so users slash Sami Shumiye slash desktop slash summary.png, it returns true. That's because I passed to it a file name that's valid. Hello everyone, and welcome to the lecture on copying and moving files and folders. In this lecture, we'll see how we can copy files and folders and also how we can move them. So for this, we need to import a module called shutil. This module has functions that allow us to move files and folders and also to copy files and folders. Okay, so we have to use the import statement, import shutil module, and to copy files, let's start with copying files. shutil has a function called copy, shutil.copy, and we specify the file path and the destination path. Okay, before that, let me show you an example. Import OS. I want to get my current working directory, os.get current working directory. We saw that last time. So this tells me my current working directory. And if I want to change my working directory to some other directory, I use the change directory method. So users slash Sami Shumiye slash desktop. Okay, so run it, and to find out the list of files and folders in this directory, I can use the list directory method function that we saw last time, os.list directory, and then you provide the directory name, which is this. Let me copy this part, Command C, Command V. Okay, so these are the different files and folders that I have in this directory. So what I'm going to do now is move this summary file, summary.png file. I'm going to move it from my current directory, which is this, to this directory. Okay, let's do that. So shutil that copy, I'm going to copy it. So the file path, users, Sami Shumiye desktop, and then I have summary.png, that's the path, and then the destination path. So my destination path is, I want to move it to users, Sami Shumiye. So this is the destination path. So I'm going to copy this file, sorry. So I'm going to copy the summary.png file to this location. So once I copy it, it will exist in both locations. Okay, let me run it. Okay. Now if I change my working directory to this, the summary.png file should be in there. Okay, let me show you that. os.change directory to users / Sami Shumiye / okay, I want to change it to that, and then I can use the list directory function to find out files and folders, users / Sami Shumiye. So in here, this summary.png should be there. Let's see. Summary.png, there it is. So my summary.png file is copied into this location. Good. So that's about copying a file. Next question is, how can we copy a file and rename it? We can also do that. In order to do that, we use the same copy function, but also add the new file name that we want to rename it to. So in this case, shutil.copy. So I'm copying this file from this location, and I'm copying it to users / Sami Shumiye. And if I want to rename it, I add the file name that I want to rename it to. Let's say new name, let's say new name.png. So if I run that, new name.png, okay, run this again, and run the last one too. So new name.png should also be in here. New name.png, you see? That's the new name that I renamed it to. And the summary.png was there initially. So that's how I can copy a file and rename it too. Now let's see how we can copy a folder. To copy a folder, we use a function called copy3. C-O-P-Y, copy3. That's the function that we use to copy folders. Okay, let's show an example. os.get current working directory. So I am in users Sami Shumiye. So let me change that to desktop. os.change directory to users / Sami Shumiye / desktop. Okay, and then to list out the file names that I have in this directory, I can use the list dir function. So I have this files and folders. So this is a folder. What I'm going to do is move it. I'm going to copy this folder and move it to another location. So let's see how we can do that. Okay, so let's move this note folder from users Sami Shumiye desktop to users Sami Shumiye. Okay. Executil that copy tree to copy folders, then the file path slash our folder and the destination path users slash Sami Shumiye and the destination folder users Sami Shumiye. Okay, let's run it. Okay, so here it says file already exists. Since I ran it twice, first time it made a copy, and then when I ran it again, it says file already exists in this location. So at this time we can move the folder. Same way that we move the file, we can move a folder. So by copying it, we can also add a name for our folder. Let's say note, new note folder. So it will be copied and renamed. New note, run it, and then if I rerun it again, it will give me an error because this has already been created. Same thing. Good. So in this instance, I have to make new note 2. So this will make another copy by renaming it. Now if I go back to my users Sami Shumiye directory, I should get a copy of this note folder. Okay. os.change directory to users Sami Shumiye, and then to list files and folders in that directory, I use the list directory function, and then pass in the path users Sami Shumiye. Scroll down here. So that's a list of files and directories in files and folders in this directory. Okay, now let's look at deleting files. We can delete files by using 3 different methods. Let's start with the first one. The first one is by using the unlink function, which is found in the OS module. So let's import the OS module. And in the OS module, there's a function called unlink, which is used to delete files. And then we pass in file name, let's say picture.png. This doesn't exist, but I'm just passing it. It says no such file or directory picture.png, but this is one method. And then we pass in the file name. Okay, the other one is the remove directory. So os.rmdir, and then this is used to delete folders. And if we are using this method, the folder has to be empty. It has to be an empty folder. Otherwise, you won't be able to delete that folder using the rmdir function. Okay, os dot get current working directory. I'm in users Simon Shumige. So basically I'm in here. Let's try to delete this folder, this test folder. This folder is empty, so if I open it, it's empty. So I can delete it by using the rmdir function. Okay, remove directory, and then name of my folder, test, run it. Now it's gone. If I run it again, I get no such file or directory, test. That's because it's already deleted. So if I go back, there is no test. If I want to delete test2, this test2 folder has the following files and folders, right? So if I try to delete that, it won't delete it because that folder is not empty. So if I try to, I get an error and it says directory not empty. Good. Another way to delete files and folders is by using the remove tree function. And then for that we have to import the sh util module. It's inside that module. Then sh util dot remove tree, and then we pass in the folder name. Unlike the rmdir, the remove tree function removes all folder and its content. So make sure, you know, while you are using this function, to see that, to check if you want the contents of that folder or not. It won't ask you, it won't display a message like this, directory or folder not empty. It will delete it. Okay. And then another alternative way for deleting is by sending it to your recycle bin. So these two methods delete folders or files permanently. There's another method. This method will send your files or folders to the recycle bin. But before we use that, we have to install it on our command prompt or terminal by using the pip install command. So pip install send to trash. So if you go to your, I already installed this. If you go to your terminal or command prompt, if you are using Windows, just type in pip install send to trash, and this will install, and this will install the send to trash module. Once you install it, you can use it by first importing it. Import send to trash module, and then send to trash module. Inside it there is a function called send to trash, and then you specify the file path. So this will send it to your recycle bin. For instance, if I send, let's say, test2, right? We saw there is a folder named test2. So if I send that to, by using the send to trash method, I can send it to the recycle bin. So run it. Now if I go to my recycle bin, let's say, you see the test2 folder is in here. I can empty it or I can put it back. Okay, so that's the difference. To recap, we saw how we can copy and move files by using the shutil.copy function. We can also rename it by specifying the new file name in our destination path. We also saw how we can copy a folder by using the copy tree function in the shutil module. And then we saw how we could delete files and folders by using the unlink function. By using the unlink function, remove directory function, which are permanent, and by importing the send to trash function, we can delete our files or folders to our recycle bin. Okay. And one important thing to note is to be careful while you are deleting files or folders by using the unlink and remove tree method. Be careful with those two since the changes are permanent. Okay, thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on reading and writing files. In this lecture, we'll see how we can read a given file, and we'll also see how to write in a file. For this lecture, I have created two files, file 1 and file 2, and I have saved them where my Jupyter homepage is located. So file 1, I have added 5 lines, and then file 2 has a single line, and I have saved them both where my home book is located in the same directory. Let's start by looking at reading files. In order to read a file, we need to open it first. And for that, we'll be using Python's built-in function known as open. This function allows us to open a given file. So let's do that. Open, and let's open our first file, which is open, and then pass your file name, which is file1.txt. So this will open our file. So if we run this, we don't get anything, right? It says open file, file text. And what we'll do next is save this in a variable. Let's say first file. And now we'll take our first file object, which contains the file that's opened, and then we'll use another method known as read, and this method allows us to read a file. So once we have the file open, we'll use the read function to read the file. So we have our file object first file that read. Now if we run it, we have the content of our file as a string. So it says this is the first line, and then new line, this is the second line, new line, this is the third line, and then we have a new line, and then this is the last line. So we are able to read the entire file as a string. Okay, so first we opened our file with the function by using the function open, and then we applied the read function to read the contents of a given file. And if we try to read our file again, the result will be an empty string. We get an empty string. This is because once we read the file, our cursor is at the end of our file, so there is nothing more to read, and we get an empty string. So if we want to read the file again, we'll have to reset the position of our cursor to the beginning of the file. And there is a method that we can use to reposition the position of the cursor, and that method is called the seek method. So we have our file, first file, our file object, and then we'll call the seek method on it. So this will reposition the cursor to the beginning or wherever you want it. So this seek method can take values 0, 1, and 2. So values could be 0, 1, or 2. So 0 is an absolute position. It means it will take the cursor to the beginning of your file. So it's an absolute reference point. Whereas if you apply 1, it means your reference point is your current file position. And then 2 means your reference point is your end of the file. So for our example, we will use 0. That means it will move the cursor to the beginning of the file. So first file.sig, and now if we try to read our file again, we'll get the entire file. So run it again, we get the file contents, and then we can use the seek position. We can use the seek function to reposition our cursor. So 0 means to the beginning. Your reference point is the beginning of your file, whereas 1 is your current file position, and 2 means your reference point is the end of your file. Okay, now that we have seen the read function, there's also another function known as the read line function. Okay, before we see the read line function, let's reposition our cursor to the beginning of our file, and let's look at the read line function. So we have our first file object, and then we'll call the read line method on it. So if we run this, we get this is the first line, then we have a new line. So the read line method reads one line at a time. So first file that read line, that's your first line, and then if we call the read line method again, we'll get the second line, since the cursor is at the second line. Now if we call the read line method again, we get this is the third line, and if we call the seek method, this will reposition the cursor to the beginning of our file. And if we call the read line method again, we'll get this is the first line, which is now it's at the beginning. So the first sentence will be read, which is this is the first line. So if we run this again, we get this is the first line. If we run this again, we get this is the second line. If we paste it again, this is the third line. Command V, this is the fourth line. If we use the read line again, we get this is the last line. Now that we are at the end of the cursor, at the end of the file, if we call the read line function, we'll get an empty string because we are at the end of the file. And if we want to read again, we'll have to call the seek method to move the cursor to the beginning of the file. Right? Great. There's also another function known as the read lines function. Okay, let's look at that. We have our first file, and then let's reposition our cursor to the beginning of our file. Now let's look at the read lines method. So the one we just looked at is the read line method. Now we're looking at read lines. So the difference is when you use the read lines method, it gives you the entire file. It gives you the entire file as a list. So if we look at the read lines method and run it, we get the entire file as a list, right? We have each line as a string, and then the entire file is enclosed in a list. That's the readLines method. And if we call the readLines method again, you'll get an empty list because our cursor is at the end of our file. And again, we can reset our file. We can reset our cursor by calling the seek method. So first file dot seek and then path 0. Great. So just to summarize, we saw how we could read a file by using the read method, read line method, and the read lines method. And we saw that we have to open our file first before we could read our file. And we also saw that we can use the seek method or function to reposition our cursor to the beginning of the line, to the beginning of our file, by passing 0 as an attribute. In the next lecture, we'll continue our discussion of reading and writing files. Thank you, everyone. Hello, everyone, and welcome back. In the previous lecture, we looked at how we can read a file once we open it. We looked at the read method, which will read our file and give us a string of the entire file. We also looked at the read line method, which reads one line at a time. And finally, we looked at the read lines method, which reads the entire file and give us a list result. In this lecture, we'll continue our discussion of reading and writing files. We can also read our file by using a for loop. And we can use this for loop to print the content of the file, each line at a time. Let's see an example of how we can do that. So the first thing we need to do is open our file. So we use the open method for that, open, and then file name, which is file1.txt. And we save this in a variable, let's say first file. And what we'll do next is we'll take this first file and then apply the for loop to read each of the contents of the line of the file, one line at a time, and then print each line. So we can say for, let's say, each line in our first file object, in our file, we can say each line dot strip. So we'll strip the file by lines. And let's save this in another variable called, let's say, all lines. And once we have that, we can print all lines. So we use a for loop to iterate through our file, and we'll strip our file at each line, at the end of each line, and then we'll print each of the lines. So if we run this, we get our file, right? One line at a time. This is the first line, this is the second line, this is the third line, this is the fourth line, and so on. So that's how we can use a for loop to read the contents of our file and print each line at a time. Last time we looked at the seek method, which will move the cursor to different positions based on the value you pass. So let's look at some more examples of the seek method. For that, we'll be using our second file, file2.txt. Okay, so we can say first let's open our file. Let's open it and save it in a variable called, so this is our second file, right? So we can say second file is equal to open, Then we pass our file name, right, which is file2.txt. And once we have that file open, what we'll do is let's use the seek method. So now that we have our second file, if we read our file, we get second file.read, we get AEIOU, right? Now our cursor is at the end of our file. What we'll do is use the seek method to or function to move the cursor to a different location. So we have our second file and we'll call the seek method, and let's pass, for instance, -2. I'll explain what this means. -2 and 2. So this basically means move the cursor 2 characters from the end of the file. So 2 characters to the left. Since I said -2, it means move it 2 characters from the end to the left. Basically that means to the left. That's what the negative means. And the second attribute 2 means it's your reference point is the end of your file. So we mentioned that our reference point can be the beginning of the file, or the current position of the file, or the end of the file. So 2 means your reference point is at the end of the file. So in this case, it will move the cursor 2 characters from the end, right? So 2 characters to the left. And once we do that, if we try to read the file again, so second file that read, we get ONU, right? It makes sense because it has moved the cursor 2 characters from the end. So the cursor was here, and then when we try to read it again, we get ONU. If we try to read the file again, we'll get an empty string because our cursor is at the end. And we can move the file to the beginning by passing 0. That will move the cursor to the beginning of our file, right? And we can also say second file that seek, let's say 3. So this will move the cursor 3 characters. So if we run that and then read the file, second file that read, we get ONU, right? That's because we move the cursor to the beginning first, okay, and then move the cursor 3 characters. So 1, 2, 3. So the cursor was here, and then when we call the read function, it reads the OU, only ONU, since it was already moved to this location. Let's look at one more example. Okay, now we need to reset the cursor to a different position since it's at the end of the line. So we can say second file that seek, let's say -4 and then 2. Now we have moved our cursor 4 characters from the end, and then if we read it again, we'll get what? ENI. So second file that read, we get EIOU, since we have moved it to this position, 4 characters from the end. So those are some examples of the seek method. I just wanted to show you about the seek method, what it does. Great. Next, we'll see how we can write to a file. As usual, before we can write a file, we need to open a file. For that, we'll be using the open function. And we'll try to open a new file and then write to it. So we'll open a file known as, so we have used file 1 and 2, let's use file 3. So file 3.txt, and then for writing a file we need to pass another attribute, which is the W+. It means write mode. So when we open a file, we'll be opening it in a write mode so that we'll be able to write to our file. And let's save this in a variable called third file. And so far I haven't created this file 3.txt, so I don't have file 3.txt. And the good thing about writing and reading to a file is that if we don't have a file with this file name, Python will create for us. The open function will create this file for us. So first it will look for this file. If this file doesn't exist, it will create one for us. So that we'll be able to open the file and then in a write mode, so that we'll be able to write to it. Okay, now that we do that, we take our file object, which is our third file, and then we call the write function on it. So that write, and then we can write whatever we want. Let's say this will be the first line of our file 3 object. So that line will be added. And if we want to write more lines to it, we can say third file that write, let's say new line, and then can say this will be the second line of our new file 3 object. Similarly, we can add more and more lines to our file. So third file that write, and let's say this will be the last line of our file 3.txt object. So now we have added 3 lines. And let's try to read our file now. So third file that read. Okay, we have an empty string. That means it's at the end of the cursor is at the end of our file. So let's call the seek function and pass 0. So now it should be at the beginning of our file. And then if we call our third file, if we call the read function, we should be able to read our file now. So we have, this will be the first line of our file 3 object, and then we have a new line there. This will be the second line, and then the last line. So if I go to my home book, there should be a new file here. Here you go, file 3 is created. So if I click on it, these are the lines that we added by using the write function. So we were able to write to our file. This will be the first line of our file 3 object, second line, and then our last line. Great. That's how we can use the write function. So just to recap, we looked at how we could read and write to a function, to a file, by using the read method mainly, and we saw that we could use the write function to write to a file. And don't forget to open your file in a write mode if you want to write to a given file. Great. Thank you, everyone. Hello, everyone, and welcome to the lecture on the map function in Python. In this lecture, we'll look at what the map function is and what it does. The map function applies a function to each element in a given sequence and returns a new sequence as a result. Let's look at an example. Let's say we have a list containing the elements XYZ, XY, and Z. And let's say we have a function. So what the map function does is it will apply. So we have our map function. It will apply the function, the given function, to each element in our sequence, to each element in our list in this example. So it will apply it to the given list, for instance, and then it will give us a new list as a result. So for instance, if our function finds the square root of the elements in our list, so the result will be the square root of each of the elements. If our function returns the value of a given sequence by, let's say, 10, so the result will be each of these elements in our sequence times 10. So that's what the map function does. Now let's see an example. So we have map, and let's try to find out. Let's try to apply a map function and then convert the elements in our list from uppercase to lowercase. So we can call the strings lower method, str.lower, and then we pass our list, let's say x, upper y, upper z. Okay, that should be good. So we apply strings lower method to this list. So the result will be, if we run this, we get x, y, and z, or all of them are lowercase. So we have a function here, and the map function applies the given function to each of the elements in our list. In this case, to each of the elements in the sequence, and the sequence has to be iterable, right? Great. So this is in Python 2. If you are using Python 3, the map function results an iterable object. In Python 2, it gives you a list, whereas in Python 3, the map function gives you an iterable. So in order to use the map function to get a list in Python 3, you have to cast everything into a list. So we have to say, let me copy that, and then cast everything inside the list. So this would be the equivalent of the map function in Python 3. So if you are using Python 3, don't forget to cast the entire map function inside a list. That way you'll get a list as a result. So that's the difference between Python 2 and Python 3 when it comes to the map function. Great. Let's look at another example. For this example, let's say we want to find the square root of some given numbers. Okay. Let's import the math module, and then what we'll do is we'll try to find out the square root of some numbers in a given list. So we can say map square root, so that will be our function, and then find the square root of these numbers. Let's say 4, 64, 25, and 81. So we know the square root of these numbers. So if we apply the map function, we get, or square root is not defined. Okay, let's from math import square root. Okay, let's run it again. Okay, now we are good. So the map function applies the given function, which is the square root function in this case, to each of the elements in our sequence. So the square root of 4 is 2, the square root of 64, 8, 25 is 5, and 81 is 9. Okay, similarly you can add some more numbers. Let's say we can add 23, run it again. So we get the result. That's the map function. And the equivalence in Python 3 would be list, and then the entire map function. So don't forget to cast it to a list if you are using Python 3. Let's look at some more examples. Let's define a function that will give us the power of 4. Let's call it power 4, and then it takes an attribute x, and our function will return 4 to the power of x. So basically, if we pass 3, our function will return 4 times 4 times 4, so 4 to the power of 3 basically. Okay, so that's our function, and let's see our function. So power 4, let's pass 3, so this will give us 4 times 4 is 16, 16 times 4 is 64, so we get 64. That's our function. Now what we'll do is we'll use the map function to apply this power 4 function to a given list, to a given sequence. Let's do that. So we can say map, and then our function power 4, and apply this power 4 function to the following elements in our list. Let's say 2, 3, 4, 5, and 6. So basically this will be equivalent to 4 to the power of 2, 4 to the power of 3, 4 to the power of 4, and so on. So when we run this, we get 4 to the power of 2 is 16, 4 to the power of 3 is 64, 4 to the power of 4 256, and so on. Okay, and for Python 3 users, cast the entire map function into a list. Great. Next, let's see how we can use the map function with a lambda function. Okay, so we'll use the same power 4 function, and in this case, let's use a lambda function. So we can say lambda x, then return 4 to the power of x. So we're doing the same thing as we did here. Instead of defining a function, we are using an anonymous lambda function. So lambda x, and then return 4 to the power of x, and let's apply our list 2, 3, 4, 5, and 6. So the result should be the same. Run it, we get the same result. So that's how we can use map function with lambda. So map function is used commonly with lambda. Let's look at another example of how we can use the map function with lambda. Let's say we have a list x and contains the element 3, 6, 9, and 12. What we'll do next is will return each of these numbers to their power. So 3 to the power of 3, 6 to the power of 6, and so on. So we can say map, then lambda, let's say y, and then return y times y, return y times y, and then we'll pass our list x. So if we run this, we get 3 times 3 is 9, 6 times 6 is 36, 9 times 9 is 81, and 12 times 12 is 144. That's how we can use the map function with lambda. Let's look at a few more examples of the map function. Now what we will do for this example is apply the length function to a sequence in a given list. Let's do that. So we can say map and then apply the length function to the elements in the following list, and let's have a list within a list as elements for our list. Let's say 2, 1. Let's have another list containing the elements 2, 2. Let's add few more list elements. Let's say 3, 4. What else can we add? Let's add 4, for instance. I think that should be good. So what this map function will do is it will apply this function, which is the length function, to each of the elements in our list. So our list has how many elements? 1, 2, 3, and 4. We have 4 elements. So when we apply the length function, the result will be a list containing. So the length of this is what? 2, 2, 2, 1. So that will be our list result. So you get 2, 2, 2, 1, right? Length of this is 2, length of that is 2, and finally length of the last element is 1. Okay, last but not least, let's see how we can use the map function with for loops. We can do that. For that, let's define a function. I'll just call it at func x, and then our function will return x cubed, for instance. X cubed. Okay, let's give it a better name. Q function. Q function of x return x cubed. What we can do is we can say for I in map, and then we'll pass our cube function, and then apply this cube function to the following elements. Let's say 3, 4, 5, 6, and 7, and then simply print I. So for I in map cube function, which we define here, apply it to the elements in this list. So for I in map function, print I. So if we run this, we get each of the elements cubed. 3 cubed is 27, 5 cubed is 125, and 7 cubed is 343. Just to make sure, we can add 10. 10 cubed is 1,000, right? 10 times 10 times 10. So if we run this again, we get 10 cubed, finally 1,000. So if we only use this map function, we get a list containing. So if we do this, we just get a list containing these elements, right? But this is an example of how we would use a for loop with a map function. How we would use the map function with a for loop. So it would be the same for Python 3. Great. Just to recap, we looked at the map function, and we saw that the map function takes a given function and applies it to the sequence in a given list, for instance, and then gives us a new list as a result. And if we are using Python 3, don't forget to cast the entire map function into a list, because the result of map function in Python 3 is an iterable object instead of a list. So we have to cast it to a list. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on the reduce function. In this lecture, we'll see how we can use the reduce function. The reduce function applies a given function to the elements in a sequence, and then we'll get the final result. And the final result is usually a single element. Okay, let's look at an example. Before we do that, if you are using Python 3, don't forget to import the reduce function from a module called function tools. So from func tools, import reduce. So if you are using Python 3, don't forget to import it. So from func tools, import reduce. This is for Python 3 users. So in Python 3, the reduce function is inside the func tools module. So we'll need to import that for Python 3. Let's see an example. So let's say let's apply the minimum method on a list containing the following elements. Let's say 3, 8, 6, 9, 7, 2, 5, and 11. So what this will do is the reduce function will apply the minimum method on each of the elements in our sequence, and the result will be a single element. In this case, the minimum of the elements in our list is 3. So the result will be 3. So if we run it, we get, the result is 2. Since 2 is the minimum of all the elements. Similarly, we can apply the maximum function on the same list, and the result will be 11. Let me paste it, run it, we get 11. So that's the reduce function. It applies a function to a given sequence and then gives you a single element as a result. Now let's look at an example of how we can use the reduce function with a lambda function. Let's say we have a list of days. Let's add Monday, Tuesday, Wednesday, and Saturday. What we'll do is we'll apply the length function and we'll find out which of these days has the highest length. So the length of Monday is what? 6. The length of Tuesday is 1, 2, 3, 4, 7. The length of Wednesday is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the length of Saturday is 8. So we'll use the length function to find out the length of each of these elements, and whichever element has the highest length will be the result. So reduce lambda, let's say A and B, and then return A if length of A is greater than length of B. or else return B, right? Let me put the parenthesis there and remove it here. Or else return B, and apply that to our days object, to the list containing this days. So reduce lambda, you have AB, 2 elements, and then return A if length of element A is greater than length of B, or else return B. So it will compare each of the elements. It will take 2 elements at a time and then compare the length of the elements. So the length of Monday is 6 and Tuesday is 7. So whichever has the higher length will be returned. That will be Tuesday, and then compare that to the next element. Wednesday has the highest length, so it will take that and then compare it to the next element. So it will do the length comparison to each of the elements in a given list. And finally, the result will be the element with the highest length. In this case, it will be Wednesday. Oh, let's run our list containing days. Let's run this again. So we get Wednesday. That's how we use the reduce function. We could have also said reduce lambda AB, return A if length of A is greater than B, or else return B, and pass our list, right? Pass the elements of our list, Command C, paste it here, and you'll get the same result. Great. So one thing to remember about the reduce function is it will compare each of the elements in your sequence and then gives you a single result at the end. And if you are using Python 3, don't forget to import the reduce function from the functools module. Great. Thank you everyone, and see you at the next lecture. Hello everyone, and welcome to the lecture on the filter function. In this lecture, we'll go over the filter function and see how we can use it. The filter function checks if a given element in a sequence fulfills a function, and if it does, it will add it to a new list. What do I mean by that? Let's say we have a list, let's say list 1, and it's equal to, let's say, 3, 4, 5, 6, 7, and 8. Let's say it has this elements. And if we have a function that will return elements if they are greater than, let's say, 5. So what this filter function does is that it will apply the function that will return elements if they are greater than 5. It will apply that function to the given list, and then whichever element fulfills the function will be added to a new list, and we'll get that list as a result. So in this case, the result will be a list containing the elements 6, 7, and 8, right? Since those are the 3 elements that are greater than 5. So that's what the filter function does. In a way, it filters our original sequence and we get a new list of elements. Another example, if our function, let's say our function returns elements if they are, let's say, greater than 8. So it will apply that function to our list. In this case, we don't have any elements which are greater than 8. So we get an empty list as a result. So that's the filter function. Let's look at some examples. Let's say we have a list containing the elements. Let's say list 2 contains the elements A, B, C, and let's add a couple of numbers, 2 and 7. What we'll do is we'll have a function that will check if the elements in our list is a number, and we'll apply a filter function. So if the elements are numbers, we'll get a new list containing those numbers. So we can say filter, and then we'll apply a strings isNum function, then apply to our list 2. So in this case, the result will be a list containing the elements 2 and 7. It says type object string has no attribute isNum. Okay, let's check. Let's go for isAlphabet. So isAlphabet. In this case, our filter function will return a list containing the elements A, B, and C, since those are alphabets. So if we run this, we get A, B, and C, right? Since those are the elements that are alphabets. So here we define the list and saved it in a variable, and then we just pass the variable here. We could have also passed the entire list, so it's the same thing, right? We could have said str that is alpha, and then pass the list, so it gives you the same result. We get ABC. So this is in Python 2. If you are using Python 3, don't forget to cast it into a list, similar to the map function. So in Python 3, it would be filter list, cast the filter function into a list. So filter, and then str that is alpha, and then your sequence of elements. So list 2 or this list. So that would be the equivalence in Python 3. Since it returns an iterable, we have to cast the filter function to a list. Okay, don't forget that. This is in Python 3. Great. Let's look at some more examples. Let's define a function that will return if a number is an odd number. So let's say define, and let's call our function odd. Then it will take an attribute x, and then it will return. So we can use the modulus function, x modulus 2. If it's equal to 1, that means it's an odd number, right? That's a simple check. So x modulus 2 equal to 1. So if we say odd, and then pass, let's say 7, that's true. If we say odd, let's pass 4, that's false. We know our function works as we intend. What we'll do next is use the filter function to apply the function that we define here, the odd function, and then pass a list of numbers. Let's say 2, 3, 4, 5, 6, 7, 8, and 9. So our filter function will return a list containing the odd numbers here. So that will be 3, 5, 7, and 9. So if you run this, we get 3, 5, 7, and 9. What if there was no odd number? Let's make this a list containing 2, 4, 6, 8, and 12. In this case, our result will be an empty list, right? since none of the numbers are odd. Again, if you are using Python 3, don't forget to cast it into a list. That would be the equivalence in Python 3. Next, let's see how we can use the filter function with the lambda function. So what we'll do is we'll have a list, and then we'll have a function that will check if the length of the elements in that list is greater than 1. And if it is, we'll get a new list. So let's do that. We have a filter function, and then let's apply the lambda function. So we can say lambda x, and then it will return length of x if the length of x is greater than 1, for instance. Then let's pass our list. Let's say our list has the elements ABC, AB, A, and B maybe. And let's add one more element, A, B, C, D. Okay. So filter lambda x, return if length of x is greater than 1. And then apply this lambda function to our list here. So it will check if the length of each element is greater than 1. So the length of this here is 4, right? So it will return this element. It will also return the next two elements since the length is greater than 1. So the result will be a list containing this highlighted elements. Let's run it. So we get a list containing these elements since their length is greater than 1. Let's look at a few more examples. For these examples, I'll create a few dictionaries. Let's start by creating the dictionaries. Let's say our dictionary 1 contains one key and element combination. So our key is A, and our value is 1. Let's create two more dictionaries. Dictionary 2, let's say our key is B. For our value, let's say 7. Let's have one more dictionary, dictionary 3, and then let's say for our first key and value combination, let's use A5, and then for our second key and value combination, let's say B and 3. So we have 3 dictionaries. What we'll do is we'll use the lambda function, and then we'll check if the keys in our dictionaries start with, for instance, A. So if the keys contain the element A, it will return that dictionary. Okay, let's do that. So we can say filter, and then we'll use the lambda function. So lambda, let's say lambda our dictionary, lambda x, let's say A in our x dot keys, right? So lambda x, and then return if the element A is in x dot keys. So if it means if A is a key in the dictionary, return that dictionary. That's what the lambda function does. Then apply this lambda function to our dictionary 1, dictionary 2, and dictionary 3. So in this case, the result will be a list containing what? So dictionary 1 has A as its key, so it will return dictionary 1. Dictionary 2 doesn't have A as its key, so it will not return dictionary 2. And dictionary 3 also has A as its key. So the result will be a list containing dictionaries 1 and 3. Let's run it and verify. So it will be a list containing dictionaries 1, right? Which is A1, and then dictionary 3. Since it has A as its element, as its key. Similarly, if I copy that, and then if we check for B, the result will be a list containing dictionary 2 and dictionary 3, since they have B as a key. So if we run that, we get B7, which is dictionary 2, and dictionary 3. Similarly, we can check for a given value. For instance, we can check if any of the dictionaries have 7 as their value, and if that's so, we'll get that dictionary as a result. We can also do that. So in these examples, we checked for keys. Now we can check for values. For instance, we can say filter lambda x, and then we can say 7 in this case, right? For instance, 7 in x dot, we can say items, and then pass our dictionary objects, dictionary 1, dictionary 2, dictionary 3. So in this case, our result will be a list containing dictionary 2, since it has 7 as its value. So let's run this, or let's make this values instead of items, since we are checking for values, right? So we have, as expected, dictionary 2 as a result, since it has 7 as a value. And we can also check for other elements. For instance, let's check for the value 1. So lambda x, 1 in x dot values. So if 1 is the value in a dictionary, return that dictionary. So the result will be a list containing dictionary 1, since it has 1 as its value, right? So let's run this. We get dictionary 1 as expected. Similarly, if we check for a value that doesn't exist, for instance, let's say 11 is not a value, right? Yes. So if we check for 11, we'll get an empty list, since 11 doesn't exist as a value in any of the dictionaries. So that's how we would use a filter function with lambda function. Just to summarize, we looked at the filter function in this lecture, and we mentioned that the filter function checks if elements in a given sequence fulfill a given function, and if they do, the result will be a list containing those elements. And we saw that in Python 3 we'll have to cast our filter function into a list so that we get a list as a result. Great. Thank you everyone, and see you at the next lecture.